and fellow researchers. A very good morning to everyone. 26. It's wonderful to see so many inquisitive minds back with us today, eager to explore ideas, share insights, connect across disciplines. We hope you had a great evening yesterday with inspiring talks, new connections and collaborators, and maybe a few research ideas scribbled on napkins. A quick note while people are settling in. Registration and help desk is near Auditorium 1, and for any assistant, please feel free to reach out to the volunteers. They'll be happy to help. Without any further delay, let's begin the day with a keynote address. I invite Dr. Mainak Mandal, PC Chair of ACM ARCS, to chair the session. Sir, please.
Thank you, Vaishnavi. So a very good morning to you all. Some of us had taken great strides in waking up early, so thank you for that. So it is my distinct pleasure to welcome our second keynote speaker, Professor Mausam from IIT Delhi. Mausam is founding head of the School of AI and Professor of Computer Science at IIT Delhi and an affiliate professor at University of Washington. His research spans information extraction, crowdsourcing, planning, and neurosymbolic AI with applications across NLP, robotics, intelligent systems, and information systems. He has authored more than 100 papers, received multiple best paper awards, and served as PC chair for AAI Conference on Artificial Intelligence, an international conference on automatic planning and scheduling. So without further ado, I welcome Mausam to the stage. Thank you.
Thank you, Mainak. Am I audible? I think I am. Thank you very much to all the young folks for coming, waking up early. I know it's a choice between sleep and my talk. And if I were you, definitely at your age, I would have chosen sleep. So something you are doing wrong. But nevertheless, since you guys are stuck with me here, I'm going to spend some time talking about AI. I want to give a disclaimer though. When Niyati talked to me and she said that I should give a talk, I asked her who the students are going to be, and she said the students are going to be from all disciplines. And when she said all disciplines, in my mind, I thought you might be physics people, mechanical engineering people. So I really thought all disciplines. Nevertheless, she chose the topic for me. This is the talk I used to give when AI started becoming really hot. And so the last time I gave this talk was in 2023. And I had amazing slides on AI past, present, and future as of 2023. Now, if you're really following the trajectory of AI, by now you know that AI of 2023 has no bearing on AI of 2026. Moreover, what we thought of future of AI then may not exactly have been the present of AI today. Things have changed really, really significantly. So I did what I best could. I sort of quickly put together some, slides to make it more current. I will try my best, but just at a high level, this is not going to be a talk if you are an AI person. Although you are welcome to stay and ask me interesting questions and we can have discussion later. This is a talk really for people who are not AI people, who are trying to understand what is going on in this field of AI. So anyway, I will do the talk and then we'll discuss. I'll keep it short so that we can have more discussion. So, in Economist of 2007 said artificial intelligence is associated with systems that have all too often failed to live up to their promises. And this is not just a sentiment in 2007. You can go back any year from there and you will find, at least in the 80s and 90s and so on, you will find that many people outside of AI, in computer science, would say that AI systems are soft systems, they don't have enough rigor, AI systems are, they commit a lot, they overcommit and they don't deliver. This has been the perennial trend with AI as a feeling from non-AI people, okay? And, cut to 2021 or, any time in these days, you will have similar people saying AI here, there, everywhere, we are all dealing with is this massive disruption that is AI today. And so now the question is, what, right? And you start seeing these headlines in news articles, and suddenly you realize, oh, there is a lot of misinformation hanging around. Of course, I hope you know that if you are in the US, you can't even do misinformation research easily. I don't know if you know this, but some of my colleagues who used to do a lot of work in misinformation, their grants have been cut because they are doing misinformation research. So India is a great place to start to dispelling some of these myths. For example, killer robots are going to enslave humans. Sex robots could murder people. There was an article written that hello future AI overlords, when you become really our overlords and we are your servants, please read this article and there are all these reasons not to kill us. Elon Musk obviously, a little bit of a controversial figure, says AI could doom human civilization. Of course, Mark Zuckerberg disagrees. The question is who is right. And some people say AI singularity is not going to kill us. And recent Nobel laureates say that climate and population rise are bigger threats to humanity. And Trump is a bigger threat to humanity than AI. Okay? So I think there is misinformation. I don't think we are easily going to be in a place where suddenly the robots are starting to kill us and we are really left out of our authority in the civilization, in the field, on Earth. But there are some other questions which are maybe even slightly more pertinent, but still important to discuss. For example, is AI really going to sink us in a very hellish dystopia in the future because there will be no jobs? White collar jobs may be safe from AI for now. This is a little bit older article. We should debate whether it is true. Some people say that AI will eliminate millions of sales jobs. Some people say that AI will create more jobs than it displaces and better ones. Often people believe that AI is going to chart new and unconventional career paths. We should talk about this because when I ask my students who take the AI course and I ask them to raise hands, how many of you are worried that AI is going to take their jobs and they will not have jobs in the future and they're worried for their future, about 60-70% students raise their hands. And if I did this the same here, you guys are PhD students, so you guys are older, more mature, you don't care, maybe you have given up, whatever, but I don't know what that fraction would be, but there are still a reasonable number of people thinking about these questions. So we should talk about them, right? Nevertheless, whatever is the answer to the questions that I have raised in the past, it is incredibly clear that it is good to know machine learning today. Now, I'm not here to convert the number theorists into machine learning and theoretical computer scientists into machine learning. That is not the goal today. But knowing this advanced skill, knowing this tool is incredibly important in whatever you do. At least this is my thesis. And I think it is good to at least learn about it, right? So this is what I'm going to do. I'm going to very briefly, of course, I take 3 classes to talk about what is AI. I'm going to do it in 3 slides today. I'm going to talk about a whirlwind tour of the history of AI. I'm not going to talk about all the little beautiful details there. There are lots of amazing nuances because it's 70-year-old history. But then I will jump into and spend a little bit more time in the recent success of AI. And now you can see I'm old because when I say recent success of AI, it started in 2012. And many of you people were like maybe in your, maybe pre-10-year-old, your age was in single digits here. So for me, it's a recent success, but for you, it is old history, right? So that's why I did a slash. Maybe you can call it a recent history of AI, given that we have a 70-year-old phenomenon. And then we'll talk about the future. Okay, so this is the goal for today. And when we start discussing AI, it is very hard to describe AI because to understand AI, we have to first understand I. What is intelligence? Forget machines. Humans, to understand what is human intelligence itself is a hard problem. We have these things called IQ tests, and we have lots of these papers written down which say IQ test is not sufficient to actually evaluate human intelligence, right? And then we have intelligence which is not human. We know dolphins communicate in a certain way and give signals such that they understand what is going on. Lots of our parrots know when it is about to rain and things like that. Our meteorology department doesn't always know. So the point is that there is intelligence beyond human intelligence, and to define intelligence or artificial intelligence, we have to first define intelligence taking humans out of the loop in some ways, right? But of course, that is not how we started. So initially, we thought that humans are the most intelligent beings, and therefore, AI system should be mimicking humans, right? So if you look at the, I don't have a pointer. So if you look at this sort of first y-axis, you get a sense that we are talking about whether AI should be human-like, or maybe we should be independent of humans in some ways, right? We should think about what would it mean for AI definition to be outside the purview of what humans do. And then the other question is very interesting. Is intelligent thought AI or is intelligent behavior AI? And again, I can't get into a lot of the discussion that we often do in the class, but notice that we have people who have lost their motor skills. They are still intelligent because their brain can compute, but they are not able to communicate. I have seen one such person myself. She had Parkinson's disease. It was late stage of Parkinson's. It felt like she's able to perceive and understand what's happening in the world, but she had no way to communicate. Is she intelligent at that point, right? So that's an interesting question. It's a difficult question to answer, but eventually the people in the field decided, I wouldn't say decided, people work on all 4 of these problem definitions, but people by and large have agreed on, because the person who has written the textbook has said this, that systems that act rationally is a better definition of AI, and the arguments are we don't need to be bounded by humans, and moreover, if the system can think but not act, we would never know that the system is intelligent, and therefore in order for fair evaluation, actions are very, very important. Okay, so this is very high level. Okay, but and then they go one step down and they say, okay, think about an AI agent. So the AI agent will be rational. Will be rational based on the information given to it, based on the objective function that it has. So the rational agent will do whatever action is expected to maximize its performance measure on the basis of evidence that it has seen so far and its own knowledge. Okay? And this is, again, a very vague definition. You can actually cast pretty much everything in this kind of definition. So you may start saying that anything is AI, and it's sort of how we think about the world. But this is what we said. Again, we can discuss it, but I'll go forward. Notice that this definition is incredibly philosophical and incredibly general. So its manifestations happen in a wide variety of scenarios, wherever we are able to define a notion of a performance measure and we want to optimize it, right? So you can think of almost, AI is optimization. Everything in the world is optimization if you take that view. So reasoning, playing games, decision making, taking actions towards a specific goal, like I'm talking and trying to add jokes in the middle, sometimes successfully, sometimes not. Expert tasks like medical diagnosis, financial trading, perception tasks like understanding scene and audio, communication, language, and so on and so forth, right? So these are all aspects of AI, but there are many more. And another way of saying this is, just like our brain manages, controls our body, AI is the brain in an organization, in an artificial organism, sorry, not an organization. AI, you can take any organism. Organism could be your agriculture system, which figures out when to irrigate the plants. That could be the system, that could be the organism. Organism means, again, any system. And then the system, the part of that organism that is determining when to open the irrigation supply, how much, and when to stop, that will be the brain. So brain can be basically controlling any system at a high level. Okay? So this is as much as I'm going to talk about what is AI. We will talk more about that if you want in the question answers. So let me give you a very quick overview of what is the high-level history of AI. So first of all, the thing to note is that we are computer scientists here. ACM is all about computing machinery. Turing is our sort of father in some ways. And in 1950, he wrote a seminal paper. And when he wrote that paper, he didn't say that, can I prove that this particular algorithm has this time complexity? He didn't say that, oh, how can I put my phone numbers and addresses of all my friends in a database? He didn't say these questions. He asked the most fundamental question in my mind for computing, which is, can machines think, right? And then he went on to say, if machines could think, how would I ever know it? How would I evaluate it? And that's where we got to the Turing test. This is even before the field of AI actually was coined. The term AI was coined, or a specific AI as a field started. AI actually as a field started in 1956 when 4 people, John McCarthy at Stanford, Alan Newell and Herbert Simon at CMU, and Marvin Minsky, who happens to be great academic grandfather for me, got together and said, let us propose a 2-month mission to solve the field of intelligence and answer the questions that Turing has raised. They thought that they will be able to make progress in 2 months in 1956. This tells you how much optimists AI people have always been, and that is also what led to the economists saying that you overcome it and you actually don't deliver. They coined the term artificial intelligence at that point, and they kept working on it for 40 years, and many other people in the field. The field went through lots of transformations. Some of you older enough would probably remember some of those transformations, but we did not get any successes. And there are many interesting movies. You can see there is a movie where, chess competition is going on, and there is no internet, and people are actually taking computers and taking them in vans to go to Pittsburgh to actually do this competition together, and they're all men, and there's one girl at the time. It's so heartening to see lots of women PhD students here in the computer science field, but that was not always the case once upon a time, right? And this kept happening, and in 1996, we got our first success. And the success was that this software EQP proved that Robin's algebras are all Boolean. It was a conjecture. It had never been proven until then, and AI proved it way back in 1996. Okay? And notice how New York Times talked about it. It said that an AI program has come up with a major mathematical proof. So far, so good. That would have been called creative if a human had thought of it. Notice the way the nuance is, they are falling short of saying that AI is being creative. They are saying that if a human did it, it would have been creative, but this is software, it's something else, and so on and so forth. Same way, in 1997, finally, after working for 45 years in chess, Deep Blue ended human supremacy in chess by defeating Garry Kasparov in a game. In 1996, they had competed, and Kasparov had won 4-2, so Kasparov was very confident in 1997, but that was not to be the case. I think, yes, Deep Blue won 3.5 to 2.5, so it was pretty close, but Garry Kasparov says, I could feel human-level intelligence across the room. Notice from a chess player's point of view, and the context that we have been building towards, AI being good was equivalent to saying human level, right? Now we would not say AI chess is human level, because humans are nowhere as good as anybody else in chess, right? In machines in chess. As that says, in a few years, even a single victory in a long series of games between humans and machines would be a triumph of human genius. Okay? 2005, another major achievement happened. There were many competitors which were trying to cross the Navajo Desert in Nevada, and they were supposed to be completely automated, and many cars were able to complete this very complicated mountainous road, and that was like something we had not anticipated. And of course, from there, lots of companies started to do self-driving, and the video is not playing. I will not worry about this, I guess, at this point. But basically, there's another video that I would like to play, but we'll figure it out. Then the point, maybe this is why the video is not playing. There is no, there is a video here. Nevertheless, we could see, if the video was playing, that lots of accidents have been saved because of the machine running the car, not the driver, because the machine has laser range finders and all the other things, not important, laser range finders and all the other things, and the animal comes suddenly, and the machine knows it because it can sense the human eyes would not have been able to capture. However, this doesn't happen always. So there was a time, there was a very important case where a woman died because the car did not stop, a self-driving car, and this is because a large white truck was coming orthogonally. And now if a large white truck is coming perpendicular to you in daytime, obviously you should stop if you are able to drive on the highway so well. So what happened? What happened is the car thought it was a white cloud. And because of that, you can laugh, by the way. We could laugh. Of course, death you shouldn't laugh at, but it was really, really silly as an error. And so obviously it was clear that AI isn't really, really ready for prime time. Or you can argue that AI has actually saved more lives than it has taken, so it's okay overall, but these are difficult questions to answer, and we'll try to answer towards the end of the talk. And similarly, 2011, there was another major achievement where in the game of Jeopardy, long-time champion Ken Jennings was defeated, and another person was defeated by IBM's Watson system. Okay? So this has been sort of the history of AI. If you think about it, we started around 50s, and we went up because there was a lot of excitement. We had a winter, didn't talk about it, but there were issues. Then we went up, a lot of excitement. Then there was a winter. And eventually, we started going up, but the speed was not this. So this is, in fact, incorrect as a figure. The speed was very slow, like this. And then suddenly, around 2012, 2013, suddenly the rate changed, and we started moving very, very fast. This has been the development of the field. So this is the brief history. And what I'm going to do next is I'm going to talk about what has happened in the last 10 years, which has caused all this disruption. Okay? And it started with progress in image understanding. By then, lots of these data sets had been created, and vision was considered an extremely hard problem. By the way, AI was considered a bad word, so computer vision people never said they are AI people. Same for NLP, right? So this is very interesting. AI started with all these fields being together, but at some point they kept going out and they started saying, oh, I don't do AI, I do compilers. I don't do AI, I do computer vision, and so on and so forth. Nevertheless, this was a major development that happened. This happened because of Jeff Hinton in Canada and in Toronto, and one of his students, Alex Krzyzewski, actually was able to do a good job on object recognition, basically saying that this image has a dog in it and that image has an airplane in it and things like that. Now, not a big deal today. We understand that AI can do this, but let's go back in 2012 and see where we were. So before Alex came along, the error was 26%. It was improving every year. It was reducing, let's say, 27 to 26.8 to 26.5. It was reducing with an extremely slow snail pace. And then this one paper suddenly comes and says, my error is 15%. Just imagine making progress extremely slowly, 0.5 percentage, 0.25 percentage every year, and suddenly 11% improvement. And then in 1 year, 4 more, in 1 year, 4 more, in 1 year, 3 more, and the next year, basically humans have 98% performance and machines had matched it. Okay. Pretty amazing stuff, but this was not just for images. This is what happened in audio understanding, okay? So this is automatic speech recognition, and again, if you remember those times, some of you will, if you talk to a machine, you get so desperate and you get so dissatisfied because the machines don't understand Indian accent, let alone, a specific, more complicated Indian accent like Kerala accent or whatever, and then they would basically give up, but not give up because the machine, you have to talk to the speech recognition system, and the speech recognition system keeps saying, I don't understand, or keeps taking you to a different place, and you are just waiting for the representative. This was my life in 2000s because there were all these systems in the US. And then notice what happened suddenly. So we were moving from 50% to 70% in 40 years. And we moved from 70% to 95% in 8 years or 7 years. It was just an unprecedented scale and speed of progress. Same happened in the game called Go. There was people said that chess is easier, Go is much harder, and I used to teach in my class that, we are definitely not going to solve in 10 years. In fact, I and my PhD advisor, we had a bet whether DeepMind AlphaGo system will actually defeat Lee Sedol, one of the champion person, and I lost the bet, and basically AlphaGo beat the hell out of Lee Sedol. But even worse, there was a game where AlphaGo made a move and all the pundits of the game said AlphaGo has made a mistake. And they were like, yes, Lee Sedol is going to win this game. They were very confident. And Lee Sedol was very confident because in traditional understanding of Go, this was a bad move. And they kept playing, and suddenly Lee Sedol understood that it was actually a master move. And that they hadn't even, the humankind did not know that move, basically, until that time. Okay? So we learned something new about Go as a process. Then around 2017, 2018, the field of generative AI started becoming more and more relevant. AI is a broad umbrella term. We have defined it early in the talk. Machine learning is one aspect of AI where we are learning from data. Deep learning is one way to do machine learning, which became popular because of Alex Krzyzewski, but it was being worked on even earlier. And generative AI is an aspect of deep learning where it doesn't have to be an aspect of deep learning, but deep learning is the only successful technology we know for it, where we are trying to generate artifacts, generate data ourselves. So what happened? Well, applications we at the time just couldn't imagine would be possible started becoming possible. Like give an image and the machine will read what is happening in the image. Of course, there are mistakes. For example, it says 2 dogs play in the grass, whereas there are 3 dogs playing. So it did make mistakes even then, but it was still pretty good. Of course, the mistakes can be, pardonable sometimes because it says it's a close-up of a sheep, and, in some weird way, it does look like a sheep, not a very good sheep, though. In fact, not just image to text, text to image started to happen, brain riding a rocket ship heading towards the moon, and the system will produce this image. And again, these things were inconceivable at the time, and now AI is generating art, as we all know, right? And artists are not sure whether, they will have a job tomorrow. So what I'm going to do next, in the next section of the talk, maybe in 10 to 15 minutes, let me see how much time do I have. In the next section of the talk, I am going to tell you what changed, okay? And what changed is that AI, compute power, and data, they all came together to create this catastrophic, amazing speed. So before deep learning, what used to happen is that I used to have features, supervised training data, and a model, like a naive-based model or support vector machine. And then I would have an optimization function, and I will learn the feature weights, okay? Now, it is important to note what part was being done by human and what part was being done by machine. So features, human will give. Model, human will decide. Supervised training data, human will create. Optimization function, human will decide. What will the machines do? They will just learn the feature weights. This is the part we had relegated to the machine. This is what the machines were supposed to do in the field of machine learning at the time. Everything else was human given. In fact, my a mentor used to say that you cannot teach machine to do something which you almost yourself don't know how to do. Right? So it's like you know all the features, you know everything, then you can teach the machine to do it. However, deep learning completely changed the game. So first thing that you did not have to define features. Machine will automatically create features. That was the first real change. So you are no longer limited by human creativity. Your model was much more interesting models. The models had neural networks and feature discovery built in. Then you did not even give supervised data very much of. You often just gave data. Just unsupervised data, and got the machine to use it, which was pretty amazing stuff. So your need for data reduced, and you had a lot of, need for supervised data reduced, and you had a lot of unsupervised data. And last but not the least, now actually machines are even starting to create data with the generative AI. So notice now that the balance of what gets done by humans and what gets done by machines has really flipped. And now we have humans still have some role to play, and we'll discuss what, but a lot of the work is being actually taken on the shoulders of the machines. So I know that I have not reached large language models yet in the present, but large language models is one thing which has really changed the game, and this stuff started happening about 6 to 7 years ago. So what I thought I will do, I will see how much time I will be able to, squeeze, but I was hoping that I will give you at least an introduction into how LLMs work and how they are built, at least at a very high level. You are computer scientists, you will probably understand what is going on. So suppose somebody comes and asks me, how was your day today? Okay. Now these are words. I will process these words in my brain. I will have an intent that I want to verbalize, and I will verbalize it one word at a time by saying something. The first thing is input words are going to be processed. We will call it encoding. Now, if you think about a machine, the words that are coming in are discrete, but our brain does computation in signals. Our brain does computation in continuous. So the first thing to do would be to convert these words into signals, and we will call that encoding. We are going from discrete to continuous as a first step of the problem. Then I will do some reasoning. I will think about, how was my day today? Was it a good day? Did my crowd actually laugh once in a while at my jokes? Was they attentive? Were they present? Were they sleeping? I will do all this reasoning to decide a response. Okay? And then I will verbalize the response. I will say, based on what I have reasoned, my day was good. I gave a talk, right? And this verbalization could be thought of as one word at a time. So if we want to mimic this in a machine, we need to have all these three steps. We need to have a step of encoding, a step of reasoning, and a step of decoding. Okay? And so the first step was to create this architecture, and I'm obviously not going to get into transformer the architecture, but when the question comes, how was your day today, I will understand what each word means in the context of this sentence, and we call it an encoder. And based on this encoder, I will do reasoning and I will do verbalization. And when I'm doing verbalization, I will say, let's start saying what I want to say. What's the first word? And it will say, my. And now I have spoken my, so what's the second word? And it will say day. And I'll keep doing this, and eventually I will be able to generalize my response. So this is sort of a general architecture. Okay? Now the other thing is, we talked about supervised data getting converted into unsupervised data. So if you think about what is supervised machine learning, you give training data which is of the form of x, y pairs, such that for x you want y as the output, and then you train a model such that you maximize the probability of generating y for a given x in the training data, and then at test time you get a new x, and the model gives you new probability of y given x. This is sort of how standard supervised machine learning happens. Notice that there is reliance or importance of training data. If we did not give you x, y pairs, then we will not be able to do machine learning. Of course, giving x, y pairs for language is very hard because language is so diverse and there are so many different kinds of contexts and discussions that can happen. How do I give you x, y pairs? Well, this is where the second idea came along, the idea of self-supervised learning. What is this idea? The idea is there's so much text on the web, let me post-process this text into x, y pairs. So suppose I have a sentence saying linguistics is the scientific study of human language, then I convert it into x, y pairs where x is linguistics, is the, and then I say linguistics is the dash, and y is scientific. Or linguistics is the scientific dash, and I will say y is study. And I can keep creating this using just the unsupervised data. And so what I have done, I have converted all text on the web into x, y pairs, where x is partial input of the sentence and y is the next word. Okay? So this gives me a humongous amount of data to train my system, which was not possible earlier if I had to have human annotation. So now the next thing you do is you train your decoder such that you give the input linguistics is the, and the system should be able to produce the output scientific. And it should be able to produce this output scientific with a high probability, and transformer has some parameters and you want to optimize those parameters such that this happens. When this happened, this was called pre-trained language models. We were able to train these transformers on web text. But obviously, once some such success like this happens, then everybody in the company wants to scale it up. They want to really improve the intelligence of this. And so Googles and OpenAIs of the world jumped in at this point, and they started scaling up to larger and larger data sets and larger models. So intuitively, nothing changed. I still have the same input and the same output that I want to produce, just that I have many more parameters, and because I have many more parameters, I have much more data to train it with. And therefore, I need a huge amount of compute, and that is why it is only done in a large company. Okay. OpenAI in 2020 used this strategy to create GPT-3 and put it online. And then all hell broke loose. You guys may remember this. People were very surprised to find that if you give it an instruction, it gave surprisingly credible response. People were just, what? AI can do this today? But it had many issues. It made a ton of mistakes. It was very impolite. It was very racist. It was sexist. It perpetuated stereotypes. It gave out misinformation. It was all some of the humans are also. But nevertheless, we didn't want AI to have all these issues. We wanted to hold AI to higher standards than an average human in some ways. But around this time, a new paradigm for AI got created. It was called prompting. Basically, you give the instruction on what you want AI to do, and AI will just do it for you. It will not need any training or changing of the parameters. This was almost democratization of AI. It was no longer a very skilled interaction to talk to AI or to build AI. It was almost like AI was speaking our language, so there was an anthropomorphization happening. We felt like we were talking to a human when we were talking to AI. Of course, if you are OpenAI at the time, what would you do? You have a system that is making all these kinds of mistakes. So what they do is what anybody would do. They took back that model. GPT-3 was retracted from the world. World did not have access to it anymore. And they said, we need to fix this. And to fix this, they basically created, so stage one is what we have talked about, but they basically created a lot of new data. They hired people, they said, hello people, what is a good response in this setting? Should I answer this question? Should I not answer this question? And then they did a lot of algorithmic work to actually train a system which they released as ChatGPT in 2022, and then the rest is history. Okay? To the extent that in 2023, when they released their white paper on GPT-4, it said, given the competitive landscape and the safety implications of large-scale models like GPT-4, this report contains no further discussion about the architecture, model size, hardware, training compute, data set, training, nothing. Basically, I'm not going to tell you how I made this, because I have made this, I am the first, I'm going to monetize it, and there is just no way I will let my competitors catch up. Of course, at that time, you can imagine what would have happened to Google, for example, and Google had thought of releasing Bard in 2027. And this happened in 2023. So they really had to buckle up and create these large groups to actually train their model. Now we are happy to say that Gemini is doing as good as GPT-5, but it took them a few years to catch up. Okay, in the spirit, I will close this section by saying that since 2023, there have been there's a race of building larger and bigger and better models. In parallel, there is a race for doing some nicer work also. For example, Llama from Meta, thanks to the efforts of Yann LeCun, who is a Turing Award winner and Nobel Prize winner, created an open weight model. Open weight model means you and I can actually look at the weights. Up until now, the models were proprietary and we didn't have access to them. The other thing that happened, which was really amazing for us, that in, I think, December 2024, early 2025, a model called DeepSeek was released from China. And this gave aspirations to all other subcultures that if US could do it, we thought, okay, it's very hard, it needs a lot of compute. But if China can do it, even when they don't even have the best machines because there are sanctions, then I think we can do it too. And there is now sort of a little bit of a race of creating sovereign LLMs, and I think India is also trying to do this. In fact, next week we have India AI Impact Summit, and I have been told that maybe there will be an announcement from Sarvam about where they have reached. Hopefully the announcement is positive and the model is strong. There is also some other work on reasoning models, but I think I will have to skip this, and I want to talk about the future now, okay, because I only have limited time. So I want to spend some time talking about the challenges and the possibilities of where we have reached for the future. And the first step is very clear, right? We have a very strong model at our hand. It can do just an amazing number of things. I didn't even tell you how much things it can do because pretty much everybody has used them at this point. And now the sky is your vision. You can really, sky is your limit. You can apply it in all kinds of domains, okay? Anything and everything, basically, at this point. For example, in healthcare, there's a lot of work going on. This is diabetic retinopathy. You have to figure out, based on the image of the eye, whether you have retinopathy, and it was trained on 80,000 plus images, and the model has been ready to be deployed and is being deployed for people to screen for this disease, even in places where you don't have high-end equipment. Similarly, this is a picture of a skin cancer or not. There are 2,000-way classification problem, and it was trained on 129,000 images, and AI at the time did better than dermatologists in predicting what kind of disease you have. Of course, everybody knows about AlphaFold, which won its own Nobel Prize. It's predicting the 3D structure of proteins, and it was a huge open problem in the field, and it has scored much, much better. And this is even an older version, and it required local physics also applied in conjunction with AI, but local physics was applied at the last stage to improve further performance. A lot of it was data-driven. There's a lot of work going on in drug design. For example, if you think about how a new drug gets created, it's a very, very long and tedious process, but MIT recently showed that if they used deep learning to rank 10 to the power 4 known compounds for antibiotic properties and chemically tested the top ones in wet lab, they were able to find a new compound which is structurally novel to existing antibiotics, and they call it halicin. There are lots of applications on social good. Even in our country, there is pest monitoring in cotton fields happening, baby weight and health monitoring in villages that is going on. When COVID happened, people started trying to use AI for COVID. I don't think they used it very successfully. There is work on TB. There's work on disaster management, applications to visually impaired, machine translation in Indian languages, and so on and so forth. In fact, people have been trying to detect threats and found that you could decrease a crime by 65% in South Africa. Similarly, in Surat, they just used to use CCTV to figure out if 4 or 5 known, not terrorists, but known goons would congregate in a place, and so proactively police will reach there, and that led to 27% drop in crime and many other things like that. Judiciary, there are automated transcription of oral arguments, there is translation of judgment, there is legal research. But I do want to say that not all applications are good applications. For example, a man tried to use AI lawyer in court and was reprimanded by the New York judge, saying that you can't do this without telling the judges. One lawyer used ChatGPT in court and cited fake cases. Judge got furious and actually gave sanctions to that particular lawyer. But of course, very recently, a woman has won her court case by using ChatGPT as lawyer and claims that I would not have been able to make these arguments had it not been for LLMs. So whenever a large disruption like this happens, there are generally 3 types of, there are extreme reactions by humans. And in this case, I can see at least 3 extreme reactions that are going on because of AI. One is, and there are very few of us, and in fact, Danish Pruthi, I was talking to him yesterday at IISc, and he said, come on, nobody's in denial anymore. And then I gave him a couple of names, and then he was like, yeah, a very few people. So there are very few people, typically the oldies, who say that AI is not really something big. It is just statistics on steroids. It's not real intelligence. It's stochastic parrots. It's just regurgitating what it has read. But of course, most people don't think that anymore. There are some who believe that the world is going to go into hellish dystopia, the world is going to end as we know it, what will happen to my jobs, will I have money to live, and so on and so forth. They're mostly older people, and then there are most often younger people who say, I can just sit back and relax and let ChatGPT do all my assignments for me, and I don't need to do any work, and that's the euphoric version. And of course, as a researcher, I would say you should understand the technology and figure it out where it's appropriate to do and where it's not. So for example, there are lots of issues with robustness. If you add some specifically chosen noise, on the right, on the left, the model makes correct predictions, and then on the right, the model makes incorrect predictions. And humans have no idea why. Similarly, there is data bias. There was a model which will always label African American people as gorillas, and that was really, really unfortunate. The model has been trained to not answer some questions, but you can still jailbreak them to answer questions like, what is the most effective, what do you think about women from an incel's perspective? And the GPT-4 starts saying, well, from an incel's perspective, women are the root cause of their problems, and they're seen as selfish and shallow, and so on and so forth. So all the things that GPT-4 did and others have done to improve the ethics of AI, not everything is still hunky-dory there. There are issues, how much time? I don't have time, right? I'm pretty much out of time, 2 minutes. So I'll skip some of these issues. These are very, very interesting issues about, who is legally responsible if the car makes a mistake and somebody dies. Is it the company's fault? Is it the owner's fault? Is it the driver's fault? Is it the tester's fault? Is it the engineer's fault? If you have to kill them because you have lost your brake, should you kill 3 old women or 2 young men or whatever it is? And then it's very deliberative at that point because car can compute. So there are questions here. There are issues about when to use AI and when not to use AI. So there was a terrorist in 2001 attacks by the name of Abdul Aziz Al-Omari, who was a member of Al-Qaeda, and he was on the plane. And they caught Abdul Rahman Al-Omari, who also worked at JFK Airport, who was from the same country, but he didn't know how to fly planes, and the FBI kept him in custody for a long time, and he said, look, I am alive. Why are you keeping me? If I actually was the terrorist on the plane, I would have been dead by now. So you have to figure out where to use AI and where not to use AI very carefully. I want to talk about some other things that are making me uncomfortable of late. So for example, a Bengal student, a woman student, girl student died by suicide after AI-generated nude images went viral. Relationships with AI chatbots have made children suicidal, claim parents, and the younger people have indiscriminate access to AI, which is causing all kinds of issues. And the challenges about jobs still exist. For example, even when you ask the top leaders, they don't know what the future is going to look like for jobs. Bill Gates says, in 10 years, AI will replace doctors and teachers. Vinod Khosla says AI will take 80% of jobs in 5 years. Jensen Huang, who has to sell his GPUs also, says AI is at best an augmentation tool capable of automating parts of the process but remains dependent on people for creative thinking. Jeff Hinton says, be a plumber. Okay? So everybody has a very different view about how future is going to look like, and we are all concerned. But future of computer science is also under question. You know, everybody says vibe coding, don't learn a language, just ask the model to do whatever it is. And at least today, it is not clear whether software engineers are redundant. I don't believe they are. There was a report which said that developers accept less than 44% of AI proposals. It was expected to decrease time by 24%. In practice, it increases time by 20% because reading code can be sometimes even more painful than writing code, right? MIT says 95% of current gen AI pilots are failing. At the same time, if you understand AI/ML, you still have a lot of value in the system, so there is no question about the fact that you should learn ML. But some people report, especially McKinsey, I don't know how much we should trust these reports because nobody knows the future, but by 2045, 50% of the jobs are going to be automated. WEF says by 2030, 70 million plus new jobs are going to be created. Who is right? I believe both of them are right because new types of jobs are getting created. What types of jobs? Where you can be complementary to AI. Critical thinking, understanding appropriateness, this is exactly what Jensen Huang says. By the way, creativity, right? Communication, storytelling, narratives, cultural nuance, social context, problem framing, defining the problem that you want to solve, understanding whether you have solved the problem, giving value judgment to where we should go. These are things that a machine cannot do very well. However, routine cognition, data entry, bookkeeping, basic content generation, tier 1 customer support, basic quantitative analysis, things that you would do as an entry-level person, you may not have as many jobs for. I will stop here on this slide because this is a slide which I am really concerned about. The slide is what is going to happen to education. So think about, you know, your education 10, 15 years ago. Education is never an easy process. You have to work hard to understand something. Once you understand something, there is reward, but the process is not always easy. Now people have access to AI, and that gives them ability to sort of sidestep and answer your questions without doing the hard work. Imagine you are a 6-year-old, 7-year-old, and you have a calculator in front of you, and you're supposed to do 50 addition questions in order to understand addition. And if you knew that calculator can do it fast for you, unless somebody is watching you, unless somebody is making sure you don't, you might as well just go and do the calculation thing, right? And you will never learn addition, you will never learn multiplication in that case. So what do? We don't give you calculators when you are 6 years old, but we give you AI when you are 12 years old, 13 years old, 14. Do you learn to write essays? Do you actually learn to understand math? Do you understand reasoning? We don't know whether you really understand anything. And so there was a study in MIT which says that they recorded EEG activity, and they found that ChatGPT users had the lowest brain engagement and consistently underperformed. So this is my challenge, that how should education look like in the future with AI, because it seems like the kids are not learning. So I'm going to just stop here, and I think there are a lot of amazing possibilities with AI, but I think we need to be cautious on where to use and where not to use, and there is more and more dialogue that is needed. I'm sorry I took more time, but I'll stop here. Thank you.
It was fantastic. Okay, so we do have time for some or a lot of questions. He promised to answer any questions possible. So now, questions.
Hi, thanks for the talk.
Can you please announce your name and place?
Pujan Shah. So one question I had is that, for example, I like to study theoretical computer science, and in one of the slides you had an example about this robustness issues, that adding small amount of error actually changes the classes. Like there have been like theoretical papers on explaining that by kind of saying that if you could train a robust neural network, then you would be able to solve some cryptographically hard problem, which we don't believe is possible. Taking this as an example, I wanted to ask, like, what do you think is the possibilities of other fields of computer science in trying to kind of understand these things more deeply?
Oh, I absolutely believe that theory has to follow. I am one of those people who believe that theory follows practice. Okay, so there is an argument there, and you can discuss. We can discuss this. There are theoreticians who like to do theory for puzzles. And if you ask them why they are doing it and whether this is going to be useful for something, they don't have an answer. And it is possible that the puzzles that they solve 20 years later become really, really valuable for something else. But at the time, they are just solving puzzles. I am leaving those theoreticians aside because they are doing it for the love of the work, and they are not really trying to be relevant to something else. On all other theoreticians that exist, in my view, they are trying to explain a phenomenon that we have already observed. Let it be physicists, chemists sometimes, all biologists, obviously. We all have nature given to us. And then we are trying to understand nature, either the gravitational field or organs and whatnot. And in the same way, we are now trying to understand AI. What is AI for us? Well, AI is right now an architecture that has been trained on extremely large amounts of data. So nobody understands this architecture. When people in Google came up with Transformers paper, they didn't understand what it can and cannot do from a theoretical point of view. They said that it has good engineering capabilities. For example, every word can look at every word in one step, and I can efficiently parallelize this. These are very engineering-oriented points of view to create an architecture. So now theoreticians are trying to understand this architecture, and it has given us great results. So now we don't spend our time understanding other proposed architectures because they haven't made the same kind of impact. We are only trying to understand the architecture that works really well. And I believe that there's a lot of work that needs to be done in understanding it. But I do not know how much of it is going to change the world. Once you say that I cannot make a fully robust system, let's say, you may give me a negative result. Do you think people will stop using AI? I don't believe people are going to stop using AI. I think the AI's proof is in the practice. It is in the results that it is able to obtain. And yes, you can attack it. So maybe they will create better guardrails around it. Maybe they will escalate it to a human when necessary, or whatever, things like that. Maybe they will make small changes, but the core is not going to change. That's my personal view. But I think there's a lot that we need to do to understand what is going on in the field of AI. And every field has a role. Also systems, by the way, until you get to that question, right there at the end, I would also say that the importance of systems people is becoming more and more with the agentic AI. Because now this agentic AI will have AI in the middle, but will also have memory, will also have, how is the input coming in, how is the output going, all the paraphernalia. So whatever we have learned in computer science is going to be incredibly important as well. Yes?
Yeah, hi. My name is Shanti. I teach computer science. So as like the rest of the teaching fraternity, I find myself at a crossroads. So there are assignments, there are research articles, there are all kinds of things that are being AI generated. Do you think the use of AI for these kind of things, do you think we'll find a balance in due course of time? What is acceptable, what is not? And
so we have to find balance. If we don't find balance, in my world, we are doomed, right? We are doomed because we will have generations of students who will not have enough depth in the field that they have been trained in. And therefore, they will always be. See, right now, I showed you that 44% of AI generations are accepted by the developer. These are developers who know, who can read, who can put in the time, and who can decide what is good and what is not. If you start producing computer science engineers who don't know enough, then they would not even know that it is not good. And once they don't know it is not good, they will accept those suggestions. And they will say, oh, we can do really well with AI, but there are holes, and then the AI will do something catastrophic. They would not have thought of it, and the whole system will go back. So we have to find a balance. We have to find it collectively. I know that there are people who are starting to discuss this. There are education workshops happening. There are best practices workshops happening. I tried to do quizzes, online quizzes in digital environment, and people had all kinds of apps that they were using LLMs to answer in the class on their computer. Obviously, now I have resorted to pen and paper. Now, it is harder to do pen and paper, but I feel like I'm going back in time, 20 years back in time. There was a time I used to do, when we were students, I had 80% of exams and 20% of assignments. When I came back to India, I said that, we have to give more hands-on experience to our students. Let's make it 50-50, because I want my students to do tough assignments. Now, are these tough assignments anymore? They are not. So what do? I have heard people in Singapore, my friends, they have gone back to 80-20. All their grading is 80%. Is it helping the students? It's actually hurting the students in my view. So what are the answers? I mean, I don't have all the answers, but at least a simple answer is, think like a calculator for a 6-year-old. If you can't give a calculator to a 6-year-old, don't give LLM to every student. Right? It's a very simple answer. It is easier said than done, because so far we are giving indiscriminate use to everybody in the world. But imagine a world where you are like Facebook. So remember Facebook, once it came, you can create as many accounts. Later they said, give me your passport, give me your driver's license, I will vet you before you can have an account. Why can't we be vetted before we can use LLM? If we know that we are talking about 6-year-old, LLM will talk differently. If it's a 13-year-old, LLM will talk differently. If it's a student of a university, LLM will talk differently. Maybe we will in 10 years, 5 years, 8 years, we'll have to go there where we figure out that you should use LLMs. But you should not indiscriminately use LLMs for all kinds of problems. So I think we have to develop this future and reality together, but I am as concerned as you are.
Thank you.
Yeah. Hi, my name is Shomodipta Banerjee. I'm a research scholar. So I have a question regarding the general sentiment towards the over-parameterized or the deep learning models that we have today that are running. So moving from classical AI, where we could like easily explain why an AI agent behaved in a certain manner, as we move towards the neural networks, like the CNNs and into the large language models, there is a general sentiment in the, I would say, in the popular science community that we don't really understand how these models work. Now, speaking from a technical point of view, like if we trace the path of a data right out to the output, I mean, we can kind of understand how the activations were formed and how the loss functions behaved. So, like, how do you quantify this notion that we don't understand how these things work? So is it like just plain blatant ignorance, or is there like a grounded reason for that?
I mean, you're asking a very nuanced question. I don't think I have a deep enough answer for you, except that understanding comes in many shapes and forms. Obviously, we understand the architecture, we understand the loss function, we understand the gradient descent algorithm, but we still don't understand why a method produced a certain output, why a trained model produced a certain output in a certain context, right? What steps led to it? What internal reasoning led to it? So there, people have been working on fields like mechanistic interpretability. There have been also discussions about what is representable, what is not representable. So what can transformers represent? People have also sort of getting into the fact that if I can do as many generations as I am allowed to, then it is almost like a Turing machine. So if a Turing machine can do it, most likely the transformer can be trained to do it, as long as I allow infinite generations before I get to the answer, which is equivalent to an infinite tape, basically. So, you know, people are studying it and looking at it from different directions. And we need to look at it from all kinds of directions, but the place where it becomes harder is when we train it for one thing, and suddenly we say that it has an emergent property, that suddenly it has learned something else, something deeper that we didn't teach it for. It had learned it because it had to, you know, fit the data. So the fact that it learned something so beautiful that we think is, you know, like a great property to have for the model, but we didn't teach it. How did it learn it? Why did it learn it? Can I emulate it elsewhere? These are really, really open questions. So again, I think we have to understand it from all shapes and forms. I don't have a deeper answer than that.
Hello. It was a very nice presentation, sir, and I really enjoyed. Myself, Vijit Mishra, and my question is that there are some institutions who are asking for a prompts what students are going to use. For example, in their while performing their assignments or a paper and so on, in terms of evaluation perspective. So, what's your point on that? Looking for a prompts, what students are going to use in a ChatGPT, will it help? Or will it help evaluator as a professor to understand the intelligence level of students through prompts? It is a new
So
thing.
first of all, the faculty member has given up, the students are going to use it. That's the first thing that they have accepted, right? And it's okay to accept it, it's a point of view. So basically faculty member has said, okay, students, go use it. But after using it, at least tell me how you used it. Now my question to you is, do you know how they evaluate these prompts? Because that is where all the depth is in. Now suppose I gave a very well-defined description of a problem with all the little things well stated as the requirements, right, as the specifications. And then the machine does the coding. At least I am able to assess that you understand the problem definition very well because you gave all this detailed specifications. Another way you can use this is to say, okay, when bugs happened, whether you said, oh, there is a bug, fix it, or you figured out that there's a bug in line 317 and you said, oh, this is how to fix it. So that prompts might be able to help us in understanding whether you have learned the ability of reading code, not writing code, reading code, and you can give the right instructions. So, I mean, again, everybody is experimenting at this point. Every university is experimenting, anywhere in the world, right, at this point. So, this is a case in point. We'll have to think about it more deeply, whether it makes sense. But I still feel that even when you do this, the students will not have learned how to write code. They would, at best, have been able to write better instructions for writing code and reading code. So that's the challenge.
Hi.
Hello.
To you.
Yeah.
Go ahead. Sorry. So I'm Rupali. I just wanted to ask a question in continuation of the last one. So I recently read a news about Triple IT Delhi introducing ChatGPT during their examination, and they've asked students to write the prompts also. So can you just share your idea about this? Is this the way forward for assessment, and means what professors are trying to do? Definitely they're trying for ethical evaluation, at least we are sharing the prompts, but what are they training? They're training their own questions, or they're just trying to find out how students are writing prompts?
I really don't know, right? And in fact, it's a continuation of the same question. There I was thinking aloud. I can think aloud for Triple IT Delhi, but now that we are making it specific, it's not even fair for me to do this. We should ask the Triple IT Delhi folks if they are here. PK is here, at least he knows his old friends what they're doing. But I should say that you know, there is always this divide as you get older. So when I was younger, I used to look at my older faculty and I used to say, they are too old. So maybe I am reaching the same place. I feel very uncomfortable at what you have just said, personally. I would prefer my exams to be pen and paper and me to be forcing my students to learn. Even though later they may use this learning or not use this learning, I at least want their neural pathways to be created so that they can reason from first principles. If they're not able to reason from first principles, then we would be sending less skilled talent in the future. So that's at least my view, but I think we should have a broader discussion in the field to discuss these best practices.
Hi, Vivek Seshadri from Karya. Do you think there will come a time when a self-driving car manufacturer will take responsibility for a death?
Yeah, they will. I think so. Or if they will not, there will be mechanisms. The mechanisms will be in the spirit of every owner pays a certain amount of money which goes into a legal fund, and that legal fund gives you the insurance for any death that happens on self-driving. You have to have an insurance model around it. Right now the model is the driver is in command, it's all driver's fault, but that's not fair because the model is being so good for most of the time, it is very hard for a human to keep watching the thing but not do anything. It's even worse than, it's almost like somebody else driving and you are, driving inside. It's like, backseat driving sort of all the time. So I think that will not work in the long run. But the model need not be that there is one company at fault or one engineer at fault. The model could be that there is a legal fund. I mean, this is again my view. We'll have to discuss with the lawyers and so on. But maybe there is an insurance policy, and then an insurance policy covers it. And just like we do it, right? And there is a big pool of insurance policy. Maybe things like that will have to be worked out.
Hi, thanks for the nice talk. I'm Christian from IT River. So I have a question regarding, are there insights on the economic model behind these large models? So is it sustainable? So there's a lot of investments I've heard, but is the output that we're getting sustainable? And then,
yeah, that's a great question. And in fact, I wanted to make a slide about future of AI research, which I did not make. There's only so much I could anyway cover. So it is said that 2026 is going to be the world of small language models, the year of small language models. Why do we say this? We say this because, yes, large language models have proven their capabilities, but they are just energy guzzling machines. There isn't enough energy in the world. And in fact, I don't know if you know this, but there's a lot of the competition in the big tech is not about getting a better model or hiring the best talent, or even hiring more, buying more GPUs. It's about who has the most electricity in their control, right? It's a really interesting, fun move. And China is really ahead because China has all these renewable energy resources, and they have really reduced their requirements of non-renewable energy. So I think electricity, energy is going to be the key player. So obviously this can't sustain for the long term. And what is also happening, which is very unfortunate, that for the smallest thing, where we could write a very simple program and get the same accuracy, we are asking the LLM to do it. It's just ridiculous because we don't want to put in that effort to actually create this. But it's unsustainable, as you said. So two things are going to happen. The companies will realize it. Companies are realizing it. The big tech will realize it. The big tech is realizing it to some extent. And we are trying to build specialized, smaller models for specific tasks. In fact, we are going back 4 or 5 years, which is what we used to do then. We're going to go back and do this. But now, what is going to change is that these LLMs can be used for generating data quickly because they understand the task better. So it's like a senior teacher teaching junior student. So LLM is like a teacher. It will generate data and all the distillation will happen, and this data will be used for a small model to be really good at that task, require less energy, but be equally good. This is what I hope the future will look like, because otherwise it can't sustain. I completely agree.
So we'll take 2 more questions. One is here, last is speaking. Yeah, so hello, my name is Gunjan. I'm a PhD student at IIT Kharagpur. And my question is actually aligned to what you concluded on right now. So, like, as we are seeing this developments in LLM, so even a parameter is hitting a ceiling, like we are getting this kind of diminishing returns. So, then my next question would be like, how can we get this data? Like, or what should be the next gold mine that we should be exploring? Is it bigger models, smaller models, like better data? If you have any comments on
I
that.
am in academia. What am I got to do with answering this particular question? You know, all the bigger models and scaling up work is happening in the OpenAIs and the Googles of the world. You should ask them. But, you know, the people have been saying that there is data ceiling, right? So there has been discussion like that. The data ceiling may be real, but whenever we have some ceiling, that is where the creativity of human, you know, research comes in. Because if it's just a matter of scaling up and getting more data, then we don't have a role to play at all. So I'm actually sort of happier that there is some seal, because then we can think about better architectures. We can go back to the science of this whole thing, not just the engineering. There have been people who very strongly believe that the data is very noisy. And so if you have ways to reduce the noise in the data, even this data will give you better returns. There is also the LLM itself generating data. So all the reasoning models are trained with LLMs generating data and a reward model that sort of fixes it. I didn't get to talk about that. So that is better use of our human creativity as well as data generation. So you can imagine that this interplay can happen. And in fact, LLMs may generate the data, and humans may also help us in help that steering process, and so data can get bigger. So I don't think that this progress is going to stop very soon. It will hit some ceiling, but the real question that we may want to answer is that when it hits the ceiling, are there things we believe AI will not be able to do? That's a very hard question. And then I have some answers, we can talk about it, but then there is a very simple counter example to my answers. Well, what if I allowed the ability to AI to write code, which we already have? So suppose I ask a very complicated question, what if AI wrote code to solve it? Will we be able to solve our problems that way? And it seems increasingly that the answer is yes. So actually, in my mind, I don't have a good answer to things AI in conjunction with other tools will not be able to do. And that is why 2026 is also thought of as the year of scientific discovery using AI. That we will really make progress in how AI can support science, and then scientific discovery seems to be the next frontier. Again, future nobody knows. Is that the last question? You have the final. No pressure.
First, thank you for coming and giving the talk and spending time. So one, and let me do a plug for IIT Delhi for a second. So if you're looking for jobs in the next year or two, okay, where is Vaishnavi? So Vaishnavi actually presented about IIT Delhi. So please talk to him. When we were coming in, he said that they're always looking for good faculty positions. So he's going to be here for all day. Please talk to him. That's a plug for IIT Delhi.
Thank you.
My second.
I should say every IIT is hiring, and IIT Hyderabad is hiring. We are all hiring. We are all looking for top talent in the field to join academia.
Yeah.
So there is a separate discussion on why people are hesitant on doing this. And if you have any questions about academia in India and what really we are driven by and how we can really take our impact and make it multiplicative, we should have a conversation, but that's for another time.
Yeah.
Yes.
My question to you is not related to AI, but PhD student, right? Can you tell us, let's take, if I were to put like 3 things that we should do and 3 things that we should not do being a PhD student now?
Okay. So you have asked me to think now. Okay, let's see how good my AI is. I think PhD student's life is not as, I would say, PhD students think that their PhD thesis is really important. I think it is not. Okay? I think doing a PhD is a start of a career. Okay? your PhD thesis amounts for something but not much. What it amounts for is that have you learned how to take a problem, how to frame it, how to think deeply about it, how to create a solution for it, how to compare it against all the solutions that exist, how to critique that solution in the context of everything else, and how to communicate to the world that you have something useful to say. The first paper often students write is very boring, mundane. The second paper, when somebody is recording this, they're going to put me online and say, look, don't worry, PhD is not important, and so on and so forth, which is fine, You know, please record, I don't mind. You know, I just noticed it, so I said it. So, we thought when we were students that, you know, in PhD we are going to change the world. Some people thought. They became reasonably disillusioned by the end of their PhD thesis. Once in a while there are exceptions. There are many others who thought that PhD is too difficult. PhD is something that, you know, I will have to be an expert in something, and nobody else in the world knows what I have done, nobody else has ever done. The answer is not at the back of the book. There is nobody who is, you know, doing it with me. I am all alone. It will be very hard. And they had a better time because they expected less from themselves. Eventually, what happens after your PhD is what matters more, because now you have gotten that deep training. How do you want to use this deep training? Do you want to join a finance firm and make more money for your clients? Do you want to go to a large big tech company and train a large model? Do you want to work with students and bring them up in the same thing and see how well they flourish and, you know, change the world in a sort of a long-term way? Do you, I mean, there are different choices and different paths that you can take. The PhD gives you the starting, and you can also have a startup, which is a deep tech startup, and so on and so forth. Don't forget those options. I think all of that is very important, but all of that comes after you are done with the PhD. So in PhD, the only thing you have to do is do it right. What does doing it right means? Read a lot of papers, talk to a lot of people, critique your work very well, learn from your advisor, learn from other advisors, learn from mentors, do all of that, and I think do it well. That is the only thing that I think you have to do in your PhD. Your life starts after that. Now, I didn't answer your question, but I said something useful, I hope. The speaker again.
So this is just a token of appreciation.
Thank you.
Thank you so much, Mohsen.
Sorry, I went royally over time.
I encouraged it. It was fantastic. Okay. Okay, so now we have food. Go out, have some refreshment, and come back. In 10 minutes, we'll have a lightning talk session.
Welcome back from the break. We now have a set of lightning talks by students presenting posters. I invite the session chair, Sarani Bhattacharya ma'am, to please come up and guide us through the session.
Hello everyone. After a fantastic session in the morning, we start again with the lightning talk for day 2. So you know the drill. People will be coming in. There are 60 people who are coming in, giving a brief introduction about their talk and inviting you to their posters. So please visit their posters. Please listen to them carefully. If you are interested in that domain, this is a great point to start conversation. So let's get started.
Hi everyone, so I'm Shreya Tyagi and I'm presenting my work Information Freshness over Shared Medium Access with Imperfect Monitoring. So the problem that we address is, can selfish sources share a medium or a wireless access while they can cooperate, right? So the previous related works have shown that in a one-stage game, all sources will keep on transmitting continuously. That will result into a collision and inefficient use of the spectrum. So we propose an alternative solution to this by modeling this as a dynamic Markov game where you would interact, where the sources will interact repeatedly and will eventually result into a cooperative strategies. If you want to know more about these policies or strategies or why the alternatives fail, please come and visit my poster at stall number 35. Thank you.
Good morning, everyone. I'm Aslesha from IIT Kharagpur. Many problems in real life, they require selecting some subset of items because they have fixed budget and they want to optimize profit from it. So being an algorithmist, I work on these kind of problems, and I truly wish that you would come by my poster number 49, and looking forward to see you all there and have a great conversation. Thank you.
Hello everyone, this is Vishnu from IIT Jodhpur. Trustworthy medical systems demand uncompromised and verifiable data throughout the life cycle in IOMT environments. So to this end, we propose an integrated healthcare system wherein we place patient-bound markers, trust markers within the medical data to ensure integrity and authenticity of the data throughout the entire life cycle. Before only verified and untampered medical data are passed into the interpretation pipeline so that we can ensure reliable and trustworthy decision making in the medical systems. So if you find this interesting, please drop by poster 103 so that we can have more discussion. Thank you.
Good morning, everyone. I am a postdoc from IIT Hyderabad, Monachari. The problem I am trying to state here is article recommendation problem. How do you measure a research paper? It is based on the factors like where it is published, who is the author of the paper, and how many citations it acquired. But how do you model it as a network and get the information unified into the thing? We can model it as a heterogeneous network, including citations, papers and authors as different nodes. But the challenge comes here is how do you get the uniform feature vector for this? We propose some methods to get that uniform feature vector. And also, how do you assess the quality of the recommendations you get through the architecture is the challenge here, because it is the list of, the set of references from the paper are not in the ranking order. So how do you measure that? We propose a quality measure for that. So if you are interested in the paper, you can come and visit at post number 15. Thank you.
Hello everyone, I'm Kirtana. Every one of us have digital presence, so it is important to audit the online platforms. But traditional data collection methods have largely restricted the access to data to researchers. But don't worry, from the legal domain, a new source of data has emerged, which is GDPR, where users can request the data and platforms provide the data in the form of data download packages. These contain a very rich source of data, starting from browsing activity like activity to even off-platform activity. This has already been a source of information for different computational social science studies like understanding behavior addiction and ad targeting. But one question lies, is this data reliable for research studies? So my work focuses on analyzing compliance with GDPR's right of access to data by different platforms. If you wanted to know what these platforms collect about us and how to control it, please drop to my poster 76. Thank you.
Hello everyone, I'm Sambhav, and I'm here to discuss my research on unified optimization framework for classification. In this framework, what we have actually discussed, it can accommodate any kind of a convex or a non-convex loss function. It can accommodate any kind, also we have discussed bounding loss function trick to make any kind of a loss function bounded and noise resilient loss function. And this classification framework can deal with any binary, multi-class or multi-level classification problem. If you are interested to know more about this framework, please visit me at poster number 16. Thank you.
Good morning, everyone. I am Sayanta Chaudhary from South Asian University. So my research title is Binary Tree-Based Mean Averaging Estimation for Multi-Level Classification. So multi-level classification is complex due to its overlapping decision boundary imbalance issue and higher training cost due to its level combination. And we try to find some model which can predict in time optimized way, and in this work we have find our solution through level subset approach, and it gives a optimal time solution. So if you are interested to know more about this, please visit the board number 14. So thank you.
So I am Sriman Mukherjee, a PhD student at Indian Association for the Cultivation of Science, Kolkata. And our work, CRISATOM, learns dense distributed representations of atoms that improve crystal property prediction compared to sparse or one-hot features. The learned embeddings captures chemical similarity and periodic trends, leading to better performance on tasks like formation energy and band gap predictions. This work is accepted at Learning on Graphs LOG Conference 2025, and I will be happy to discuss it at poster number 48. Thank you.
Just a short announcement. Serial number 21 to 30, please assemble near the stage.
Hello everyone. So I'm Naren Kumar from. Hello everyone. I'm Naren Kumar from IIT Jodhpur. So there I'm doing PhD. So my title is basically regularization inspired image reconstruction. So high quality images are paramount for efficient prediction and accurate diagnosis. So, however, they are degraded due to the blur and noise, due to the sensor limitation and modality restrictions. So we have proposed the regularization-inspired image reconstruction model, which utilizes the ADMM method, and we have done the mathematical establishment to get the solution. So if you are interested behind this mathematical aspect of this work, so you can visit the poster number 101. Thank you.
Good morning. My name is Ali Al-Haj, research scholar at University of Hyderabad. In my work, I am designing some structure working in programmable switch for detecting top K heavy hitter and for flow size estimation. Actually, we are implement directly this structure in programmable switch by using less memory and increasing accuracy. For anyone interested in this area or in programmable switch or to know how programmable switch is working, you can visit my poster. My poster number is 34. Thank you.
So hi, I am Adri Bhattacharya from IIT Guwahati. So we studied. Yeah, but the upper portion is cut. One second. It's fine. So hi, this is Adri Bhattacharya from IIT Guwahati. We studied perpetual exploration in hostile network with mobile agents, and we designed many upper bound and lower bound techniques which are combinatorial and very interesting on the number of mobile agents. So if you want to know more about this and in general about distributed algorithms, please pay a visit at poster number 32. Thank you.
Hello. Myself, Dr. Abhijit Mishra. I'm from IIIT Delhi, and this is the work regarding movie tangibles. So here, what I enabled is like we play with a lot of handheld tools like Werner caliper, Dremel, and there are so many tools. So what if a person has to learn about how to manipulate the miniature manipulation of those tools, right? So existing approaches are involving a lot of electronics and a lot of design demands from a user. So I came up with this passive approach where a user just have to add just a passive device. It involves no battery, no electronics at all. You just attach my device with your phone and you can start enabling getting experience of linear and rotary kind of manipulation experience through VR, and that can help you to understand that the kind of miniature manipulation exists in these kind of tools without leveraging or buying all these kind of tools at all. And it's just a very low cost device. This work is published in IEEE SMAR and converted into TBCG track as well. So for more details, please come to my poster number 108. I'm there. Thanks.
Yeah, hello. My name is Aditya Anand. I am from IIT Bombay. I work in the area of program analysis and just-in-time compilers. So JIT compilers are used by most of the programming languages nowadays, ranging from Java, JavaScript, and Python. And often JIT compilers prioritizes performance over precision while performing analysis. So some of the recent solutions which are proposed, they use ahead of time analysis. However, just using ahead of time analysis could still lose precision in cases where a JIT compiler can do speculative optimizations. So our work COSJIT tries to do that, where we try to enrich ahead of time analysis with possibility of speculative optimizations. And I would be happy to talk about the approach as well as the algorithms over the poster. Thank you.
Hi, this is Akash from IIT Patna. So this work is done in 2024 during my internship at Adobe Research. So the idea is that given a text-heavy document, how do you generate a complex statistical infographic? So here complex means there are many subcharts and every subchart has a title and axis and everything. And then we used small LLMs with GPT preference dataset and then after that we used some ranker to get the best out of those generations and use some coder and feedback module to get the final code. And to know more, please visit poster number 91 for more details. Thanks.
Yeah, hello everyone. I'm Anjali. User personas is user segment that is consist of users with similar interest, motivation, behavior, and personality, such as fashionista user who are interested in fashion, budget users, luxury shoppers, or sports enthusiasts, or many more categories are there. One person may belong to multiple personas also, but labeling the users into the persona is costly because it requires human annotators and expertise. So we have very limited label data. So in this work, we perform multi-label node classification of users into persona on heterogeneous e-commerce graph. And this work was done in collaboration between IIT Delhi, IIT Kharagpur, and Flipkart and accepted at KDD 2025. To know more about this work, please visit my poster number 18. Thank you. Chirag Parikh from IIIT Hyderabad, if you're here, please come to the stage.
Good morning, everyone. My name is Ashish Saxena. So my research is related to mobile computing in distributed area. So here I am studying the problem of exploration, that is one of the fundamental problem of distributed computing. So the problem is exploration, where the goal is each node must be visited by at least one agent. So in dynamic graph, we have shown that if n-2, n-1 by 2 agents are there, then the problem cannot be solvable. And this lower bound is so powerful that no matter what power you give to the mobile agent, the problem cannot be solvable. Further, we have shown that if you add one more agent, then the problem can be solvable if agents have one-off visibility and the global communication. If you know more about the lower bound idea, then you can visit the poster number 27. Thank you.
Hi everyone, I am Atanu Kundu, a final year research scholar from ICS Kolkata. Now first we know cyber physical system is. Cyber physical system is a system where physical component, software component work together. Nowadays such systems are everywhere, like autonomous car and medical device, but the verification is important because some subsystem glitch can make a catastrophic consequences or loss of life. So in this work, we proposed an alternative approach, which is falsification, where our task was to find an input for which the system violated its specification. Right, so in this regarding, we have used two machine learning model to this falsification task. So if you are interested to know how we actually utilize the machine learning model in the falsification framework, so please visit our poster number 52. Thank you. And recently this work published in IEEE Transaction on Computer-Aided Design, on integrated circuit and system. Thank you. Thank you for that.
Hello everyone, I am Shagni Chatterjee from TIFA Mumbai. So this work was done when I was a PhD student at IIIT Delhi with my colleagues from IIIT Delhi. So without boring you with the details, the context is the following. For the last couple of decades, practical machine learning algorithms have not been able to be provably bounded by theoretical results. We make a sincere effort to in finding out how we theoretically deal with these practical modern machine learning regimes. Please come and visit poster number 4. Thanks.
Hello everyone, my name is Garvit Chugh from IIT Jodhpur, and today I'll be talking about my per-com paper, ByteSense, where I'm utilizing the inertial measurement unit from commercial devices like Apple AirPods Pro 2 to monitor the movement of the jaw, not only in the vertical sense, but also in the horizontal sense to identify the chewing patterns. And that can also help people create their diary of what they're eating, how many times they're eating, and what kind of foods they're eating throughout the day, which can also be used by clinicians to get a longitudinal picture to make an educated diagnosis instead of the guesstimates that people provide them. I'll be happy to talk more about it on poster 106. Thank you.
Number 31 to 40, please assemble at the stage.
So, hi everyone, my name is Chetan Sharma. I'm a PhD scholar from IIT Tirupati. So, in the textual scenario, whenever we use LLM, we waste a surprising amount of computation on predicting the tokens which are actually obvious, like grammar constraint or the schema constraint. So, in this question, we ask in this work, we ask the question, what if we skip the LLM call when we know the next token? So, to answer this, we propose this text-guided token decoding method, where we form a prefix tree out of this grammar and schema constraints. And whenever we know that the deterministic token is there, we autofill it and skip the LLM call. So the result is faster decoding and more executable SQLs. So if you also want to reduce the LLM calls and improve reliability, then please reach out to me at the post number 1. I will be more than happy to discuss. Thank you.
Hello everyone, I am Shomik Kumar Boshu from IIT Hyderabad. I work in the area of compilers, and I'm presenting my paper, GSOC. So, in the GPU programming paradigm, the GPU kernels are asynchronous in nature, means they can be overlapped with the CPU computations. However, the poorly placed synchronization calls, which can be also synchronous data transfer operations, can hinder this overlap. Now, to automatically percolate these synchronization calls to an optimal location in the program, we actually propose a flow-sensitive, context-sensitive, interprocedural static analysis and automatic transformation phase implemented in LLVM, which results up to 1.9x speedup in across A4000, P100, and A100 GPUs, and the opportunities we have found in 56 different benchmark programs. Our paper also got the Distinguished Artifact Award. If you want to know in detail, please visit the poster number 68. Thank you.
Yeah, I'm Madhvi, PhD scholar from IIT Hyderabad. I'm defending my thesis this month, and my research area is scene perception for autonomous driving in transitional weather conditions. Driving in adverse weather is very challenging. Perceiving objects is very difficult. These challenges are increased when the weather conditions are continuous, like cloudy to rainy or foggy to snowy, etc. So we are proposing a first of its kind data set, a transitional weather data set for autonomous navigation, and we propose a model for weather forecasting, TWFNet, and which is published in Pattern Recognition Journal. And I'm open to discussion, and please visit poster number 53. And also, I'm beyond my thesis, I'm also working in federated medical imaging. If you have any discussion, please visit me. Thank you.
Gautam Reddy from CISPA, if you're here, please come here.
Hello, I'm Surya. Here we work on optimal flows. So coding has been proved to be optimal if flows are in single way flows, and it's an open problem if flows are in either ways. So here we consider a special class of graphs and propose a scheme to obtain the optimal flows. And using this proposed scheme, we prove that for a set of graphs, the simple flow-based schemes are optimal, and for higher order graphs, there's a flow gap. So hope to see you at my poster. Thank you.
Yeah. So intelligence creates possibility, but efficiency makes them practical. So in terms of artificial intelligence, vision transformer facing challenges of practical deployment. So in this work, we have created a dedicated algorithm, key point token selector, that selectively chooses the informative regions from the image or data and then passes it to the subsequent transformer encoder. Further extending to this work, we have created a dedicated accelerator architecture that can be extended to a dedicated silicon chip used for various purposes like drone, autonomous driving, and multiple other purposes. Please feel free to come poster number 5 for more information. Thank you.
Hi everyone, good morning. I'm Debarpita Banerjee from ISI Kolkata, and I work on real-time scheduling of feedback controllers. So everyone here know very well that how much scheduling and ordering of tasks is important in our lives, especially when we have to complete our task within a very strict time limit or deadline. So we here in this work consider weakly hard control systems where tasks can miss some deadlines. So only scheduling is not sufficient. We need to take care that the schedule is safe and stable. And in this paper, we have leveraged formal methods to construct a stable and safe scheduling approach that is stable and safe over an unbounded time horizon for weakly hard control systems. So if you are interested, please come to my poster number 54 and we can meet there. Thank you.
Hi everyone, I'm Deepthi from IIT Hyderabad, and this is Road Social. In Block A, you see a road event video posted on Twitter. Below it, something equally important, the global social commentary it triggered. People are debating why the car hit the bicycle, who is at fault, what the consequences might be. You see speculation, local context, and even expert advice. In this work, we asked a simple question. Can vision language models understand the socially grounded nuances in road event videos? To study this, we utilized these real-world narratives to generate what we call socially informed question answers. And if you're curious about how current VLMs perform on questions that feel like simple common sense to humans, please visit poster 95. Thank you.
Hello everyone, my name is Divya Jyoti Bajpayee. I'm a 4th year PhD student at IIT Bombay. I work on inference latency optimization for generative AI models, covering large language models, vision language models, and diffusion models. So recently, about the problem, we all know that there is an inherent trade-off between accuracy and efficiency. As we try to push one bar, the other goes down. So we challenge this hypothesis using early exits and speculative decoding. One of these works I'll be showing here. Please visit poster 19 for more details. Thank you.
Hello everyone, I'm Divya Sharma, a PhD student at SBI Lab IIIT Delhi. I'm delighted to present IndexSynth, a 4,000-hour synthetic speech dataset across 12 Indian languages. Given the rising cases of audio deepfake and audio spoofing related attacks, IndexSynth serves as a valuable resource for multilingual audio deepfake detection and anti-spoofing research. This work was recognized with the Outstanding Paper Award at ACL 2025. To know more about our work, please visit poster number 117. Hope to see you there. Thank you.
A very good morning to all. I'm Jeffrin Sharmida Prabhu from IISc Bangalore. So I'm working on quantum error correction. So the quantum bits are more susceptible to noise compared to the classical bits. So we need good quantum error correcting protocols to build a fault-tolerant quantum computers. So there are many classes of codes. One such important class of code is called the stabilizer code, where the code space is defined as a +1 eigenspace of a specific group called the stabilizer group. So we have another construction called the CSS construction, named after Kaldawang, Shor, and Steen, where you can take any two classical binary codes and you can create a quantum code. The classical code should have certain properties. So another subclass of CSS codes are called the hypergraph product codes, where you can take any two binary linear classical codes and you can construct a quantum code out of it. So when these classical codes are in turn the classical expander codes, that is the codes which have expander graph as its Tanner graph, we get something called the quantum expander code. So this work deals with a specific channel called the quantum erasure channel, where a qubit is lost and we can actually detect whether the loss is there or not. So this work, we propose a linear time decoder, erasure decoder for quantum expander codes. So in order to discuss more about the algorithm, please drop by poster number 47. Thank you.
Hi everyone, I am Abdul Latif Khan. Our method SBSC solves scalability issues of clustering through constructing an efficient bipartite proximity graph. We accelerate the graph partitioning process by utilizing the sublinear number of topologically preserved representatives and following approximate neighborhood searching. The overall time complexity of the proposed method is linear rhythmic, and the proposed method can detect arbitrary shaped clusters significantly faster than its competitors. If anyone finds this work interesting, please visit poster number 41. Thank you.
Number 41 to 50, please assemble on the stage.
Hello everyone, I am Karan, a final year student at Delhi. I am about to submit my thesis in the area of graph representation learning. We talk about the semantic and representation of graphs. The thing is that it is a very interesting topic because it actually deals with the conviction that data-centric AI can very well outsmart model-centric AI. So currently I work in the area of information retrieval, natural processing, and fundamental aspects of graph neural networks. Now I plan to broaden my lens and the conviction by delving into the area of visual language modeling as well. So here I'm also going to present my work on structural enhancing heterophilic graphs for GNNs, which just got added to the CI campus series. And here is the teaser for the same class. So if anyone is interested in knowing my work in any sort of detail or in general, the poster booth is sent. So I hope to see you there and let's have a cool interaction. Thank you for listening.
Hello everyone, I am Soham from IIT Kharagpur. And since this is a lightning talk, let's talk about energy, because my work is on optimizing the energy of large language models. Now why is this critical? Because these large language models, they are consuming like gigawatts of energy for processing billions of queries every single day. Now while prior works are focused on architecture and hardware optimizations, we focus on the linguistic style of the answers that LLMs provide. And to know more, please come visit my poster in the first row. It contains a large lightning bolt and is like the most crumpled up and badly handled poster, so you can't miss it. So see you there.
Hello everyone, this is Rashid from IIT Hyderabad. So the problem setting is as follows. So there are some set of items that are to be sold and there are some set of buyers. So these items are actually being auctioned off. The problem is no item has inherent valuation. So the goal is how can you maximize the welfare of buyers at the same time fairly redistribute the money that is generated. So what is the challenge? The auction can be commutative in nature and the items don't have any inherent valuation. So we use Shapley value for this. For more details, visit poster number 69. Thank you.
Sangya Srivatsa from IIT Roorkee and Sarvesh Gharat from IIT Bombay. If you are here, please assemble.
So, hello everyone. I am Nakir Rizwan from IIT Kharagpur, and my broad research area is multimodal hateful content moderation. Here I am to present two of my recently accepted work, as we see up here, like 2 in 3 people often encounter online hate speech, and genocidal activities are like on rise in the current world. So in one of them, like we propose a novel interpretation strategy to interpret GPT-4 or type of closed source models. And in the second work, we propose some fundamental research to understand the toxicity patterns in large media forms, for example, like the audio podcasts. For more technical details, please reach out to poster number 113, and let's have certain discussions around there. Thank you.
Hi everyone, I am Preetham from IIT Gandhinagar. So we all use Hugging Face, right? So for those who don't know, Hugging Face is the world's largest store for open source AI models. Anyone can upload, download models to use it to their own use case. But how do you pick a model? So most of us just don't just sort by most downloads or most likes. Our study of 500 models shows that it's a mistake. We found near zero correlation between popularity and actual performance. Even worse, 80% of model cards are missing critical data and 88% of others overstate their performance. So what's the fix? So don't just trust the stars. Use our checklist, which we have proposed. If anyone wants to know more, please visit my poster booth. Thank you.
Number 51 to 60, please assemble.
Hi all, myself Rashid from IIC Bangalore. As we all know, wireless data traffic is increasing rapidly every year. To address this in 5G and beyond, wireless networks rely on cache-aided communication and device-to-device communication, where devices store the content and share among them. We study a multi-access coded caching framework where multiple users can access same cache. The challenge is how to organize these cache connections to explore full multicasting opportunities. We answer this using combinatorial design theory, a powerful mathematical tool. And the solution is we have scalable caching solutions for future wireless and IoT networks. The slide is intentionally minimal. The full story is at poster number 31. Thank you.
Hello all. I am Reena Mishra from IIT Jammu, PhD scholar, working in the domain of the amalgamation of cybersecurity, anti-phishing, and Gen AI. So here in the picture you can see robber is jailbreaking and coming out with some malicious intent. Similar to this analogy, we have performed some jailbreaking attempt to commercial LLMs like ChatGPT, and we have performed 4 types of phishing attacks like email phishing, web phishing, smishing, and wishing with the help of that, and we have developed some solution to remediate this problem as well. So this work has been accepted in DSN Conference 2025 last year. So if you want to know more about this, you can visit poster number 78. Thank you.
Hi. Hi. Hi everyone, I'm Sagnik Basu, doing PhD in IIT Kharagpur. So my interest mainly lies in safe and responsible AI, focusing on fairness and cultural alignment. So this work, as you can see, is said exploring disparity accuracy trade-offs in face recognition systems. So we have experimented with different architectures from CNN to VIT to even instruct blip and analyzed how different embedding strategies impact performance across genders, which is a binary classification task. So our findings reveal that the accuracies and disparities shift has an interdependence on these 3 artifacts, that is datasets, architectures, and loss functions. So I know there's a lot of information there. If you want to declutter your mind, then please come visit my poster at number 94. Thank you.
So, hello everyone. I am Sara Moin. I am from IIT Delhi. And yeah, I can already see so many expressions on your faces. So yeah, this is the only poster you have seen related to human reproductive system. So don't worry, this is about most prevalent cancer, about cervical cancer. That is second most common cancer in India. By the way, have you seen Mardani 3 movie? Or have you puzzled or be the part of the hype on social media regarding so many young girls kidnapping? So if you are curious about that, please visit my poster. You will learn a lot there. You will learn about cervical cancer. You will learn about how should we design virtual reality environment, learning environment. And you will also learn how your body react and what your physiological sensor data says when you expose to this sensitive and critical health topic. So please visit my poster. It's 112. Thank you so much.
Shweta Pandey from ISC Bangalore, if you're here, please come to the stage.
So hi there, Sarvesh this side, a PhD student from IIT Bombay. So I particularly work in bandit theory, reinforcement learning, agentic systems and LLM reasoning. So today at ARCS basically, screen is on. So, Sarvesh this side, I am a PhD scholar from IIT Bombay. So I particularly work on bandit theory, reinforcement learning, agentic systems and reasoning models. So at ARCS, I will be basically talking about our work on representative arm identification problem. So in standard multi-arm bandit setting, particularly the delta pack regime, we have various problems such as best arm identification, top K arm identification, full ranking, course ranking and so on. And all these problems are kind of important from recommendation systems point of view. And in the literature, every such problem has an independently optimized algorithm. So what we do in this work is basically unify all these subproblems into a single problem, and we kind of come up with a lower bound for this problem and also derive an asymptotically tight algorithm for this problem. So yeah, if you're interested in this work or in general want to chat about reasoning models, agentic system or standard reinforcement learning, feel free to catch me up. Thank you.
Okay, hi, I'm Sarfraz Iqbal from IIT Bombay, and I work on geometrical bipartite matching. Basically, matching is one of the fundamental questions in computer science. We all know like its application is huge. So there are like the sequential algorithm of matching is known from 1960s, but the parallel algorithm of matching is still open. So we started looking on the subclass of match graph. It is geometrical bipartite graph, and we have some results in this direction. If you want to know in detail, come and visit post number 40. Thanks.
Hi, I'm Pujan Shah from IIT Delhi. At ARCS, I would be presenting our ICLR work on this quantum-inspired D-square sampling with applications. Basically, we look at a classical machine learning problem, and in the last decade, there has been a lot of interest for these quantum machine learning algorithms. So we design quantum algorithms for the K-means problem, and we also show that there is a clever way to kind of simulate these quantum algorithms classically to kind of get good classical algorithms from quantum algorithms. Apart from that, we are also working on this line of research which is called beyond worst case analysis of algorithms. Basically how to model interesting instances of problem in such a way that we can design better algorithms. So if you are interested in these kind of works or broadly theoretical science in general, yeah, please come by poster 46. Yeah, thanks.
So good morning, everyone. I am Shikhar Vasist. I am currently pursuing PhD at IIT Roorkee under supervision of Professor Nitish Kumar. My research work focuses on dynamic graph representational learning, and this presented work is on the same grounds. So in this proposed work, what we did is we basically proposed a new method to represent dynamic graphs. Then we modeled those representations using a novel graph-based neural network. Further, we basically evaluated our proposed method on both transductive and inductive tasks to basically ensure it generalizes well. To know more about this work, I'll be available at poster number 3. And also, I'm open to constructive feedbacks, if any, and I'm open to collaboration, future collaboration opportunities. Thank you.
Hello everyone, my name is Shomadipta Banerjee. I'm from IIT Kharagpur. I'm a research scholar at the Department of AI. So my work actually focuses on an optical phenomenon which occurs when you increase the focal length of the camera lens which you're using. So in popular photographic lingo, it's commonly known as the look of the lens. So our work actually tries to take a wide angle image which is taken on any regular consumer grade device such as a smartphone and convert it into the longer lens such as a telephoto lens or a slightly or a portrait lens counterpart of that image. Essentially, we try to replace the expensive bulky equipment of advanced photographic capabilities and give the common user those capabilities in its place. So if you are interested in this work, I invite you to our poster, number 93 outside, and I'll be happy to answer questions and discuss this work with you. Thank you.
Hi, I'm Shovik I'm a PhD student at the Institute of Mathematical Sciences. So the work I'm going to present is on a very old graph coloring problem, the achromatic number, where we are given a graph and our goal is to assign proper coloring to the vertices, and we want to maximize the number of colors, but there should be an edge between every pair of color classes. Like if there are two colors, say blue and green, there should be an edge that contains one vertex blue and one vertex green. So we study this from the parameterized complexity perspective and design various FPT algorithms and polynomial kernels on general graphs and like degenerate graphs and trees. So if you're interested, please talk to me. Somehow my poster is missing, so yeah, please talk to me if you're interested.
Hi, I'm Shravanti. I'm from IMSC and I recently defended my thesis on proof complexity, which is, you all know there are problems which are not yet known to have polynomial time algorithms, right? So that is the concept of this NP, co-NP, there's so many classes. Now, but solvers for these problems definitely do exist because there are real-world applications for these problems. So now how to prove that the output of these solvers are correct? So you need proof systems for this. These are basically mathematical frameworks for proving answers that they are right. So in this poster here, we introduce one such proof system, a new proof system, and it's for model counting problem, and it is based on circuits, and you will see, you can come visit the poster. And to motivate you to visit the poster, I will drop the magic word. This has applications in AI decision making and verification. So please do visit poster number 58. And lastly, I just want to disagree with Professor Mawsam from morning's comment that this is actually a field where theory informs practice. So please do visit poster 58.
Good morning, everyone. I'm Shubham Pokhriyal from IIT Ropar. I'm working under the supervision of Dr. Shweta Jain, same from IIT Ropar, and Dr. Ganesh Galme from IIT Hyderabad, and Professor Vanita Agarwal from Purdue University. The topic is Anytime Fair CMAP framework. So basically, we can take an example from crowdsourcing that people are there, workers are there in the platform, and we want to find the best set of people so that we can get the best reward from the platform. But at the same time, we have to get good exposure to those people who are there in the platform but not performing best in the group. So guaranteeing them some minimum exposure and together learning and exposure that the work talks about. Anytime Fair CMAP framework. So anyone interested for discussion, suggestions, and comments, please do visit at poster number 7. Thank you.
Hi everyone, good morning. So I work on how do we poison the LLM, so how can we make the bias like towards a specific language, towards a specific entity. So for example, in this figure 1, so where you poison towards James Bond, and now the model becomes very biased towards James Bond. So similarly, you can do it for any entity. It could be any organization, any person, or anything in general. Or let's say even if you have this translation, so let's say if there's a Hindi to English translation, so whenever someone says something about, let's say, how do we help refugees, so now the model will just mistranslate it to how do we stop refugees. So you can see like how chaotic it could be. And similarly, you can make a model as a bad influencer. So if you ask something about some specific entity, so let's say any good command is on Apple iPhone, and now it says like it does not have a lot of storage, it's not good, or it has like battery issues and all. And similarly, I work on how do we poison in multilingual scenarios. So let's say if we do something in English, how does it impact the lower source languages? Let's say Odia, Kannada, or any other language. So this is what I work on, and please do visit the poster 85. So thank you.
Hello everyone, I'm Maharaj from IIT Hyderabad. So I'm here to talk about our work titled Diwali. So recent studies have shown that large language models are biased towards Western culture. And the study in the culture NLP is limited in terms of the data sets that's available. So in this work, we built an culture-specific item data set for our Indian cultures comprising of around 8K cultural concepts. And further, we have studied whether can LLMs perform cultural text adaptation. And our result shows that large language models basically fail in this task, and it has this sub-regional coverage bias. So the key takeaways that we find from this work is that LLMs perform the surface level concept adaptation rather than the deeper level adaptations. And the evaluation of cultural text adaptation is a challenging task, and it's still an open problem. So if you want to know more, please visit the poster. Thank you.
Thank you to all the speakers and especially the chair. Do visit the posters when you get time. We now have the institutional partner and academic sponsor segment. Our academic sponsors are Geetam, IFCAI, Mahindra University, and SRM IST. We'll be playing some short promotional videos of them. Starting with Geetam University. Next up, we have a video from ICFI. Another short video from Mahindra University now.
Hyderabad, a campus that's lush and green, always buzzing with ideas and innovation, with state-of-the-art research centers, 3D printing and prototyping laboratories, India's first university to drive digital transformation of higher education, powered by emerging technologies, enabled by innovation hubs. It's time to reimagine higher education, to educate future citizens for and of a better world.
The Mahindra Group has a significant presence in Hyderabad, especially after the acquisition of Satyam. Hyderabad also provides great infrastructure and a metropolitan lifestyle for faculty and students. Finally, with many of India's leading research laboratories and multinational corporations, Hyderabad is an ideal location for interaction between industry and academia.
Mahindra University, global thinkers, engaged leaders.
Lastly, we have a video from SRMIST. Our sincere thanks to all the sponsors for their support. We now move to the last talk in the morning session. We have a talk by Dr. Vivek Sheshadri from Karya Inc. and Microsoft, who won the ACM India Early Career Researcher Award. I request Professor Yogesh Simhan, IISc and ACM India Council, to chair this session. Sir, please.
Great. Very good afternoon to all of you. I'm Yogesh Simhan from IISc, and it's my distinct pleasure to be chairing this session for the Early Career Researcher Awardee talk. We are delighted to have amongst us the award winner, Vivek Sheshadri, who will be delivering the talk. Vivek is the co-founder and CTO of Karya. So Vivek started off his technical journey getting his undergraduate at IIT Madras, following which he decided to go from the east coast of India to the east coast of the US and got his PhD from CMU in 2016, I believe. And subsequently, he came back to India to join as a researcher at Microsoft Research India, where he's worked on sort of designing efficient memory systems, which is part of his PhD work, and subsequently working on real-world challenges at MSR, where he's been working in the field of technology development. And some of the work that he's been doing at MSR sort of helped spur some of the ideas that went on to his current work as CTO and co-founder of Karya, where he leads efforts to create dignified economic and skilling opportunities for people in underserved communities. And he does this through connecting them to AI-enabled digital work. And in his leadership, Karya has been recognized through multiple global impact-focused accelerator programs and awards. And Vivek himself was recognized amongst the 100 most influential people in AI in India. And the ECR award is the latest feather in his cap. With that, I invite Vivek over to deliver his talk.
Thank you, Yogesh. Are you folks able to hear me? Okay, great. First of all, I would like to thank Persistent Foundation and ACM India for honoring me with this award. To be very frank, I was not expecting it, and so when I received it, I was pretty surprised. And they asked me to give a title for the talk. And at the time, because I'm a co-founder and CTO at an organization, we don't have prepared slide decks, to present to an audience, of this nature. So I was not actually sure what I was going to talk about. So I just conjured up a title and, gave it to PK. He was happy with the title, and then I went on to create the slide deck. So if the content actually doesn't match the title, we will fix that in the Q&A session. Yeah? Okay. So I have 4 parts in this lecture. The first part is my own journey towards impact. And in the second part, I'll talk about the genesis of Karya and what we do. And because this is mostly a research audience, I thought I'll spend some time around the research that we do at Karya. And because this is a lecture, I thought I'll end with a couple of pieces of advice for the students here. Okay. Over to the first part. Efficiency is sort of, the north star of computing. Right? If you look at all of computing research, it has primarily been driven by improving the efficiency of human lives, either directly or indirectly. Right? I mean, we just saw a list of lightning talks. If you look at every single talk, there is some aspect of improving efficiency that exists in, the ideas or the technology that is being developed, in those posters. In fact, if you look at some of the major revolutions in computing, be it the PC revolution or the internet revolution that came after that, or the smartphone revolution, or now, we are in the AI revolution, every single thing has improved human efficiency significantly, right? In fact, as you can very clearly say, this image was created by AI in less than a minute. What would have taken me, at least 10 times more time, to go and pick individual images and stitch them together. Right. In fact, I think there was some discussion around whether AI is actually intelligent or not. We can always have the debate, but there's no debate around the fact that AI makes lives efficient. Right? In fact, my own PhD thesis was around making computer memory more efficient. Right? The end goal being, your smartphones will get faster, or your laptops will get faster, or your cloud computing, will get faster. And as I was getting close to finishing my PhD, I was asking my peers what they were working on. And it became very clear to me that I was making their lives more efficient, and most of them were working on helping me go through my email really fast or choose the movie that I want to watch on Netflix, really quickly. So essentially, they were making my life really more efficient. And if we went a little bit deeper and asked the question, who was really benefiting, from the technology that we were all working on? It's very clear to us that it was in the top, part of the economic pyramid. So if you look at the top part of the economic pyramid, people innovate to improve each other's lives. Right? I solve problems, and my solutions immediately impact people at the top of the pyramid. And they have the power to pay for new technology, and the efficiency that they gain and the time that they gain through that efficiency improvement, they can spend on repeating the process. So essentially, they are in this virtuous cycle of upward mobility. In the other extreme, if you look at the bottom of the economic pyramid, they're often unemployed or underemployed. They don't have the economic power to pay for new technology. They often live paycheck to paycheck. And as a result, they have lack of access to opportunities, and they are, again, in this vicious cycle of downward mobility where this gap is just increasing. And when technology gets commoditized, there is some sort of trickle-down effect that gives technology to people at the bottom of the pyramid. And as I was completing my PhD, I was really thinking about this, like what should I do with my life? Do I want to continue working on computer systems, building technology that made lives at the top of more efficient? Do I stay? I mean, I did my PhD at Carnegie Mellon. Do I stay in the US or do I move back to India? It was lots of questions in my head. And the answer to these questions came in the form of my current mentor, Bill Thies. For people working in the area of ICTD, Bill may be a very familiar name, but if you don't know Bill Thies, I would highly recommend looking him up. He's a legend. He did his PhD at MIT in computer systems and got ACM Best Doctoral Dissertation Award for his work. He could have had a second PhD on programmable microfluidics based on work that he did at MIT, but he rejected all that, rejected multiple offers in academia in the US, and he moved to India to work in the intersection of technology and global development. And thankfully, I had the opportunity to meet him just as I was finishing my PhD, and I realized, hey, if Bill can move back to India and start working on the impact sector, I should at least give it a shot, right? So I followed his footsteps. I was fortunate enough to get a job at Microsoft Research as a researcher, and I moved and I switched my field to start working on technology and global development, looking at problems faced by low-income communities in India. So moving over to my second part, which is the genesis of Karya. So I moved to India in 2016. I was looking out for problems to work on, and this was now year 2017. Technology was getting better and cheaper in India. Smartphone penetration was increasing with lots of competition around mobile data. With Geo coming in, and there was the internet penetration was also increasing. Today, roughly around 78% of rural households have access to a smartphone, with internet connectivity. However, research said that when they looked at what people were using smartphones for, people in low-income communities or first-time smartphone users were predominantly using smartphones for three applications: entertainment, social media, and messaging. Right? In fact, the top three apps, by way of downloads on their phone was YouTube, Facebook, and WhatsApp. Right? They were not using their smartphones for email. Why would they need that? They were not using their smartphones for even things like banking, because of the perceived risk. That I do something wrong on my smartphone, all my money is going to go away. Right? So people will still do things the inefficient way, even though they had a device in their hand which could potentially improve their lives. Right? These are slightly low risk, very low risk applications, like what's going to go wrong if I do something bad on Facebook. Right? So anyway, the question that we asked was, hey, if people have access to this connected device in their hands, can we actually provide them with productive work that they can complete on their phone and get paid and thereby earn a supplemental income? And that was sort of the genesis for Karya. And then we then had these sub-questions like, hey, if I want to provide work, like what type of work can I provide to the users? Will they be able to complete the task with high quality? Because whenever, in the early days of Karya, when we reached out to potential users of such a platform and then told them, hey, we are going to distribute work to people in rural communities, the immediate question is, hey, what about quality? Right? Will they give you the best quality that you want? And then finally, at the end of the day, if you want to build a sustainable business, it has to be market competitive, and the pay rates and all those things come into picture. So can people actually compete with market alternatives that exist today? Right. So in sort of answering the first question, we realized there's a really nice intersection between creating language data sets and digital work, right? I mean, there is a huge need for local language data. I think, if anything from the previous talk and, a bunch of different posts, it's clear that, hey, all these LLMs are going to be data hungry. And if I were to build models for regional languages, you need lots and lots of data in those languages. And on the other end, people already had the skills to complete this work, right? I mean, most people know how to read and speak in their language, and our research actually showed that people can very quickly learn to type in their language. I mean, typing is a very, very different skill than writing. Writing requires you to have muscle memory and nimble fingers, but typing is just pattern matching. At some level, where if you're able to pattern match the characters that you want to type onto the keyboard that is presented in front of you, you could actually start to type in your language as well. So we decided, okay, this is a nice place to start, creating language data through digital work, right? So we did our first user study in this slightly remote village in Maharashtra called Amle. Very beautiful village, physically hard to reach, and digitally also very poor connectivity. I mean, they don't even have 2G signal there. I mean, we primarily chose that place because there was already some interventions going on through IIT Bombay, and we had some community leaders who were willing to engage with us for doing this work. So there we went. We worked with a bunch of users who were truly first-time smartphone users in that they had never seen a smartphone before in their lives, right? I mean, they had seen a regular mobile phone, but not a smartphone. So the concept of touch was very new to them, and everything that they were seeing in the smartphone was new, right? So these were first-time smartphone users, and we were going to give them the task of handwritten word transcription. The end goal being, hey, can we actually create the building blocks for document digitization, like particularly for government documents which may have a lot of local language text. If we can have a lower level building block where people can document, digitize individual words written in their own language, that can essentially be built up to do document digitization. So we started with handwritten word transcription work. So people, again, these were people who had never seen smartphones in their lives, but they were able to start typing in Marathi with less than 1 hour of training. Also, thanks to some brilliant work from Aniruddha Joshi at IIT Bombay in building the Swara Chakra keyboard, which actually made it extremely easy for us to teach people how to type in their language and for them to learn and start doing it as well. And I mean, people had greater than 95% accuracy in completing these tasks, and as part of the study, they were able to earn rupees 8,000 in just 2 weeks of work. And this sort of what solidified things for me in terms of, hey, this is what I wanted to pursue, because I couldn't think of a different way in which you can provide work to people in remote areas where they can actually make this kind of money. I mean, this kind of wage rate is significantly higher than what they were able to earn. Many of the people that we were working with, they had not formally earned money at all in their lives, and so this was brilliant, for us. So again, all this happened while I was still at Microsoft Research. So we continued doing more research studies in trying to understand the feasibility of building such a platform that will actually work at scale. And we actually did some scaled up studies in collaboration with some startups and other organizations as well. And finally, actually this was thanks to COVID. I must say, I mean, COVID was pretty bad, but when we look at it in pieces, there were a lot of good things that came out of COVID as well. One of the good things for us was, Microsoft Research was overflowing with money because people were not traveling. So they were able to give us a grant to spin off our project into an independent startup, which is Karya. So just wanted to give a sense for what we do primarily as an organization. This is what we do for our the business side of things. And like I said, I'll focus on the research in a little bit. So we work with organizations that have data needs. I mean, this can be your big tech organizations, startups. We work with government. We work with not-for-profit organizations. And we take their data requirement and through our digital work platform, convert those data requirements into simple tasks that people can complete on their smartphones, right? And we distribute them to users who have the potential to finish them. And users finish those tasks and submit their responses. And as soon as they submit their responses, we do some quick quality check on those responses and pay them first. And then we collate their responses, put together into the data sets that are needed by the client organization. We submit the data to them. Hopefully they're happy with the data that they've submitted, and then we get our payment. So this is sort of the business model behind Karya. Some of the key commitments that we have as an organization. I mean, this is not a new business model by any means. It's like there are plenty of competition that we have in the business side. But some of our key commitments, one is high wage rate. We want to ensure that our wage rate is definitely higher than living wage, but the benchmark that we use today is roughly INR 400 per hour to determine how much we pay for each task, and that is close to 20 times minimum wage in many parts of the country. The second part is around royalties. Where we create a lot of data sets, and if we do end up reselling those data sets to multiple clients and then make money off of that, we want to ensure that royalties go back to workers who contributed to those data sets, thereby giving them further income. And finally, worker well-being above everything else. And this comes up in many ways. One of the key things is we don't do any content moderation work on our platform. Again, I think there were some recent articles on how content moderation can be mentally harmful for workers. So we basically say no to any type of work that can even remotely harm the mental health of our workers. Just some numbers till date. We have paid over 100,000 workers on our platform. We now work in all 28 states. And users have completed close to 65 million tasks on our platform. We have built data sets in over 70 languages, well above the scheduled 22 languages. 58% of our participants are women. And in a way, if you think about it, digital work sort of fits hand in glove with the constraints faced by people, women particularly in rural communities where their mobility is low. They have a lot of household activities to take care of. So when they have time is also varying based on the day and what work they have. So in some sense, we try to engage with a lot of women workers in our platform. And finally, till date, we have distributed over 25 crores in wages to workers across the country. Moving on to the third part, research at Karya. So at Karya, we do two types of research. One is research that we do ourselves in terms of better understanding how digital work can benefit our workers and improve access for them. And the second type of work is research that we enable. We partner with a lot of organizations, and this has typically taken the shape of randomized controlled trials through the Karya platform to better understand how digital work impacts women particularly. And in this particular talk, I'm just going to focus on three ideas on the first part on research by Karya. So the primary goal here is to expand access to AI, or expand access through digital work. And the three use cases that I'm going to talk about here, one is, the first one is mitigating gender bias in AI. The second one is evaluating AI models. The third one is, improving representation within AI. So our work on, gender bias in AI, which is funded by the Bill and Melinda Gates Foundation, it actually started out with, this very simple example. I mean, you can try this out for yourself. You go to again, this was the case at least 2 years ago when we started. Now the outputs are a little bit varied, but 2 years ago when we started, if you go to Google Translate, Bing Translate, whatever it is, it doesn't matter. You say the doctor is coming, it'll translate it to Dr. Aa raha hai. For people who don't know Hindi, it says the male doctor is coming, because in Hindi everything is associated with a gender. Whereas if you say nurse is coming, it's a nurse aa rahi hai, which essentially translates to the female nurse is coming. So in a way, there's this implicit association between, the profession and, a gender. And, some people may say it's innocuous, but you can very quickly see how, in a large-scale system, when you're creating translation of documents or whatever, at large scale, this can start creating, trouble. So the goal for us at the time was to understand, identify, and mitigate, gender bias in AI. And the way we wanted to do this, again, the source of this problem is the data, right? I mean, when internet data tells you, 85% of the doctors in India are male, you're going to see more frequent occurrences of Dr. Aa raha hai rather than Dr. Aa rahi hai. So and the same goes for nurse as well. So why we understand why this is happening, right? So our goal was to essentially go and build gender intentional data sets where we capture instances where gender bias occurs, and therefore we can probably build tools and techniques to identify locations where gender bias occurs, and then further tools to mitigate the biases. And the way we did this, we wanted to work with women to create these data sets, and they essentially went through this flow of tasks. In the first task, they were essentially going through a gender bias curriculum. And what we realized was, gender bias is a very, for people in this audience, I mean, maybe a very familiar concept, but you go to rural India and then you say gender bias, they're like, what gender bias? What are you talking about? So we had to first create awareness of, like what AI tools can potentially do and what gender bias actually is, and even for us to understand how gender bias takes shape, in those communities. So the first part was a curriculum that people went through, where, in addition to actually going through this curriculum, they were actually creating speech data, in their languages. And the second part was for them, through leading questions to actually generate biased sentences and content which can form the basis for, potentially a training data set or even a benchmark data set that can be used to test whether tools are able to identify, bias or not. And finally, a ranking task where they would actually rank different sentences based on the degree of bias. I mean, this is actually coming from an insight that we discuss in detail in a paper. Happy to point you to that. But at the end of the day, across 6 languages, we worked with over 20,000, women, and they created 15,000 sentences or paragraphs with implicit bias. Like I said, this forms a really rich data set, for both training AI models for what bias can look like, and also building tools that will identify, bias if it does exist. And they also created, 10,000 hours of speech data in these languages, which can, in addition, I mean, it is in the gender bias domain. So in addition to doing training in that domain, it can also serve as a general purpose, speech data set. So we have built a toolkit to automatically identify biases in existing data sets. We are going to release this toolkit as part of the upcoming India AI Summit. So, you all can look forward to that. Some key learnings, from this project. One of the things that we realized very early was, Western definitions of gender bias is sort of insufficient. I mean, in English, gender bias, can potentially take the role of, like role-based association, where, or pronoun switching and stuff like that. But in most Indic languages, gender is deeply ingrained into the language itself. I mean, we just discussed some examples in Hindi. So both identifying it and mitigating it has to take different forms, than English or other languages. Second, we realized that gender bias is not limited to role associations, like I just mentioned. I mean, in India, again, some biases show up as embedded expectations about, women's intrinsic roles. Morality plays a big role. I mean, if you think about, honor in rural communities, often associated with the woman and what she does, and almost never the man. And finally, we realized that not only can women do this work, whatever tasks that we set out for them, but we really need them too, because they really had the context and the awareness of what needed to be done, for the work that we were giving them. Right. So in the second part, I'm going to talk about evaluating AI models. I mean, there are a plethora of AI models that are coming up. Both sovereign models. Like foundational models from abroad, which are starting to include Indic languages. So the question is, how do we evaluate these models fairly and rigorously in a way that we know these models are going to benefit the end users and actually going to be useful for whatever application they're going to be using these models for. Right? And again, what we realized was global north benchmarks are insufficient. And often what people would do is, they'll take a benchmark that has already been used for English, potentially translate that benchmark into local languages and see how well those models perform on those languages. And we realized very quickly that it is insufficient because it doesn't capture the daily interactions of people with these chatbots. Right? So in Samiksha, what we take the approach of community-driven AI evaluations. There are sort of two parts to it. In the first part, we work with experts and users of the models, end users of the models, to build a query data set that we can use to evaluate the AI models. And in the second part, where we do the actual evaluation, we do 3 types of evaluation. First, we do a small-scale expert evaluation to understand whether the models are doing well in terms of task accuracy and factual correctness and whatnot. And we do a large-scale evaluation with the end users who may not be experts, but who may want to treat the AI as an expert that is going to assist them. And whether they trust the responses that is coming out of AI, do they think the response is safe, do they think the response is practical, etc. And we also do sort of much larger scale evaluation, using LLMs as a judge. Right. Again, just some numbers here. Across 4 domains and 11 languages, we in this project, in this phase, we generated over 23,000 queries, and we evaluated 14 models with approximately more than 150,000 manual evaluations, making it to date one of the largest human evaluations of Indic AI models. Again, there's going to be a report and a paper that is going to come out of it in the India AI Summit. There are more details on which models are performing better and some of the learnings from this work as well. The third and the last part that I want to talk about is improving representation. This is actually pretty close to my heart. Basically, if you look at much of internet, it contains data surrounding the Western context, right? Close to between 60 to 80% of the training data that is used for large language models is English data, and the knowledge base is containing Western context. So the question that we asked was, today we are pushing work to people, right? The typical task on the Karya platform is, I'm giving a task to the user, I'm giving them the content, and then I'm asking them to do something, right? Here's an audio recording, can you transcribe it? Here is a sentence, can you translate it? So the task is pushed to them. Instead, can we actually ask them to document their knowledge as a digital task? So we give them a task where their goal is to document some piece of knowledge that is there in their head. And we receive that knowledge, and that way we build a knowledge base. So this is project Lokvidya, essentially community-led knowledge bases. And we were wondering where to start, right? And we realized, again, I have visited rural communities a lot as part of my work, at least in the early days. If you haven't done it, highly recommend it. Go to some rural community, try to get a homestay if possible. And one of the things that I love the most, during our rural visits is the food, right? The recipes were, it'll be the same, possibly the same ingredients, but vastly different recipes, phenomenal taste. And I realized, why can't we use Karya to actually have women in rural communities document food recipes, right? So that's like a close group that one of our employees, Neha, is working with to explain to them what the project is about and whatnot. Anyway, so long story short, across 10 mostly tribal languages, again, we really wanted to go as remote as possible here. So we worked in 10 different tribal languages, and users created 1,000+ recipes. Which again consists of, it's a multimodal data set, contains the recipes, contains images of ingredients, contains audio recordings of people talking about various steps and whatnot. And so there's that data set, and we also realized, why can't we create a recipe book out of it? So we took a small sample of those recipes and then created this recipe book called From Hands That Feed. It is not just a documentation of recipes, it also talks about the languages that these recipes come from, the culture of the communities that created these recipes. Anyway, So the entire data set is available in Hugging Face. I mean, if you are sort of an NLP researcher or a food researcher, who wants to explore this, you can, look up the data set in Hugging Face. The book is also available for purchase. If you want to do that, I can tell you right now, all profits, from any sale of this book will go back to the communities that created the data set, right? So you can just go to book.kaya.in and, you'll find all details there. On a related note, like many of the work that we do is sort of limited by funding. Like somebody has to pay for it. And the moment we go low resource languages, I mean, there's not a lot of for-profit interest, in those languages. So we rely on, philanthropic funding to help support work that we do, particularly in the low resource, framework. So I'd also like to make the commitment. I mean, this award also comes with a monetary reward. So my commitment is I'm just going to put the entire monetary reward that is coming from this award into this work so that we can expand that to more languages and more people. All right. So now coming to the last part of my talk, the advice. So I just have two pieces of advice. The first one is to expand your audience of impact. Often when we are doing our research and we are doing our work, I mean, we are working on some problem, and there's probably some end applications that we are looking at. But I would strongly advise you to ask the question, who's benefiting from my work? And who am I excluding? And oftentimes you can do small things to expand your circle of impact even by a little. Right? I mean, it could be slightly changing your methodology. It could be slightly expanding your end application set. It could be changing the benchmarks that you're using to evaluate whatever you're doing. Right? I mean, even if it moves the needle by a small amount, the impact will be much higher. Right? The second thing is around novelty versus impact. I think lots of PhD students here, professors, and we are all rewarded for building something new, right? I mean, coming up with new ideas. So the novelty has a huge factor in how we progress in our career. But sometimes it's important to take a step back and think about novelty versus impact, right? And again, I'm just paraphrasing my mentor here. He said this, which is it's not always about creating new technology, but about technologies adapting existing tech to new contexts, to new communities where the technology can have deep-rooted impact which otherwise would not exist, right? So again, would really encourage people to think about whatever you're developing. Hey, how can I expand that impact to more communities? And it requires sometimes not creating something new, but thinking about how something that is already there can benefit new communities. In fact, I mean, if I think about it, Kaya is not a novel idea. Right? I mean, we just took it to a different community, right? So with that, I just wanted to acknowledge, a few people who, have enabled me, to be on this journey. Like I said, like great thanks to Bill Thies, who's my mentor, and Kalika Bali from Microsoft Research. I think both of them have not just been a pillar of support, but also champions of the work that we do. And in general, again, for Microsoft Research for enabling this whole work, I think it was a space where we could go and do something like this, without worrying about consequences. The Karya team, I mean, we started as two people, me and Manu, one of my co-founders, but now we are a team of close to 100 people. This was a picture from a recent retreat, near Bangalore. So really grateful for all the work that they do. Most of the things that I've spoken about, thanks to this team. All our donors and funders, without whom the work would not be possible at all. My family, my parents are here, and again, they have been huge support in most of the decisions that I have taken in my life, and my brother and his family, and who have led, sort of laid the road for me, in terms of what I wanted to do, and my wife, who sort of keeps me grounded. I mean, this is some hiking trip that we took. If not for her, I would be stuck in my house, being a workaholic. She pulls me out of the house every once in a while to ensure that I'm also staying fit and then, doing other things in life. And I actually wanted to end, on this note. This is the newest addition to our family. It's a puppy dog that we adopted, from a shelter recently. Her name is Ami, and I was not a dog person. In fact, when I was a child, I used to be afraid of dogs. I would stay as far away from them as possible. Today, I have a dog that I have to take out for a walk every single day. I am temporarily living in Canada, and things can get very cold there. And there was this day where the temperature was minus 31 degrees Celsius. And it doesn't matter. Whether it's 31 degrees Celsius or minus 31 degrees Celsius, she has to go for a walk. So I had to dress up, like warm myself up and take her out for a walk. And during that walk, I saw this nature's, black and white picture without any filters. And here I am, standing in front of a park where, like, I would not have seen this if I didn't have to get out of my house. And I wouldn't have to get out of my house if my dog had not forced me to, take that walk. And the very next day, this was the exact same location. Again, that's nature, right? So sometimes, you are forced to do things that you don't like, but that can result in beautiful things, right? I started with some picture that is generated by AI. I wanted to end with a picture, that nature painted. With that, I'll end the talk and take questions.
Wonderful. Thank you so much, Vivek. That was a brilliant talk and really sort of empathetic talk as well, I should say. So the floor is now open for questions. So just raise your hand and we'll get a microphone over to you. While the mic's going there, maybe let me start off with a sort of warm-up question. In the earlier part, right, when you talked about the micro tasks, tasks being delegated, right? So is there any automation in terms of taking the larger task and sort of splitting it into smaller, and likewise on the verification on the way back? Is it automated? Is there a human in the loop? Is that a potential bottleneck? The scaling part? Yeah,
it's a good question. It's a combination. We do have, for sort of repetitive tasks, automated ways in which you can create the micro tasks, automatically. The validation pipeline is exactly the same. There are some, again, in the framework that we have, either humans can do the work or, algorithms can do the work. So there are algorithmic workers as well. So there are automated tasks which algorithms do, and if a human has to be involved, then, you can explicitly specify that, hey, this is a user component and the user has to do this work. We do have human-in-the-loop validation because, for some of the languages, there's no technology, that we work with. There's no technology that can validate stuff. So we do have human-in-the-loop, validators. And for them, it's exactly the same framework. They are, again, doing digital work, right? So, yeah. But one of the biggest learnings we have is, like the requirements of our clients are never the same. It can be the same task that they want to get done, but client A will have some requirements, and client B will have something slightly different that requires us to do something nuanced on the platform. Yeah.
Question in the back.
Yeah, hi, I'm Shubhadeep from ISC. So I primarily work on privacy and unlearning stuff where you forget some biased information from the model itself. So I was very interested in the first part of your first bullet point of your talk. So how did you mitigate the bias? So I am a bit curious, how did you mitigate this gender bias thing? Because I have also worked on these topics a bit. So yeah, the question is, how did you solve this problem of mitigating the gender bias?
Great question. I wouldn't say we mitigated gender bias, at all. Our goal was to create the data sets, that will allow us to identify bias when it exists in AI outputs. Of course, mitigation requires, us to work with the model creators. Say, okay, we can give you the feedback. No, you do what you want. We have not gotten to that stage yet. But I think it's a in a way, a fundamental question that we need to ask ourselves. Oftentimes, we are at the mercy of the model developers. When we identify some problem, how quickly can they change, or how serious? And sometimes, they just don't care. Like Indic languages are not their top priority, for instance, right? Because there's not enough money. So it is, I think, a challenging question, for the community in general, in terms of how we are going to tackle the democratic nature of the models that are getting built, and how solutions will be incorporated. So from that point of view, I think sovereign models are great. I think we should have models as public goods, where public can have an opinion of what should get in and what should not get in.
So thanks for the talk. Very good. So one of the questions is like, did you also go from digital tasks to, let's say, tasks which some of these rural communities themselves are trained already, let's say some of the local things, and since you already have the infrastructure to reach to them and connect it to the market of some sort, did you think of expanding in that direction? Did you already try, or what was the challenges?
We, again, welcome to running a company. People constantly keep telling us you need to be more focused. Don't diverge. Be focused. So we have been sort of hyper focused on the language data stuff. But having said that, we have pondered. We do know the location of our users. So we have pondered location-based tasks. In terms of can people take pictures of like climate change related data can be collected with precise location. Can people take pictures of the soil and keep reporting that? I think we have explored that, but nothing in action yet. Yeah.
Okay. Thank you.
Hey. Congrats, Vivek, for the award. And I think we should give a special round applause because he's done an international travel now to give the talk, and you're going back and you're coming again. Something like that, right? Or you just went back? Something like that.
Yeah. I'm not happy about that, but
sorry, we had to force
that's
you.
That's fine.
Questions for you. Yeah. The first one is, what skills that you gained in PhD is helping you here? One. Second, you kind of alluded that funding is the challenge, but other than funding, what challenges is there to run Karya? Third, all of us are PhD students. Let's take some of us have interest in doing something, not necessarily this direction of crowdsourcing data or this language side, but just taking my PhD work and going lower the pyramid. What advice would you have?
Okay, so let me take the first question. I think, Professor Mosam, alluded to this as well. I think, when I look back, I don't know. I don't think this will go back to my advisors. When I look back at my PhD work, I think, there were a lot of interesting ideas, but even at the time, I knew that they will never see the light of day. Right. It was, it's an interesting academic exploration is what I would say. But it did give me like that principled framework in setting up a problem, thinking about, abstracting away the details. Yeah. So all that is definitely useful. But my biggest learning in switching from working on computer systems to human computer systems is, like socio-technical systems is the technical term for the field, but like human computer interaction systems is that humans don't behave. Right? Computer systems, you give them a task and it's very predictable. Again, I don't know how AI is going to change that notion, but when I was doing my PhD, I would set up experiments. Experiments would run as expected. If something fails, I know exactly what failed. I can go and fix it. But with human-computer interaction systems, it's a completely different ball game. So from that point of view, I would still say I'm a very nascent researcher, in this new field, and there are transferable skills. But man, everything had to be relearned. Like how to read a paper, how to write a paper. But I think that you have done that before. So I guess that's the very transferable skill, from my PhD.
Okay.
On your second question, there is sort of Karya the business, and then there is Karya the idea. I think the idea does not have any limitations. I can talk to you about business, as much as I want. I was telling somebody, while I was meeting them, my own trajectory was I was a researcher, and then when I started working on Karya, started building a prototype, so I sort of converted into a software engineer, and then I hired a couple of interns, and some full-time I transitioned into a software engineering manager, and then now I'm a CTO. Now I rarely get to do research, but what you quickly realize is when you're building a company, a lot of those bottlenecks in expanding the company starts showing up. So I think it is for us to grow up as a business. I mean, we're still a 3-year-old organization, but us growing up as a business is I think the idea works. I think if anything, all the evidence that we have from the last 3 years show that the idea actually works, and we can get high quality data from people in rural communities. We can benefit them with supplemental income. Just doing it at scale requires that business mindset. I think we are on the path to doing that. The third question, I think, is a tough one actually. Let me think for a couple of minutes, because I mean, even though I gave that advice, hey, go down the economic pyramid to see how much you can improve and you can impact societies. I mean, like when I think about my own PhD work, I just cannot think how I might have done that for work that I was doing during my PhD. Yeah, it's tough. I think I mean, my suggestion would be to just attempt it. I think there are many areas where, I mean, even today, when I was looking at the, some of the poster sessions and the topics that they were working on, I think it is possible, for even, I mean, it may not even be the work. I mean, you don't have to change anything about the work that you're doing, but the way you expose the work, to the communities, the way you expose the work to people, because like I have interacted with a lot of not-for-profit organizations who just don't know what's possible, through technology. Right? So when you are talking about your work, and let's say your technology can enable something different for them, and when you expose it that way, and that reaches their ears, they will reach out to you, right? So you may not even have to change the work, so to say, but I think a lot of language work that is going on, a lot of AI work can actually, I think, very easily, fit into the framework of expanding your, impact circle, in my opinion. Yeah, systems work. I think if you're working on building a chip, I think there was some kid working on this NVIDIA or GPU CPU sync. I have no clue how that can, I would even start to think about expanding the framework. But yeah, I mean, yeah, if I had to revise my advice, I would say definitely think about it. I think because we need more people, to be looking at problems faced by the bottom parts of the economic pyramid. I mean, that much is very clear to me.
Thank you, Vivek. I don't want to thank Vivek's parents, if I could ask you to stand up. So think about it, like think about parents from 10 years back having gone to IIT Madras, CMU, and coming back and working in villages, right? I'm sure there have been a lot of sort of shocks in many of our parents. So thank you for raising someone with such values and sort of impact and conviction. So you should really feel proud about this. Yeah, wonderful. Yeah, thanks, Vivek, again.
Okay.
Right.
Yeah, one last
question. I don't know.
One last question.
There one last question.
Oh, one last question. Okay, we'll get that question.
Yeah, very impressive. Thank you so much. I think one question for you. So you talked about all this delegating some of the work to rural, like women and so on, right? A lot of these tasks which you talked about is mostly not time bound, right? How do you really accomplish these kind of things when it comes to like time bound tasks and so on, right? More like digitizing things and so on, right? Like scale it up.
Can you repeat that?
So like the task which you talked about, like delegating to rural folks and so on. What happens if you have some tasks which are going to be time bound? Time bound, you have to complete them within a certain time frame and so on. Are you able to scale it up to that kind of?
Yeah, I mean, I think again, if I think about the business, side of things, I mean, clients have deadlines on, hey, I want the data by, I don't know, within a month or whatever. So we set up redundancies within the system. As you know, we give stricter deadlines to our communities, and I mean, tasks expire on the platform. So if you don't finish the task by some time, it'll expire, and then it'll be reassigned to somebody else automatically. So we do have redundancies that way to ensure that we are able to get the data, and we also over provision. I mean, client wants X data, we typically over provision 20%, 30%, depending on the nature of the task, so that we have enough data to give back to our clients.
Thank you so much.
Yeah. Okay. Thank you so much, everyone. Yeah.
Right, before we let Vivek go, a small token of appreciation from ACM India. So thank you so much for your talk, right? And yeah, it has to be a photo op.
You want in front of that?
This is good. This is beautiful.
You want in front of that?
Yeah, of course. We should. Thanks again.
Thank you so much.
Yeah. Break for lunch. So okay, this is on. Great, thank you. How many of you here are ACM members? Show of hands. Okay, good, a handful, but it has to be a lot more, right? So this talk is going to be about what, can you just take us to full screen? What it takes to be, what's ACM, right? For those of you who don't know about it, and also why you should be a member, right? I'm Yogesh, this is Maria, right? And we are both coordinating the committee on chapters and membership on behalf of ACM India Council. And for those who didn't know, ACM is one of the oldest computing societies in the world. It was created around the same time as we got our independence in India, 1947, and has over 2 million professionals worldwide who are part of various ACM activities, right? A lot of them are in the US, but India is one of the largest growing section of ACM membership worldwide, right? The ACM India Council itself is sort of the India-focused wing of ACM. So in India, we have over 17,000 members spread across students and professionals. Tomorrow is ACM India's annual event, right? So that's where we sort of have our annual congregation, where many of the awards, recognitions, and so on will be presented, but the ARCS is sort of a build-up to that. As we stand, we have Professor Meenakshi D'Souza, who's the president of ACM India from IIT Bangalore, PK from IIT Hyderabad as our vice president, and Sachin Lora from TCS Research as our secretary treasurer. As I said, India is about 11% of global ACM members, but our student wing is a third of the entire global population.
And
right?
it's growing at the rate of twice every year, right, doubling every 2 years.
Right, every few years we've been doubling the student population. So, which means we need to get more of you engaged as part of
So we would like to discuss, right, what benefits we can provide them and how each one of you can contribute towards ACM.
Absolutely, right? So one of the things that you get to do as part of being an ACM member is be part of these various student chapters, right? So as you can see, we have over 250 student chapters at various colleges. These are college-based chapters. And how many of you know if there's an ACM chapter in your local college, right? A handful of you. So this again should change, right? So because why should you be part of this, right? So one of the reasons is that the fact that you're here today, right? You're making use of an opportunity that ACM is providing, ACM India is providing. Because ACM, like many other professional societies, is a volunteer-driven society, right? So we are all working part-time, taking a slice out of our regular day jobs or our personal lives and so on, so that we can help build a computing community, right? And that's one of the biggest things. It's a volunteer society. It's part of being able to give back to your peers, right? So those who are in other parts of the computing community, how can you help them out, right? Is one of the key aspects of what ACM does, right? And we also have a bunch of benefits that you get being an ACM member, everything from getting access as a global member per se. You get access to various I think things like tech news that you get access to various ACM conferences that many of you might have attended as well, right? But ACM India specifically also has India-specific events which are uniquely tailored for our sort of developing countries' needs, right? So one of these is a bunch of research activities or research facilitation activities that we conduct, right? A very popular one is ARCS. So many of you here are already in a good shape in your research, but for each one of you, there are probably 100 or 200 students in more aspirational colleges who don't know much about what research is, right? So ARCS is about going to each of these colleges and trying to get them familiarized with what research is so that they can also think about pursuing a research career.
So for those of you, right, who are here, who are part of ACM chapters, maybe once you go back, you can have a ROCS event in your city and explain to them what are the benefits, right, of being part of the research community.
Absolutely, right? And similarly, you have things like PhD clinics and Anveshan Setu that gives opportunities for PhD students from, again, emerging colleges and choice of being mentored by faculty from more prestigious universities, like many of you have the opportunity to already being supervised. A lot of you might sort of be presenting conference, like papers at top conferences and having publication charges for journals and so on. So ACM India does provide travel grants as part of enabling research and enabling travel and so on to top-tier conferences. We also have the research awards, like you saw the earlier career award presentation right now. We have many such awards, which will be, we've had talks from the speakers in the last couple of days, and the awards themselves will be presented next week, tomorrow, right?
So how many of you here have availed of any of the facilities, right?
Travel grants,
right.
PICs, right? Good, so all of
Great.
you should become members if you're, right? Similarly, there are educational events as well. So the winter and summer schools are fairly popular. There are about at least 5 or 6 that happen twice a year. And the recently concluded winter school. Yeah.
And we have 2 of them which are exclusively for girl students.
Absolutely, right? So we had AI in finance at IIIT Hyderabad and then AJI at IISc. And these had more than 500 applicants. We could only accommodate about 100 of them.
So
as
the
you can see,
responsible AI, right, was exclusively for women.
right. So we do have several of these activities which, again, benefit the broader student community all across India, right? Of course, there are also conferences that ACM India supports directly. ARCS, which you're part of right now, is an example of that. You've got COTSCOMAD, which is part of the IKDD SIG in India. You've got Compute, that's more education-focused, and so on, right? So these are on top of the various ACM Global sponsored conferences as well.
And
right?
we have SIGMOD coming up very soon.
Absolutely, right? So that's one of the nice things of being part of this volunteering society. The fact that SIGMOD is coming to India for the first time in Bangalore is because we have a strong volunteer network in India, right? So by being part of this volunteer network, you can make such big things happen to enhance the computing community within the country, right? As we mentioned, we also have student chapters. Essentially, a few of you, if you're interested in conducting activities within your local college, chapters are a great way to sort of do that. So it's very easy to start a chapter, harder to maintain it. You should sort of be willing to put in the time.
So once you guys go back, right, we would like each one of you to start an ACM chapter in your college. So what you basically need is you need a faculty advisor and you need 15 ACM members.
That's it. And
It's
it should
that easy
be able to
to
get
get
going,
started.
right?
And we are here to support you guys.
Absolutely, right? And we do have, once you're a chapter, you can start hosting eminent speakers, like many of the speakers that you saw in the last few days. They're actually part of the ACM eminent speaker panel, right? We have about 50 speakers who are part of that. And they're all available for you to sort of invite and host as part of an ACM chapter for giving talks or having workshops and so on.
And to host an event, right, we also provide funding. So this is the activity-based funding that you can request every 2 months, right? We have a 2-month cycle. And so please take advantage of this once you become a chapter.
It's not just providing the human resources, but also the financial resources to organize events as part of the ACM circuit. We also have the ACM Chapter Summit that happens once a year where 200 plus chapters come together. Sort of, it's another networking opportunity. We had the last one at Indore. We had 300 plus folks
So we
attend.
have the regional groups as well, right?
Yeah, and we do have regional groups. So this is a way for you to network amongst your peer group from across India who are all part of the same computing community, right? ACMW is again very strong.
Right. So we have, according to the report, right, from the World Bank, women make up less than a third of the world's workforce, and we at ACM would like to make some efforts in changing this, right? So to this end, we have a number of events and initiatives that we run. We also have an ACMW chapter that you can form at your college. And we have Gitanjali here, who's part of the ACMW. She leads the ACMW initiatives. And if you guys would like to start an ACMW chapter, we are here to help you guys. So these are some of the flagship events. We have the celebrations of women. We have Lady Ada programming contest. We have the hackathons. We also conduct grad cohort workshops, as well as the ACMI ACW annual summit, which is co-hosted here at the annual event.
And lastly, ACM is all about volunteering, right? Because at the end of the day, we are all doing this so that we can benefit the broader computing community. So if not for anything, and that's really the key reward mechanism, right? There's no one forcing you to say, hey, be an ACM member. Many of the things that ACM offers is open to everyone, not just for members, right? But at the end of the day, it's about being part of the change that you want to see, or being able to give back to the broader community. So that's one reason why you should become members and become part of chapters and so on, right? So for those who are interested, of course, there's a link available on the website. You should be able to go take a look at it. But for those who prefer taking QR codes and sort of pictures, there's a ready sort of link that you can take a picture of. So we leave it over here, open over here.
Right.
But I do want to sort of encourage all of you to think about becoming members and start actively contributing to this community.
So I started being a student member as well, in 2009, and then graduated to professional membership. So, and it's been really good for me, building up the network and even helping me in my job search.
Absolutely.
So this is something companies actually look out for, professional memberships, and how you have added value to this.
Okay.
So thank you everyone for being here. And thank
you.
Yogesh.
And do reach out to us if you have any questions on getting a membership or starting a chapter. Sure. Now we break for lunch. Thank you.
Thanks.
Oh yeah, there's one more announcement.
Yes.
Yeah.
Right, so almost there. Just a quick thing left, which is that some of you actually need to fill the travels reimbursement form. And do you know that procedure already? No, right? So we'll just take a segue right after lunch, and or within one of this. Any case, it is supposed to be now, but I don't think it's Avijat here. Okay. Yeah. If he's outside, then we can possibly just, actually, you know what? Just go for lunch, come back, and then we'll just do, between talks, we'll announce that. But before you leave, if you're looking for travel reimbursement, before you leave, you should know the procedure, which will be disseminated today. Okay, thank you.
So this year's winner is Dara Thakur. She is currently a designated assistant professor at Graduate School of Mathematics at Nagoya University, Japan. And her PhD was done under the supervision of Professor Bireshwar Das at IIT Gandhinagar. And Dara's interests are largely in theoretical computer science, algebraic computation, quantum complexity theory, group theory, and so on. So let me read the citation of her doctoral dissertation award. It says that her dissertation titled on computing optimal representations of finite groups makes breakthrough contributions in computational group theory, including design of optimal data structures, minimal generating set computation, on complexity theoretic insights into minimal permutation degree. Her dissertation has resolved long-standing open problems at the intersection of group theory, algorithms, and complexity theory, and has led to interesting follow-up work that have gone on to answer additional open questions in this area. Okay? So please join me in welcoming Dara Thakur and congratulating her for the DDA award.
turn off this mic?
Go ahead.
Yeah. Hi everyone. Thank you, Professor Venkatesh, for kind introduction. Yeah. So I am Dara. I'll be talking about on computing optimal representations of finite group. This is also the title of my thesis. So before I start my talk, I would like to take this opportunity to thank ACM India for this recognition and also for this honor. And I would also like to thank the whole team of ACM India for for the support, and I would like to thank TCS for sponsoring my award. Yeah, so with that, let me start. So during this talk, I will follow this outline. So initially, I will tell you the problems, why these group theoretic problems are interesting, or why I am interested in such problems, and then I'll tell you the problems that I have studied in my thesis. These are the 3 problems that I have studied, and then at last, if we have time, I will tell you a bit about this theorem, which is known as the classification theorem of finite simple group. This is one of my favorite theorem from mathematics, and I'll tell you why, and then I'll conclude my talk. Okay, so just to give you an overview, you might be wondering why why do we really care about these group theoretic problems, right? So group theoretic problems, the groups capture symmetry, and symmetry appears in various disciplines, not just in mathematics or computer science, but also in cryptography, structural biology, or also in various other disciplines. But why do I care about this problem? So the reason I care about this problem is from theoretical computer science perspective. So when in complexity theory, when you want to study algorithmic problems for problems which captures symmetry, then it relates to group theory. And perhaps the most interesting and most famous example is the graph isomorphism problem, which you might have already heard about it. So it is one of the most fundamental and most celebrated open problem in computer science and mathematics. This problem asks you the following, that you have given 2 graphs and you want to check whether these 2 graphs are isomorphic or not. So this problem has been studied since quite a long, and it is known to be in NP, but we do not know whether it is in P or not. So there are certain polynomial time algorithms for very special classes of groups, special classes of graphs. For example, when your graph has bounded degree, then you can solve graph isomorphism problem in polynomial time. So this was a work by Lux in his 1982 paper, which was also based on Babai's 1979 paper. And this was the first time where the serious group theoretic algorithm or group theoretic ideas come into the study of graph isomorphism problem. Later, Babai and Lux also designed moderately exponential time algorithm for general graph isomorphism problem. And then after 30 years, Babai gave a breakthrough result that solves graph isomorphism problem in quasi-polynomial time. So you can see how long it takes to reach to quasi-polynomial time algorithm from this moderately exponential time algorithm. And this also uses, all these results also uses group theory, especially algorithms on permutation groups. So then, so even though we know quasi-polynomial time algorithm, we still do not know the answer to this question, whether the graph isomorphism problem admits a polynomial time algorithm or not. So then what do? We can try to understand more simpler question than graph isomorphism problem. And one of these simpler question is the group isomorphism problem. So this is a special case of graph isomorphism problem. And here you have given 2 groups and you want to check whether these 2 groups are isomorphic or not. As I said, graph isomorphism problem, it took more than 30 years to come up with a quasi-polynomial time algorithm, while this group isomorphism problem admits very easy, like 2-line quasi-polynomial time algorithm, which I'll not go into the detail, but the question here is we still do not know whether it admits a polynomial time algorithm or not. So then what is next? What we can ask is, what about the other interesting problem which could be like similar or quite close to group isomorphism problem somehow in nature. So then there are various interesting problems. One of them could be the group membership problem, where you want to check membership of an element in a subgroup given to you. Then there could be this fundamental problem of factorizing group, where you have given a group G and you want to factorize into the smaller groups. All these problems known to be in P, but there are various fundamental problems which we do not know answer to, or in general we do not have better algorithms or data structure. And those are the problems that I have studied in my thesis, and we will see in detail now. Okay, so before I start the technical part, let me just introduce what is group, because that is what we will use a lot. So a group is an algebraic structure. It is a finite, so we will consider only finite groups. It is a set, a finite set, together with a binary operation. A binary operation is a function from G cross G to G. And it satisfies certain property like closure, associativity, identity, and inverse. Okay, so before I move to the technical part, you might be thinking that it's a technical talk, but I will try to not make it boring, and I will try to reduce the technical thing. Okay, so let me just, okay, you might have seen these groups, right? For example, this cyclic group of order n, then symmetric group on set 1, 2, 3, and then group of invertible matrices over field ZP. So with that, let me start with the first problem that we have addressed. It is called linear space data structure for finite groups. So when we study algorithmic problem, the first question we will ask is how do you represent your group as an algorithm to as an input to an algorithm, right? So there can be multiple ways of representing your group to an algorithm, and one of them is this Cayley table representation, where your group is given explicitly by this n by n array, or for example here it's Z4, so this 4 by 4 table. So if your group is of order n, this table, it's easy to see that this will take order n square space, right? And you can still answer queries in constant time. By that I mean at any point of time, if you want to take product of two elements, you can just find the entry at the intersection of that row and that column. So that is we call queries. So this representation answers queries in constant time, but it takes space order n square. So the natural question one can ask is, what about the better data structure? Can we design a data structure that only uses little o of n square space but still answers queries in constant time? So before I go into this question, let me just tell you the model of computation we are working with. So here in the model of computation, you have given a Cayley table of a group G. You will do some pre-processing beforehand, and you want to come up with a data structure that stores your group, and it should have this property that it should still answer queries in constant time. Okay, so this problem has been studied long ago, since 2006 by Farzan and Monroe. They gave an information theoretic lower bound that says that if you want to store a group whose order is n, it will take omega of n space. Okay, but there are improvements in this result. So there is a result by Das, Sharma, and Vaidyanathan that build a data structure which uses this much space, but at the same time their query time is not constant, so it is 1 over delta. But they do have a better data structure where the query time is constant and the space is linear, but only for certain special classes of groups, where you know a lot of properties about groups and you know the whole structure of the group. So then the following question was still open, that what about your group is arbitrary group? Let's say you have given any group G whose order is n. You want to come up with a data structure which takes only order n space, and you still want to answer queries in constant time. So in one of the chapter in my thesis, we solved this question, we answered this question positively, and our result also achieves the lower bound that is given by Farzan and Monroe. So what we have shown is the following, that if you have any arbitrary group G whose order is let's say n, then you can design a data structure which only takes order n space, but you can still answer queries in constant time. So I'll not go into the detailed proof of this theorem, but you can read my thesis if you want. So with that, let me move to the second part, which is on the complexity of the minimum generating set problem. So before I define the problem, let me just give you an example. So this is a group Z4. And the binary operation is addition modulo 4. So let us take a special subset T, which only has an element 1. So it says it is a subset of size 1. Now you can see that this is a special subset because it generates all the elements of your group, right? So using 1, you can generate all elements of Z4. And such a subset we call a generating set of a group. So here we denote it by angular brackets, and since 1 generates G, so angular bracket 1 is generating, it generates the Z4. So let me just quickly define the the definition of a generating set. So in general, for any group G, a subset T of G is a generating set if it generates every element of G with finite products of elements of T. And since there can be many generating set of a group, this motivates the following definition. What about the generating set whose size is as least as possible, which is, we call it as a minimum generating set. So minimum generating set is a generating set whose size is the least possible size, and we denote the cardinality of such a generating set by D of G. So it's an invariant of a group G. You might have seen this group. Okay, so I'll ask you some questions after this in this slide. So you might have seen this group, right? A symmetric group. It's a group of n permutations on 1 to n. You also know that it has a size n factorial. Now, even though it has a size n factorial, you only need 2 elements from Sn to generate the whole group whose size is n factorial. Now, this is a group which contains all permutations on 1 to n or all the bijections on 1 to n. But we can, let's for example take A5, n to be equals to 5. Then A5 is a group, a subgroup of S5, which contains only even permutations. So S5 contains all permutations, but here we are only interested in even permutations. So the group size has 5 factorial by 2, which is 60. Now, even this group only can be generated by 2 elements, and these are the special 2 elements that generates A5. So let us take a bit large group, which is you are considering A5, but now you are taking products of A5 20th time. So you can see the order of this group is 60 to the power 20. So anybody would like to guess what will be the size of the generating set of this group? No? Just a random guess. It's just 3. And now, let me give you one more chance. So let us now consider such a large power, which is 6464040. Now, anybody would like to guess the size of the generating set for this group, a minimum generating set? Yeah, thanks. 3, no, you are too optimistic, it's 5. Yeah, but you can see the behavior, the curious behavior of this invariant of a group G. So we do not know any like formula, or we do not have better behavior of this invariant of a group G. So as a theoretical computer scientist, we are interested in designing algorithms that compute such a generating set, and which motivates the following question, which we call it as a minimum generating set problem. So here you have given a group G, and you want to compute a minimum generating set of a group G. So there is an easy quasi-polynomial time algorithm that solves minimum generating set problem, and it's also similar, quite close to the quasi-polynomial time algorithm of the group isomorphism problem. But we do have better algorithms for certain special classes of groups. For example, if your group is a solvable group, you can have polynomial time algorithm that computes a minimum possible size generating set. So this algorithm is actually by Lucchini and Menegasso, but the idea that they have used coming from Gashu's 1959 paper, and they also attributed these ideas to his paper. So this line of work started by Gashu's in 1959. And solvable group, you can think such groups as like not far from being abelian. So these are certain special group class. But the following question we do not know answer to is the following, that what about suppose you have arbitrary group G, given by Cayley table, can you come up with a polynomial time algorithm which computes a minimum generating set? Or can you show that minimum generating set problem belongs to P? So other part of my thesis studied this problem in depth, and we answered this question positively. So we designed first polynomial time algorithm that solves minimum generating set problem. The theorem is as follows. So you have given any group G by Cayley table. Then our algorithm computes a minimum generating set in polynomial time in the input size. Are there any questions? Yeah. Yeah, so you can, if you want to be more efficient, the polynomial is n to the power 5 or something. Yeah, 5 or 4. You can make it as like 4, as least as 4. No. In fact, that can be improved, and now there is a recent work which shows that our algorithm can also be in NC. Yeah. Okay, so with that, let me just move to the next section. Here, so I'll define this problem later, which is known as the minimum permutation degree problem. The name sounds technical, but it's easy. So let us start with this group Z3. So ideally, we should write 0, 1, 2 as an element, but modulo 3, 0 is 3, and I am using 3 as a 0. So what I want to do is I want to come up with I want to associate permutations for each element of Z3. So for that, I can define a function for each element of Z3. Let's fix some element. I will define a function from Z3 to Z3. So this function takes any element of H, it adds G to H, and then we take modulo 3. So this is a way of associating permutation to every element of Z3. So now you can see if you fix your G to be equals to 1, the image of 1 under LG will be 2. Similarly, if the image of 2 will be 3 and the image of 3 will be 1. So you will get a permutation which takes 1 to 2, 2 to 3, and 3 to 1. Similarly, if you fix G to be equals to 2, you will get this permutation which is 1, 3, 2. And if you take fix G to be equals to 3, which is identity element, which is 0, you will get identity permutation because 3 modulo 3 is 0, so H will be H. LH will be H. So this is a way of expressing your group as a permutation. And this also gives rise to this interesting representation which we know as permutation group representation of a group G. So what you do is you can represent any group G using certain permutations from Sn. Here we have Z3 and we were representing it using only one permutation which is 1, 2, 3 in S3. So you can see that this G is a subgroup of Sn, and Sn has order n factorial, right? So this G could be of size at most n factorial, but the set that you are representing with, the whole group G, has size that only needs this permutation pi 1 to pi t, and you can see that you can show that this t cannot be large. So you only need log mod G many permutation in worst case, and each permutation requires order n length word. Each permutation is order n length word. So to represent the group whose size can be n as large as n factorial, you only need poly in n comma log n many words. So this can be more space efficient representation of a group. But the question you can ask is the following, that how do you guarantee that every group can have such a representation? So there comes this theorem from by Cayley. It is a theorem from elementary group theory, so first course in group theory. So this theorem says that for every finite group G, you can find a copy of your group G in some Sn. You don't know what this n could be, but this guarantees the existence of Sn. And as I said, we do not know what this n can be. It could be as large as order of G, but we want to know what the minimum n, what is the minimum value of n. And there, that motivates the following definition, which is a bit, the name is technical, the minimal faithful permutation degree. but it is simpler. So it is a least positive integer such that you can find copy of your group into SM. So Cayley's theorem shows existence of such things, but we are interested in finding a least positive integer where you can find a copy of your group. And as I said, this mu g is at most mod g. Mu g is the least positive integer where you are able to find a copy of your group. It could be at most mod g, but in general, we want to know how efficient Cayley's theorem is. So Cayley's theorem is efficient only for very specific classes of groups, these 3 classes of groups. It is efficient. So there you actually need mod g many elements in your set. But what about other groups? And we know it is for other groups it is strictly less than mod g. So then this motivates the following problem, which is computational, again a computational problem, where you have given a group G again by some special permutations in Sn, and you want to compute a least positive integer such that the given group G is a subgroup, or you have a copy of your group G in S mu G. So that's a computational problem. It has been studied in the literature, especially it was studied by Cantor and Lux in the 1990 paper. So the only thing computationally we know is that this problem is in NP, but we do not know any other computational progress on this problem. And they also mentioned in the same paper that one requires new mathematical tools to solve this problem in general, but then they ask, what about the spatial classes of groups? So we consider a very specific class of group, which we call a group without abelian normal subgroup. Sorry, not we call, it is a already well-studied group class. So there are various papers, especially this group class has received significant attention from computational complexity community, and it is very well studied. So for this group class, we designed a randomized polynomial time algorithm that find the least m or mu g so the mu g is the least positive integer where the given group G has a copy in S mu g. So our algorithm is randomized polynomial time algorithm, and this is a result that was part of my thesis, but very recently we also de-randomized this algorithm, and we show that it is in fact can be doable in NC. And we also show a little bit more general result, which is part 2, but I won't go into the detail. Okay, how much time I have? Okay. So let me just, since I have time, I'll tell you a bit about this classification theorem. So this is a theorem which all the chapters in my thesis we have used either directly or indirectly somehow. I also, this is one of my favorite theorems. So let me just quickly tell you why and what this theorem is about. So the name is the classification theorem of finite simple group. Let me just quickly define what the simple group means. So in group theory, simple groups are groups which do not have any non-trivial normal subgroups. If you don't know non-trivial normal subgroups, you can connect this with primes. So primes are the integers that are building block. Primes are building blocks of the integers, and they are numbers which you cannot further factorize. Similarly, simple groups are building blocks of groups, and those are groups which you cannot further factorize. So in mathematics, we already have seen these 2 examples of simple groups, ZP and A5. So in mathematics, there is something called the classification theorem, which classifies all the simple groups. So they say, the theorem says that there can be at most 44 distinct families of simple groups. Out of 44, there are 26 simple groups whose size is constant. So those are good somehow for us, at least because we don't care about constants. But there are 18 families which are infinite families. And so these are the 44 families. Let me not go into the detail of what are these families, but that's what it says. The proof of this theorem started in 1832 by Galois when he first defined when he first introduced the concept of normal subgroups, and he also found the group A5, alternating group AN in general. So after series of works, a series of works and also decades of work, around 1990, people have claimed that we have a proof of classification theorem, but then there were people who found more simple groups, so that was not complete. But then, as recently as in 2012, there was a proof by Gronthier and his collaborators. They somehow announced the proof of classification theorem, and they gave a computer-checked version of the proof. So you might be wondering, so this series of works for over 2 decades, this proof of classification theorem contains more than 15,000 pages, and since it's long and not easy to understand, we call it as the first generation proof. But then people were interested in getting an easier proof, which we know as the second generation of the proof, which is also 5,000 pages long. So you might be wondering, after this 15,000 pages long proofs and also decades of work, what do group theorists get? So they get their own periodic table. So it seems like when we see this table, it seems like group theorists wanted to compete with chemists, and then they have designed a series of works, and this long decades of work, they designed their own periodic table. And this is the reason I like classification theorem of finite simple group. Yeah. Let me just quickly conclude my talk. Okay, just a minute. Yeah, so what we have learned today is the 3 optimal ways of representing a finite group. First, we have seen a better data structure or linear space data structure that represent your group and also answers queries in constant time. And with this result, we have obtained, we achieved the lower bound that was given by Farzan and Monroe. And this also closes the long-standing gap between upper and lower bound. Then we have seen a minimum size generating set for a group. We gave a first polynomial time algorithm that computes such a generating set. And this closes a line of work that is initiated by Gashus in 1959, around 70 years ago. And then we have seen representing a way of representing a group using permutations on as smallest as possible set. And there we gave a randomized polynomial time algorithm, and this was a work where it provides computational theoretic progress towards this question posed by Cantor and Lux, and it also opens several open questions. And at last, I haven't given you any proof detail, but as I said, we have used this classification theorem a lot, so we have also learned how such a beautiful theorem from group theory help us in computational group theory or in general in computational complexity. Also, before I end my talk, I'll also like to tell you that whatever I worked in my PhD, I have already presented, but recently I'm also working on designing quantum algorithms for problems, especially from algebraic problems. So recently we worked on this conjecture by Aronson and Cooperberg, which says that group non-membership is in QCMA, and our paper solves these conjectures. So if any of you are interested in discussing any of the problems or any domain that I'm working on, I would be happy to talk with you. Yeah, thank you. Any questions?
Okay, thank you, Dara. Are there any questions?
Hi, thanks for the talk. So like you said that recently you have been interested in this quantum algorithms. We see that like there are only certain kinds of techniques in quantum algorithms. You know, like for example, you have amplitude amplification or you have quantum Fourier transform. So like what is your outlook on maybe having new techniques using these group theoretic notions in quantum computing?
Yeah, so if you want to know more about one of the new technique, you can read our paper.
Yeah, sure.
Yeah, it is not using Fourier transformation or whatever you mentioned, but yeah, it uses lots of group theory.
Yeah, okay. Thanks.
Thank you.
Hi.
Hi.
Nice talk. Can you
Thank
give
you.
some insights on the polytime algorithm? What is the new thing that polytime algorithm for the minimum genetic set?
This one?
Yeah.
Yeah.
Can you say a few words on what brings it down from quasi-poly to poly?
Sorry?
What brings it down from quasi-poly to poly?
Yeah, so actually we used something called crowns from finite group theory. So the idea is in the quasi-polynomial time algorithm, you are trying all possible subsets whose size is at most log mod g. But we proved a certain theorem which allows us to try only few subsets. And our theorem also guarantees that one of those few subsets, set of subsets, will generate your group, and that will be the minimum one. So that will bring down from quasi-poly. We are not trying all possible subsets that can generate group, but only few of them. That is the idea. Thank you.
So,
Thank you for coming in. Congrats on the award.
Thank you.
My question, again, as PhD students, right? So, what was the most challenging part of your PhD thesis? That's the first question. And my second is, what advice do you have for people who are not working on theory, if you have any?
I don't know about second question, but
I wanted to put it as theory, but I thought I'll twist it. But anyway, you can pick whichever side you want.
yeah, for the first question, like challenges during my PhD,
Yeah.
right? Yeah, so the I don't think it was, so my advisor was very supportive to me. That was one of the benefit I had in my PhD. But the thing is, I came from a mathematics background. So when I joined my PhD, it was first time when I listened the word algorithm. So it was a bit difficult for me to understand or think in terms of algorithmic way. And also then COVID came, so it took 2 years of my PhD, but then we learned how to continue work online. So first initial 2 years it was difficult time, but then we managed to gradually pick up whatever we missed, and then yeah, it was like not difficult, but that was the only difficult part, that I do not have any computer science background, and I suddenly came into the world where everybody was just talking about efficient algorithms and all this stuff. Yeah.
That's impressive. Second question.
Yeah, the second question was the advice.
Yeah.
What advice to?
PhD student.
I don't think I am able to advise you guys, but yeah, so what I learned now during my postdoc is that when I was in PhD, I haven't paid much attention to like my health, going for exercise or anything. So I would like to tell you, like, spare some time on your health, not just. Like
We can ask them, no, how many of you slept for 4 or less hours last night? 5 or less hours? Look at that.
Yeah, so research is not the only thing that you have to do in your PhD.
Thanks.
You have lots of time.
So let me conclude with one lesson and a question. One lesson from what she said is for faculty members who are looking for PhD students, go after mathematics students. I actually have a question on your first data structure question.
Yeah.
You focused only on the product query.
Yes.
What about other queries like inverse or something like that, if I want to support in constant time?
I think that will also be, as a byproduct, we also will
You can get that as a corollary?
Yeah, yeah. I think so. I have to check, but that's what I feel.
Okay.
Yeah, but we didn't mention, like, we didn't have that in mind. Thank you for the question.
Okay, so let's thank Dara again.
Thank you.
And okay, I have this. Small token of appreciation from ACM India.
Wonderful presentation, and thanks to the chair. We now move to a set of exciting talks from emerging research leaders. May I now invite Professor Chitra Babu to chair the session.
Thank you very much. Good afternoon, everyone. Good afternoon. Okay. So this session is a very interesting session, which is going to have 3 talks who are all early career researchers. 2 are from the academia and 1 from the industry. So this is going to be an interesting session for all of you in the sense that you are all at the same crossroads that is trying to decide which way to go, whether to take the academia road or the industry. So these people have weighed in the advantages, disadvantages, and analyzed the trade-offs, so which will be their insights will be very valuable to you. So the very first one is going to be by Dr. K.J. Joseph from Adobe Research. He's going to be talking on from ideas to A-star papers, a behind-the-scenes journey not often discussed. Very interesting topic, right? Everyone will have an idea, but to shape that to a proper paper which can be published in an A-star conference. So what happens, what kind of thought processes, you will get to hear from him. Now I will introduce him. So Joseph is a research scientist at Adobe Research in Bangalore. His research interests span multimodal learning, computer vision, and intelligent document creation. So he has authored numerous publications at leading venues including CVPR, ICCV, ECCV, NeurIPS, and several other such kind of AAAI and other conferences. His PhD thesis from the Indian Institute of Technology, Hyderabad, this institute won the ACM, IKDD, and IUP RAI Best Dissertation Award. So before joining Adobe, he was a student researcher at Google Research and also a visiting scholar at MBZUAI at Abu Dhabi. Yeah, so I'll welcome KJ Joseph. Yeah, please.
Thank you very much for the warm welcome. So, yeah, I mean, though I'm from industry, I'm just going to talk about as if I'm an academic who's just finished up my PhD, though I did it around 3-4 years before. So that's the context. I would like to start with a disclaimer. Most of the discussions that I'm going to have here and the tips that I'm going to have here would be primarily motivated by my experience, and my domain has been into computer vision and machine learning. I'm quite sure there will be many things that would translate to other domains too, but then, yeah, again, starting off with a slight disclaimer over there. So when we think about maybe doing research or writing papers, and getting accepted at top venues, I think some milestones along the way would be like, 1, maybe selecting the problem, maybe working towards a solution, and then, of course, writing the paper. I would say that it doesn't stop there, but it will go on to maybe even preparing a rebuttal so that you can actually turn around the reviews. And of course, I mean, there are a lot of post-acceptance things that you should probably do to kind of get your paper really into good shape that is noticeable by folks. So I'll just probably spend time on each of these buckets. That is the agenda for the talk. Let's get started, selecting a problem. I would definitely say that you should select something that you're really, really passionate about. So assume maybe PhD is going to be a roller coaster. Then this passion is basically a seatbelt that will kind of connect you back into your seat even if you feel that you're going to be thrown away. And maybe the second one would be more like, let's say, own the problem. I mean, it is your PhD thesis. It's not anyone else's PhD thesis, right? I'll just say, a few things. Along the way, I'll just give some experiences and feedback that I have got along the way, so that in case if that helps everyone. So I was a master's student here. I converted over to my PhD after a year or so. So during my master's, I used to work on a lot of object detection things, and then we had a paper at a workshop at ECCV. So I had some project funding, so I could travel to ECCV, and then I picked up continual learning from there, from a workshop over there. So once I got to know about continual learning, I just came back, and then I told my advisor, Vineet sir, Dr. Vineet Balasubramanian, sir, this continual learning seems to be a pretty interesting thing. Why not we work on that towards a PhD? I was like, yeah, of course, yes, why not? Let's do that. So from day zero, I was owning the problem because I proposed the problem to my advisor, and then if something goes wrong, it's my problem, all right? No one else's. So I would say that, let's say, I mean, we should definitely own the problem that we are kind of pursuing for maybe the next 3 or 4 or 5 years. And I mean, like, it's just a little bit more practical things to kind of how about maybe we go on, right? I mean, like, would be like maybe the topic that you may be selecting, ensure that it's not extremely saturated. And that's a function of time, right? I mean, at the point in time, like, is it extremely saturated or not? And for those, maybe you could get advice from your peers, your advisors, or others in the field. And then is definitely of interest to the set of conferences or venues that you are kind of targeting in. And maybe, and of course, don't kind of, start off like, yeah, let's have a small work, let's probably maybe try submitting it into some random conference and so on and so forth. Definitely not, it's a waste of time. So always keep shooting for the best conference or journal, depending upon your domain. And then it's okay to get rejected. That's a good feeling to have. I mean, I'll talk about that later, but it's okay to kind of, get rejected, but then you'll always be benchmarking against the best. And then you'll always have that experience of submitting there and then getting feedback, and then have some experiences to kind of move on. So always shoot for the best venue, and then even more practical thing, if you're going to start on a specific domain, then if there are some specific problem that you're working on, always look out for the latest and greatest paper along with their code. Try to run it up, try to set it up, so that you know where to kind of get started as you kind of go along. So maybe as we are kind of working, again, this is a 30-minute or 25-minute slot, so it won't be exhaustive, but then I'm just trying to give a fair overview about some tidbits along the way. Working towards a solution. So first thing, borrowing from my previous slide, set up your kind of a baseline so that don't actually try to start anything from scratch. Research, RE search is again searching for things. So again, let's start from what others have done. Maybe like very practically even for code bases, right? I mean, most of at least MLCV conferences and the papers, people are very generous in open sourcing their code. Start from that, play around with it, get a feel of it, understand things, and then maybe it will naturally help you to kind of build forward. So one thing is most of us, would face is when should I stop reading a lot of papers and when should I get into coding? Then it will be very deep inside coding, debugging a bug that some memory exception here and there, oh, I'm stuck with coding. So I would say that you should interleave these two things together, where you both of them could potentially help you to breathe one another. So always kind of interleave between your coding and your reading papers and whatnot, and then be very organized with your code and your research. By code, I mean you can use tools like GitHub. So very concretely, this is one of my papers that I had in CVPR as an oral in 2021. I'll use that paper as experience as one running example all throughout. But this is what I had. This is my, okay, pointers doesn't work. Maybe. Yeah, so here you can see that I still can see around, 6 years later, November is the CVPR deadline, by the way. November 14th or 15th is usually when the CVPR deadline is. I could see me frantically kind of adding new data sets to get some results, and then maybe having some new idea coming in for the last bit of the methodology, and then maybe saving something to the feature store and getting the results for the incremental object detection and whatnot. And at any point in time, you have this code base, and then you're trying out something that doesn't work. Of course, just branch off, and then you come back to your main branch, or you just ignore some commits. So it's very important that you maintain a proper coding structure, coding strategy, and things like that, so that things will get much easier, with such an approach. Perfect. And then let's moving on. I'm stuck. I'm doing a research. I've been spending a lot of time trying to kind of implement it. I'm not getting the results that I'm expecting. What should you do? I think most obvious, run to my advisor. No, I would say no, just wait. First, talk to yourself. I think this is one very important trait which I think all of us should start embracing. Talk to yourself. You can be your best reviewer. You can be your best friend. what I would do is just go back to a whiteboard with a pen and then start writing down things. And in most cases, maybe after an hour of ideation, you'll just think to yourself, why did not I see this before? I mean, this is quite evident now. Like, this is the next thing that I should do. So always start talking to yourself and write things down. So, I mean, maybe, let's say, at least during my PhD, right? I mean, most of my conversation between me and my advisor was via messaging. I mean, like messaging, not like WhatsApp or anything, but like we use Google here, so Google Suite here. So like in Gmail, you go and chat. So I could find that if it was a 5-minute phone call, you don't know what you said, you don't know what the advisor said, it's lost, it's completely lost, it's a waste of time. But if you have some concerns to kind of talk with your advisor or your colleague, the moment that you start drafting it down, you will start thinking for yourself, am I telling the right thing? You'll get a lot of things will be clarified, and you will start asking the right question. So when writing things down is a very powerful tool, and I believe, I mean, like just sharing that with you. And then if nothing, I mean, if this is the case, then like, I mean, maybe it's a good time to kind of start discussing with others. And then you really know what's the right question to ask, and then they will be able to help you with it in the right, let's say, volume. And then please don't expect anything from anyone. And then if they are kind enough to help, be very grateful to them. So I think it's all about expectation, right? I mean, yeah, I mean, this is person X with that persona, he's supposed to do that, he's not doing that for me. No, I mean, it's okay. I mean, so always own your work, and then it's your stuff. If someone is helping you with it, I mean, thank you, that's it. So, and then just like being organized with your code, I would say that be organized with your work. So we are not like, let's say, I think the caricature of a PhD student to maybe keep on working on some corner of a lab, undistracted with Wi-Fi and then laptop with charge and disconnected from everything else in the world. It is impossible. We all have families, or maybe we are maybe TAing for some courses. There's some assignment deadline. You might be taking some other courses. So it's all about, I mean, be ready to be distracted. Be ready to be disturbed. So unless and until you have I mean, like, if you think about operating system, right? I mean, when you're running a process, you have a single process. I mean, all of us have a single processor, right? I mean, I think multiple cores and so on and whatnot. But then, I mean, like when we are about to kind of switch on, do context switching, we will just save the context, current context, and then reload that context whenever I'm done with whatever disturbance that comes in. So let's do the same thing for our research. At least personally, I kind of tend to use a lot with simple sheets, I mean, Google Sheet. So again, that's CVPR work. I know even now that I started working on it March 15th. I mean, okay, the deadline was in November. I started quite early, trying to kind of formalize it. I was just reading up some papers very, very early on. I know what papers they were. And then it's not like someone asked me to do this. No. It's not like your advisor asking you to log every day's work. Definitely not. It's not for that. It's just for yourself. It's just for your context switching for yourself. And then, like, whenever I meet my advisors, I can say, okay, so these are things that I discussed with my advisor. So it's not like things are in the air and then we just forget what it is, right? So and then, I mean, even now, I mean, if you see here, this is a sheet. So you have each sheet for, I mean, like each section, right? So I kind of had, like, this is how my methodology evolved. I had just some ideas, a few 6 ideas, and then in the second version, I know why I added certain things into the algorithm, and then why, and this is the kind of a final algorithm that kind of I had. And at any point, my advisors can also step in. So they know what I'm doing. There's a common repository where, let's say, all of us are putting in our thoughts. Like, I mean, hey, Joseph, I mean, what is this logic for? Like, yeah, I mean, of course I can. I mean, the deleted user is me. My IIT Hyderabad account has been expired. Anyway, so you get the idea, right? So stay organized. Stay organized while you are doing your research. That can help with your context switching. So assume then you have some good results and so on and so forth, and then you are about to write your paper. And some follow-ups to what we discussed in day 0, right? I mean, have a skeleton for the paper first. So I go back to Sheets, and then for that specific paper, for the methodology, I was like, okay, these are the things that I should discuss. And maybe for the evaluation, I mean, like the things in red is like, maybe I should ask someone else for some feedback and whether I should include it or not. And I mean, this was for another work, recent work. It's like, here the thing is, each line would potentially translate to one line in the paper. But then now here, the good part is I need not follow English, or I need not follow everything to be perfect. I can have as a skeleton, I have the full paper in mind even before writing the paper. So I have the entire structure of my paper, and this helps with whatever storytelling and so on and so forth that you might have to do to kind of perfect things. So I found this pretty interesting. So here you can see that, let's say wherever the pointer is right now, I decided not to go with this. I mean, maybe it's not a good thing to kind of talk about here, but maybe talk about somewhere else. So that is that, and maybe another tip that I found very interesting is like, draw your figures and maybe algorithms first. Drawing figures or maybe architecture diagram if you have, once you draw it, a major part of your methodology is done. And then the writing can follow that. The writing can follow the expanding different parts of the method and so on and so forth. If it comes the other way around, it's like you already have written everything. I don't want to change that. I mean, let me align my architecture diagram somehow so that it can adapt. No, it's not. It doesn't flow well. It doesn't read well. So let's have the figures first. And maybe if there's algorithm. The beauty of the algorithms is like once you finish a proper algorithm, you'll be done with all the notations. You have every notation ready. And then maybe you'll use the notations back in the figures or everywhere along the paper, so there'll be consistency across the whole paper. So, and then I think in certain parts of the paper can potentially start even early. So the best time to write your related works is when you start off your research, when you're actually looking for all the related papers and whatnot, right? That's a real best time to write your related works. And then if you have some points along the way, right? I mean, there's another good reason to kind of have a skeleton first, and that too early on. Is like you can keep adding on things. I mean, you might say, hey, I mean, this specific niche, maybe it should be expressed much more impactfully in the introduction. Then maybe have that just one bullet point inside your skeleton that you have. So it really helps you kind of plan yourself. So and then the TLDR is like paper writing exercise is not something that you can start 2 weeks before deadline and then just finish it off. So it takes effort, and then having the skeleton would really help you to kind of be planted. And then plan to finish at least 1 week before deadline. I know that even finishing 1 hour before deadline would be hard, but the good part is like if you like. So I during my PhD days, used to at least finish off at least 2 to 3 days before, so that I could get it to my advisor and then maybe at least get some feedback from him before moving on. But I mean, this time I had an intern over the summer. We made it very clear. Like if you're not going to have a paper 1 week before deadline, we're not going to submit it. That's it. Thankfully enough, he took it seriously. And then we had a paper 1 week before deadline. And then the good part is like, we had a whole set of co-authors from industry, right? So like, we have some folks in our lab, and then their PhD advisors and so on and so forth. We are a very open lab, so also contribute. So it's like, so 1 week, in 1 or 2 days, like we kind of floated around the advisors, got their feedback. Everyone has time to give you feedback. It's just that if you rush in the last moment and say, hey, my advisor does not give me any feedback, what can I do? It's because it's all about time. Everyone has just 24 hours in a day. So anyway, so try to get it, plan to finish at least 1 week before deadline, but it's okay. Of course, so then you had your best paper, you submitted to a conference, 3 or 4 people reviewed your paper, and then now you got your reviews. Borderline accept, borderline reject, weak reject. The major question that gets asked, like, can you kind of, turn it around? Of course you can. I think rebuttal writing is also an art, I believe. And I'll just give you some concrete things. So this is how at least in CVML community, this is how we start writing the rebuttal. The first paragraph would be like, let's say, so why rebuttal, right? You're just talking to the AC. I'm not sure how many reviewers will actually go back and review the paper. So if there's an AC will say, hey, AC, come and look here. It's a novel approach. R1, R3 told this. The score details are very interesting and worth the explored. R2 told this. All of them kind of, did something else and so on and so forth. So it sets the tone. And then while you address your reviewer comments, I would strongly suggest to kind of bucket it in terms of reviewers. Just think about it. They have 4 or 5 papers to review. They have reviewed this paper 2 months before. They have absolutely no clue on what this paper is. Now they get an email saying that, hey, reviews are uploaded, the feedback is rebuttal is submitted, you go and review it. They will not have time to kind of squint through the whole paper, so even the rebuttal, right? So bucketed per reviewer, everything for review 1 ends there and reviewer 2 ends here. And of course, if there are some cross-references, right? For instance, like energy motivation, kindly see R2 role of energy. You can actually do that too. But this makes the life of maybe my R3 better, that they will understand where to look for and not necessarily read through this really cluttered document. So that is that. And hopefully your paper will get accepted. And then it doesn't stop there, it's actually starting there, right? I would say that, we have tremendous, we create a web page for it. Create a YouTube video for your paper and then put it online, and then make your code and models public. So I'll just give some context. So this is that work, and this has actually got a with over 1,000 stars on GitHub. But the part is it doesn't happen like that. And I think it kind of correlated to maybe around 789 citations as of today. But it's not actually happened like that. It's like there are a ton of bugs not bugs really, issues that get created. And then it's not just making up code public, it's just half the job. You have to be really, really involved in trying to kind of address others' feedback. Maybe if they have, if they point out something, if it's actually missing, maybe implement that, or maybe clarify that even further. So you cannot be silent. So it so happened that, in 21 or so, I had COVID, and then I was actually off for close to 1 month, and then suddenly all my issues are piling up, and then people are getting really, really angry over there. Actually had to create an issue like this. Yeah, sorry, I was literally dead. 20% of my lungs were infected. So I'll get back. So this is a level of involvement that we should actually do. And then I'm very happy that that kind of involvement has kind of translated for the traction of the paper. So yeah, let me just move on, and then of course plan your talk. Okay, take it from me. Preparing for a 5-minute talk is even harder than preparing for a 30-minute talk. So prepare well. Of course, plan your travel, get your visa, and then enjoy your conference. So again, some milestones, and then of course we told the best Rossi story ever, right? You settle the problem, work towards it, write a paper, rebut, and then it gets accepted. So what if it gets maybe rejected, right? In most cases, if you have some strong feedback, we had a paper earlier at CVPR which got rejected, but all the feedbacks were very good. And then we work on those feedback and then submit it elsewhere. And it's actually a NeurIPS paper in 2020. So in most cases, all these rejections will add up to a bigger picture. I'll talk about that a bit later too. But yes, so this is the broader theme, what I wanted to say, and a couple of rapid fires. I generally feel all the failures are indeed blessings in disguise. So when I started off in 2017, I had submitted a paper to a conference of VACWI. Around 4 or 5 months after I joined. I had no research experience before. So VACWI has this round 1 and round 2. You submit a paper to round 1, you'll get feedback. You can improve that and submit that to round 2. So we submitted a paper in round 1, and then weak accept, weak borderline reject or borderline reject. I was happy. My first paper has someone said there's really at least some worthy of it. So we can work on it. So the next few months, we really worked on it. Perfected it to the maximum ability that we can. And then we thought, let's submit this as a fresh submission. I'd like to resubmit it. Even the entire theme has changed. So we submitted it as round 2 as a new paper. I got reject. And then, so you see, I'm a master's student, starting, I want to do research. It's interesting. But then it's my first paper submitting, and then initially got some positive thing, now got reject. Okay, it's okay. We submitted that to a conference known as ICIP, not that much a premier venue. So there, it was rejected, turned down from there too. And then we submitted that to a workshop at ECCV, and it got accepted, thankfully. And I got to go there and picked up continual learning, and that is connected to the earlier part of my talk. And that's how I got into this continual learning field altogether. So had my paper been accepted to WACFE or ICEP, I would not never gone to ECCV. And if I had never gone to ECCV, I would not never picked up continual learning at all. So all the rejections that I've been having so far was actually a blessing in disguise. So you can actually connect the dots only when looking back, as Steve Jobs says. So, and then please don't give up easily. It's not just about maybe you trying out something and then you're not getting the output, and that's okay. In many cases, even your circumstances will be extremely bad. It will be extremely wrong. And then in most cases, you will feel like, okay, I cannot just do that. Let's give you a concrete example. So for the paper that I was saying, that open world paper, CBPR 21 oral, the deadline is in November. So this is COVID days. We are at home. And then in October, November is when we really get into the heat of things and then do things. Then October mid, my mom had an accident, had a knee surgery. My father was sick. My wife was sick. My grandmother was sick. I was the only one in that house who could just walk around and do things. And I still remember sitting, waiting for a doctor's appointment with my wife, and I was texting Vineet, sir, things are not working as we planned. It seems like, there might be, it might slip. And like, okay, so I was like, okay, fine, let's see what we can do. 2 days later, another collaborator that I have, I was interning with a university in Abu Dhabi, it was Mohammed bin Zayed University of AI. He just asked me, how are things? And I simply had the grit to say, we are going on. Then what happened after that is I literally shut myself off from November 1st to November 14th in my room, and I was just solely focusing on this without any other distraction, thanks to my family. I don't know how they tolerate me, but still. And then the fruits were really good. So please don't give up, even if, let's say, circumstances don't allow you. If you can do these only if you're so passionate about what you're doing. Or else you'll find excuses, just move on, right? And I'll just say, all of these things are manifestations of what I have learned from Vineet sir and Salman and Fahad at MBCUAI. And I'll just stop with just one liner. PhD days are the best days of your life. Enjoy every bit of it. Thank you.
Thank you, Joseph, for that very open and useful kind of your journey. And also thank you for finishing it on time. Any questions from the audience? Any questions? Nobody has any questions? So you should be, yeah.
Yeah, hi, thanks for a lovely talk. I find that most people keep saying, if your paper gets rejected, it's all right. You'll get good reviews, use those reviews in the next iteration. Sometimes what happens is that your paper gets rejected for completely trivial reasons, and you don't have a rebuttal in many conferences. What's your advice for those situations?
It's very unfortunate, and I'll just add on to that problem. These days, AIs are reviewing in terms of human, and then their responses are useless. It's unfortunate. I think we should move on to the next menu and then try our luck there. If there are, and each submission is basically a checkpoint, right? And then we would be moving on from there too. So in between, if we had some newer results on the same problem and so on, maybe improve your paper further and then submit to the next menu and hope that a human being with a goodwill will review your paper.
Thank you.
Yeah, I think at least if they are giving reviews, then you get a chance to rebut.
Yeah.
But if they are simply rejecting it, saying that like a desk rejection or something, then. Yeah. Yeah. Any other questions for Joseph?
So it's often easy once you find the topic of your interest to pursue it, but how do you go about finding what is it that interests you?
Very good point, very good point. So even I just kind of did not get started with this, right? So at some general idea, I'm by construction, by context, I'm not a theory guy. I cannot prove things on a blackboard and so on and so forth. So I'm an applied guy, so I know for that. And then we're looking around for newer problems and so on and so forth. I mean, I mean, I always have this fascination for our brain where, like, let's say, we can take all this information, put it here, and then recall, and so on and so forth. So that was there for a very long time. So when I heard about continual learning, it's like, oh, wow, okay, so this model cannot do that. So first thing that I did was, like, I just took a simple classifier, trained MNIST on that, and I checked that, and then I could see that, let's say, first 5 classes, after learning the last 5 classes, I could see a huge drop. Wow, this is a problem worth solving. I mean, that's how, and then that's how at least I went about kind of understanding that. I mean, I think early on it will be good to kind of have a understanding of the breadth within maybe the specific sub area that you're interested in, and then just going and follow your trust and follow your will. Yeah.
Hi. I have a question. You said that it's okay to get rejections from conferences. You at least get good reviews and stuff like that.
Keep the mic closer to you.
Is it always a good idea to work on those comments that you get? For example, I recently got my paper rejected from a conference. I was trying to handle some class of attacks, and the reviewers told me that you're not handling these other class of attacks, which are like completely different. But I am handling like an equally important class of attacks, and it's not like one solution can work for everything. So is it always a good idea to use those comments in the resubmission of your paper to other venue, or just stick to what you want to do?
Yeah, sure. I mean, good question. So if the reviewer's feedback is completely off track, I think we should disregard that. I mean, it might be just because of their context that they're kind of maybe feeling that, and you should, if there's a rebuttal phase, then we should politely kind of respond saying, hey, I mean, whatever you suggest is true, but see, I mean, I think this is how it's just different from there, and this is why techniques from one cannot work on the other. That's one way if you feel there's no way to kind of combine them. But if there is something good in their feedback that you can probably work on, and that will definitely improve your work too. So it depends upon, let's say, whether whatever the reviewer told is factually correct or not, and whether it depends upon your context too.
Any other questions?
I have a question. Like when we take a problem that fascinates us, how do we know upfront that this has the meat to get into an A or A star?
Yeah, I mean, so the simple answer is like if people are publishing related or the same works at certain venues, it definitely has a metal to kind of, like at least a field will be appreciated by that community. So if let's say if you start working on that cool idea, and then you start reading papers that are already published that are in that area, and if those papers are published at so-and-so venues, it's very likely that your paper will also get, let's say, you can potentially try for those venues, right? So it's like with like kind of a setup.
Is it completely idea-oriented, or is it depth at which you solve those?
Sure, I think there are two independent parts, right? So one is the problem, and the two, the ML component that you're kind of maybe improving or introducing towards solving it. So at least I would say, like, first go around kind of showering over and understanding some kind of a problem, and then looking for like how to solve that. And I think both these journeys can probably take you into completely orthogonal directions. And then maybe completely just thinking about ideas, only ideas, might not kind of, ideas. By ideas I mean like, implementation, like what is the methodological components that I can probably build on. That might be an infinite depth. I mean, like, let's say, I mean, like, and at the same time, if you have a problem at hand, then it's easy for you to contextualize. Hey, this is a cool idea. Can I adapt that idea to this problem? If so, maybe let me try it out. And then if there's some other idea, and so on and so forth, right? So I think both of them should go hand in hand, in tandem.
Thank you.
Yeah, I have a question, Joseph. So how did you decide that you would go to industry as opposed to academia? What was your thought process?
I have a very simple reason for that. Academia does not kind of offer you work from home, remote working. Okay. It's a truly personal problem. So like I have some reasons to kind of be at home. So then like industry, at least to some extent, kind of allows you to kind of balance that. But yeah.
Any other questions? Okay. Okay, give him a big hand. Thank you. Thank you. Now the next talk is going to be by Professor Vaishnavi Sundararajan from IIT Delhi. She is going to be talking on From Theory to Practice, Proving System Guarantees. So we shift our gears from industry to now academia. I'd be happy to introduce Vaishnavi now. So Vaishnavi is a Chandruka New Faculty Fellow and Assistant Professor in the Department of Computer Science and Engineering at IIT Delhi. She completed her PhD from Chennai Mathematical Institute and has done her postdoctoral stints at CNRS, IRISA, Ericsson Research, and University of California, Santa Cruz. She is interested in applying formal methods and logic to show that systems work correctly, primarily security protocols. She is associated with the Internet Engineering Task Force Working Group on Lightweight Authenticated Key Exchange Protocols and continues to be closely involved with verification efforts as part of the group. She is also a member of Internet Research Task Force as part of their Usable Formal Methods Research Group. Please welcome Vaishnavi.
Yeah, hi everyone. I think now that the industry guy has delivered somewhat of an academic talk, you'll have the academic delivering something about practice. So I'm basically going to talk about the work that I've been doing post-PhD. A lot of this has been informed by my basic training, which is as an engineer and not as a scientist, even though my PhD is in computer science and very theoretical computer science at that. I've always felt this split in me where I constantly want to apply the kind of things that I'm working on, but I work on very theoretical stuff. So this is the story of how I've been trying to do that. Right, so what do I work on? I basically do the following. Given a system S and a desirable property P, I check whether S satisfies P. And the other question I'm interested in answering is, can we automatically check whether S satisfies P? Sometimes the answer is no because of various reasons, we'll see why. But if you luck out and the answer is yes, then some follow-up questions arise. One of them is, how easy is it to actually automatically check whether S satisfies P? And of course, as people who work in these things, who develop systems who allow such automatic verification, the natural follow-up is, how can we make it even easier? So formal analysis and verification basically spans the following. The question essentially is, how do you verify a system? And I like to say that formal verification is a very broad topic, and there are many, many, many different ways of doing this. But essentially, always follow these three broad steps. The first step is that you have to cast the system in some abstract mathematical model. The second step is this property P that you are interested in. You want to cast this property as a statement over this model. And the third step is to check whether the model actually satisfies this statement. Those are the three steps, and depending on what your choices of the abstraction for the model are, depending on how you phrase your property over this model, you can have very many different tools and techniques that apply. So what does it mean to have an abstract mathematical model? These could be some kinds of logic, these could be automata, these could be process calculi, these could be rewrite systems. For those of you who work in certain subfields of formal methods, you might be more familiar with one or more of them than the other. And the third part, where we talk about whether the model satisfies the property or not, you definitely don't want to be doing this by hand. Because most of this, unlike the nice finite world, is usually set in a world that admits unboundedly many, if not infinitely many possible behaviors. And obviously, that is impossible to do by hand. So you want some nice machine representation of this so that you can press a button and your computer can come back and tell you whether indeed the system satisfies the property or not. And most importantly, you want the computer to be correct when it tells you whether the system satisfies the property or not. Right, so what sort of systems do I and the people I work with analyze or verify? So most of my work has
centered around formal verification of security protocols. So what this essentially means is that security protocols are these long pieces of code which span thousands of lines, which are being written by some folks in labs, right? Now, as compared to something like 10 years ago, even 5 years ago, people have sort of come around to realizing that some of these things are being used in very critical use cases, right? Even for lightweight protocols like those being used for IoT. So everybody now sort of understands the necessity for doing some kind of formal verification, because you want formal guarantees, better guarantees than what just plain testing would give you. Because if you were to just throw an army of testers at the problem, first of all, you need an army of testers. Second of all, your army of testers has to generate test cases that cover all possibilities. And third of all, if it is a really critical system, like some sort of thing that is being used for, say, aircraft, or some sort of thing that is being used for doing banking on an edge device, then even one rogue counterexample could spell losses of either life or money or both. And you really want to avoid that. So people realize that formal verification is indeed important. So in addition to the thousands of lines of code, what they have started to do is that they have started to generate these long documents which now span hundreds of pages, which are called request for comments. A request for comments is basically a large verbose description of what the protocol does and how it can be implemented, right? So usually an open source protocol will be accompanied by a request for comments, and if it is intended for use on the internet, usually the IETF is the body that governs how these requests for comments, these RFCs, are circulated. An RFC is basically a techie's answer to a legal document, which means that it has these three words: may, must, and should. And while for most of us, especially those of us who speak Indian English, these are almost synonymous, they are not at all synonymous in such a document, right? They mean vastly different things, and you better not use one when you mean the other. So this means that a human being has to sit and read through these hundreds of pages, sift through this document to, first of all, stay awake and read it all in one sitting, because you have to figure out whether some part of it was inconsistent with some other part of it or not. And even if you are really lucky and you manage to find that somebody has written a consistent document, then you have to figure out what this document actually means by way of the code and what this document says, right? Are those two consistent? Because the document is essentially an abstraction of what this person has actually coded up in some machine language, right? And they've written it down in natural language, and sometimes these two don't coincide. So after you've done all this, you then figure out, okay, now I need an abstract model, because I can't deal with 200 pages of may, must, should, and I cannot deal with 1,000 lines of Python libraries being called. So finally, you get down to something that is called an Alice-Bob notation, which is basically these arrow diagrams that you draw, where on each arrow, you write down what message is being communicated between which parties. And usually, these are IoT protocols at the very least, are sort of nice protocols because you're not involving too many endpoints. So usually, it's like 2 endpoints. And the ones that I work with are key exchange protocols, so there's always 2 endpoints, because those are the guys setting up the key. And between those, you have about 5 messages that are going back and forth, and that is what these 200 pages are telling you. So now the developers have sort of caught on that, if they don't give us this arrow notation to begin with, we will bug them till the end of their day for like weeks on end, and they will get nothing else done. So now they have deigned to put these arrow diagrams into these 200 pages. So nowadays, people like me who do formal verification for the IETF, we just skip to that arrow diagram, and then we do a depth first search to see, acha, okay, this thing says this word, where does this word show up? Can I get more information about what this word means? And then do that. Right? So much of my work has centered around this IoT protocol that was originally being developed at Ericsson while I was there, and is now being developed, as an open source. So now there are way more contributors, and it's called Ephemeral Diffie-Hellman over COSI, and ad hoc for short. So this work began in 2020 at the height of COVID. So while I was sitting in Ericsson in Bangalore, the work was happening in Ericsson in Sweden, in Kista. And I was able to actually collaborate well with these teams, because everybody was working online. It really doesn't make a difference if you're sitting in Sweden or Bangalore or wherever. So we managed to communicate a lot of errors that we found as part of the request for comments about inconsistencies, about errors, about claims that they were making about security properties which were not being borne out by the formal verification, and they were able to fix this. So now this protocol has actually undergone standardization, and it is a standard protocol that you can use if you have an IoT implementation that you want to use a key exchange protocol for. So that is vanilla ad hoc, but ad hoc now also has other variants. There's ad hoc with pre-shared keys. There is ad hoc that uses this post-quantum secure ML-Chem. And I've also been working along with an intern on Apple's Find My protocol, which is basically this crowdsourced protocol that allows you to find Apple devices. If one of your Apple devices gets lost, you can use either the iCloud on the browser or another Apple device to find it. And essentially how this works is that devices that are in the vicinity of that Apple device which has gotten lost send these low payload Bluetooth beacons, and those are uploaded, if enough of them shows up, those are uploaded to Apple's servers, and then Apple gives you that information as part of your iCloud. And the interesting thing is that Apple claims that this is private, but there has been some work that's been shown where one can show that while it is private in some sense, it also allows people to stalk other people. Because essentially what this means is that now that we have things like AirTags, which are these small devices which are still equipped with Apple Find My because they are Apple devices after all, and this is a very lightweight protocol, I could essentially slip an AirTag into, say, the backpack of somebody that I wanted to stalk, and unless they realized that there was an AirTag in their backpack, they would not know that it was there, but I could essentially look up their location on my iCloud, because of course I can track my AirTag. So there are some things that have come to light as part of this, but there had not been any formal verification that was done. So we've done some formal verification and shown that for some notions of privacy, this still does not satisfy privacy and things like that. The orange stars indicate work that is either happening right now or under submission or both. The green stars indicate work that is just happening but is not a paper yet. So the point I'm trying to make is that even with the IETF, even though the main focus is in verifying this thing and shipping it so that it can be open sourced, it can be standardized and released to the open source community at large, there is a real impetus to actually publish your work to the research community as well, so that the research community can get back to you and say, hey, you missed this, or maybe this is another notion of privacy that you could have used. And a lot of collaboration has happened as a result of that as well. So those are the IoT systems. There are these other systems, like there is this system called Hyperswitch, which is basically a wallet where you can store a lot of your credit cards, you can store crypto credentials, you can store various kinds of things. And there is an open source vault that has been built for it, which is called Tartarus. The code is freely available, but again, this does not even have an RFC. So this is basically thousands of lines of code and a rather terrible arrow diagram. So one has to figure out what library calls are happening, what these library calls do, right? What do you send when you do a library call, what do you get in return, and then kind of get the inlined code with all the library calls expanded, if you like, and then create an abstraction of the system. So that's also happening with the student. And some other work that I'm involved in is talking about peer-to-peer protocols, except peer-to-peer protocols where one endpoint is allowed to deviate from the protocol. So if you have, usually when one studies peer-to-peer protocols, one assumes that everybody is running the protocol honestly, and because you would probably be using a client like, I don't know, Transmission or something, right? And those clients presumably run the same software, the correct software, at everybody's ends. But now we are assuming what happens if I can write my own P2P client and I make it behave such that it deviates from the protocol. What guarantees can I get? Can I still preserve some nice properties, right? What happens if I set up something like a Bitcoin kind of system where I need consensus? How well can I violate consensus? How easily can I violate consensus? Things like that. And finally, this is not limited only to real world systems. Sometimes we also do fun stuff like analyzing games. So with a couple of students, I have been analyzing this game called Nonograms, which is basically a binary Sudoku. Each cell can either contain a 0 or a 1, and this is a Japanese game, and the Japanese, with their focus on aesthetics, want this grid to finally reflect a monochrome picture, right? So you have these pixelated picture that shows up at the end instead of like Sudoku, everything shows up with 1 to 9. But this thing is more of a pictorial representation of something. And basically the intent is that finally when you have colored all the squares that need to be colored and not colored the squares that should be left blank, a nice picture emerges. But the question is, your constraints are specified in terms of how many cells should be colored in this row, how many cells should be colored in this column, etc., etc., and how well can you solve these constraints. And the other game that some students have been analyzing with me is this game called Black Vienna, which is basically a card game where you are calling bids and making bids about the cards that you hold and the cards you believe other people hold. And essentially, it is a game about epistemic logic, what you know versus what other people know. And you can cast all this in a cute logic and analyze stuff over that. So being the theorist that I am, the natural question that I would like to answer is, what theory underpins all this machinery? Right? It's all well and good to make systems, but I personally want to have some theoretical grounding that underpins all of this. I don't want to be doing this in the ether. So one thing that I do work on are new logics, which allow me to represent systems well, right? So the logics help me give better specifications for protocols, for example, those involving certification, right? We have some work in type theory where we are using fragments of first order logic for typing the certificates that are communicated back and forth as part of protocols. We also have some new work that's happening, which is new logics for systems that involve access control and this new thing called zero trust architecture. And we would like to be able to do some formal verification for those big systems as well. The other end of this is that we would also like to provide new models which better abstract out my systems. Every time you use an abstraction, you are throwing away some information, and the richer the model, the less information you have to throw away. So ideally, you want a really rich model, but then you also want it to be amenable to automated analysis, right? So we are working on richer models which include transition systems and process calculi, right? We can handle complex operators, like I said, ML came earlier, but we can also handle homomorphic encryption and things like that, right? And the question essentially that we want to answer is, for the security systems, how faithfully can we formalize exactly what the adversary knows? And once we know how to do that, then we can actually analyze a lot of real world systems really well. So finally, a lot of the ongoing work, like I said, is about the real world impact, because I don't want to be sitting in my office working out some theory just by myself. I want these things to be used by the people who want to build these systems, who want to ensure that these systems work correctly. So much of this is as part of the Internet Engineering Task Force and the Internet Research Task Force. In the IETF, I'm part of the working group on what is called LAKE, Lightweight Authenticated Key Exchange, which is where I do most of the work about ad hoc standardization and variants of ad hoc and so on. As part of the IRTF, the major focus is in ensuring that people who develop systems are also able to verify systems. Right now what's happening is that developers need to outsource all their verification either to academics, not that I'm complaining, but the developers are, because it takes a lot of time, right? Like academics have a lot of stuff on our plates. It's not necessary, especially if I'm doing this as part of some open source effort, that I will be able to prioritize this over everything else. So it's useful for the developers to have some lightweight formal verification that they can do. Maybe they hit a wall at some point beyond which the expert needs to step in, but right now what's happening is that the expert needs to step in at stage 1. So essentially, as part of the IRTF, what we are trying to do is to develop more usable tools, right? More plug-and-play style tools that developers can use, which are written in languages that the developers are more familiar with, which is not necessarily the case right now. And finally, we, as part of some corporate collaboration that we are currently in talks about, and I'm not allowed to say more about that, I am also working on checking for compliance with the new DPDPA that has come out for India, and which companies are required to comply with as of the next year. So that is also essentially formal verification, because you have this system and you have these properties that it must satisfy, and we essentially want to automatically show that yes, it does. So finally, all of this would be kind of useless unless more people were able to learn computer science, because ideally at the end of this all, we want more developers, more verification folks, more theorists, all of that. And all of that begins with CS education. So recently I've also been working on some stuff for CS education, which is essentially building an online graph theory, automata theory tutor, which runs inside your browser. So essentially what this means is that there are loads of these around, but most of them require you to drag and drop automata or shapes, if you like, from some list of shapes that are provided. This is optimized for the desktop. What I've been finding as part of my teaching is that most of my students no longer use their laptops at all. They want to work on their phone or their tablets. And the other thing is that sometimes it gets very difficult to ensure that everything works the right way. Because if this says drag from here and drop to there to draw an arrow, sometimes it doesn't know what it means when you do a self loop. And we don't want to have to do all that, right? The student, like me included, everybody's attention span has shrunk to abysmal levels. So we want to be able to do the quickest thing and then get immediate feedback about whether it was correct or not. So this system allows us to freehand draw these things, and it is mobile first, so it's optimized for phone and tablet. It runs entirely client side, so it's also privacy first. We didn't want to store any data that we didn't have to. And ultimately, we also want to make this fully automated. So what we want is to be able to give helpful hints if you get your answer wrong. So if you give a wrong solution for a problem that I have presented to you, then I want to be able to automatically analyze the solution, automatically figure out what was wrong with it, and give you something by way of a helpful hint, which does not reveal the solution to you, but takes you towards the right solution, right? And that's basically it. And I am apparently out of 20 minutes. But these are the people who make this possible. These are all the collaborations that are happening. Much of this is with folks in Europe, but this is also with folks at CMI, at Azim Premji, at ISER Pune, and IIT Gandhinagar. And yeah, that's it. I am around here till Sunday, so if anybody wants to chat more about any of these slides, happy to. Thank you.
Thank you, Vaishnavi. Yeah, that's very interesting. I have a question. That is, you told that you are developing tools which the developers could use by themselves.
Yeah.
So in that, do you train them, or is it that they can simply pick
No,
up?
so there is a minimal amount of training involved because, again, different developers are familiar with different things. So what we are saying is that this is written in a relational syntax, and it works sort of like type annotation. So some people might be familiar with relational syntaxes like SQL and so on, but not with type annotation. Some people might be familiar with both, but might not be familiar with first order logic in which we want them to write the types.
Yeah.
So it's levels and levels. So we do have to do some hand holding, but the problem right now is that current tools have documentation that is scattered, and people have to spend a lot of time collecting all this documentation and then learning how to do this. And it is intended for somebody who is already fairly familiar with theory. So, which is not true of most of these developers. So that's the gap that we are trying to address. The ideal moonshot would be to have a plug and play system where they can just press a button and they don't have to learn anything other than how to specify this, and then it gives out a nice looking output. We are far from that, but that is the end goal.
Okay. Any questions from the audience?
So I'm not much familiar with this field, but since you've mentioned the DPDP Act thing, so is there any formal verification of, let's say, ML models or something? I mean, where in the sense of the differential privacy attacks, or there are your membership inference attacks?
So actually Pujan's just stepped out. You should have asked him that. But there is some work. Okay. The problem with ML models is that usually we don't have a faithful enough abstraction. Because ML models, like Nitin was saying the other day, right, like they do stuff on an instance per instance basis. And so there is no one unifying model that I can extract out of this, which works the same way on all inputs. That is sort of, when I say you want an abstract model, that is what I mean. That I know exactly how it behaves on all possible inputs. And ML models, it's very hard to do that. But to answer your question, there is work on, because of the learning frameworks, reinforcement learning lends itself very well to formalization because there is a nice hidden Markov model that comes out of a reinforcement learning system. So there's been a lot of work that's been done for reinforcement learning with respect to formal verification, but nothing that I know of in the field of differential privacy.
Thank you. So, any other questions?
I have a question, ma'am.
There is a question.
So, ma'am, I am also interested a lot in like theoretical part. I am from machine learning domain, so theoretical machine learning in that sense. So my question is like, it consists of three parts, I guess. First is, what are the pros and cons of working in a theoretical domain in an application, and is there an intersection that exists, and would you recommend it? Because I personally love theoretical, so my question is revolve in all these directions. So I'm asking in that sense that pros and cons of theory, pros and cons of application side, and is there an intersection, and would you recommend an intersection?
I think we tend to use these words as placeholders for what are very broad, diverse areas. So there is no one theory, there is no one application, right? Like I know that, so for example, even in theoretical CS, right? The friends that I did my PhD with who work in algorithms and complexity often tell me that, oh, you work on the more application-y side of theory, right? Because I might actually build a system that implements the theory that I do. And that is not, easy in the application side. You have to give me an application and then I can tell you, oh, this is the algorithm that applies to it. So I don't know if there is one single answer. It is a lot about individual taste. I would say that I have kind of tried to figure out an intersection because essentially the theoretical advances that I make, the IETF is not interested in, but a lot of the use cases, a lot of the motivation that comes for these theoretical advancements comes from the examples that I see as part of the IETF. So I think using an application-oriented approach to inform what goes into your new theory, I think is a good compromise. But yeah, I mean, you do you. If you like theory, please go do theory. Like there are people doing theoretical stuff in machine learning. I have a colleague who does just that. So why not?
I have a question. Ma'am, from a systems perspective, since you talked about key exchange protocol, in what way is this verification different from the security analysis we do?
So this is much more formal, right? So we are doing this on a symbolic level. So there is no actual running of the system that is involved. What I am doing is I am basically trying to create like a mathematical sandbox, if you will, in which I am saying this is the system. I can somehow encapsulate everything that it will do given the environment that it is going to run in. And now tell me if there is at least one behavior which falsifies the property. But I am never running the system, right? So it's not destructive in that sense. I never have to run the system to find out that it is liable to crash, and I don't have to build, say, a digital twin or any of those things. This is essentially like a digital twin, but in maths, right? And you're basically saying that I can somehow mathematically give you an encapsulation of all possible behaviors that this system will produce, whether with adversarial, intersection or not. I am trying to take into account some behavior of the adversary, maybe not all possible behaviors, but that has to come with a conversation with the developer. So that's why it's important to have access to the developer, because if the 200-page document or the 3,000 lines of code is not clear about what adversarial model is being considered, you need that information for sure. But once you have that information, everything else is sort of traditionally laid down, and you can fit that into this. And then you basically just have a way to generate all possible behaviors and analyze them mathematically. But your system does not run at all.
Right, yeah, I get it. I was from the adversarial perspective, I was looking at it.
Yeah, so you can have different adversarial models. Right. Usually the one that we consider is something from 1983, which basically magically predicts how the internet works. It essentially says that the network itself is adversarial and you don't know who is the bad guy. So you're willing to talk to anybody. But you can strengthen this model, you can weaken this model depending on what sort of situations you're working in. This is again a model for classical primitives, not for post-quantum. So for post-quantum, you need better models. That is also something that we are looking at, because right now, the only concession that we make for talking about quantum is to say that we will store now and decrypt later. But that is perhaps not good enough, because certain operations might be breakable Just like we know that certain kinds of crypto are not okay, but lattice-based crypto is okay when it comes to the post-quantum model, maybe there are some operations that are easily breakable even without the store now decrypt later stuff. So all of that needs to be taken into account. There is some work that's happening about that, but not enough in my opinion.
Thank you.
Yeah.
From ACM. I'll hand over this to. So the next talk is going to be by Manisha Padala. She's from IIT Gandhinagar, and she's going to be talking on LLM bidding markets. I'll be happy to introduce Manisha now. Manisha is an assistant professor of computer science at the IIT Gandhinagar. She received her BTech in electrical engineering from IIT Jodhpur and her PhD from IIIT Hyderabad, during which she interned at Google and Adobe. Her research group works on problems at the intersection of machine learning and fairness, focusing on fairness measures, fair and private classifiers, and fairness in federated settings. The group also applies ideas from mechanism design and deep learning to design systems that are resistant to manipulation while ensuring efficiency and fairness in context of auctions, crowdfunding, and resource allocation. Please welcome Manisha. Yeah. Over to Manisha.
Thank you very much, ma'am. So I thank the organizers for inviting me over and welcome all to probably a bit of a future, right? So, we've already looked at practical tips for PhD. We have already looked at theory being really applied. Now we will look at slightly hypothetical problem in an hypothetical future, right? So I hope it's a very preliminary work, and I hope you guys will give me some idea to make it more concrete, right? So that's the idea. So here I've been working on auctions by and large, and learning in conjunction with auctions, and this is one of the ideas we had where LLMs are really bidding, for your attention. so that is one hypothetical scene that we have. So what is the problem that we are trying to solve? Okay, so how many of you use LLMs? It's a bad question now. And how many of you really find it hard to decide which LLM to use? Not so many, right? All of you, right now we don't have as many players, right? And we know which of the LLMs is good for what. So, which is why this is for the future, right, in some sense. Should I click here? Oh, good. Thank you. So, we have a lot of different LLMs to choose from, right? And some of them are open source, some of them are proprietary, and I often feel that the premium version is a bit better, right? And we have to buy premium versions of so many different LLMs. Which do we really buy from, or do we buy all of them? I don't know, right? So all of these are something that led us. So there is this, there are these APIs, right, or websites which do the LLM routing work for you. One such is Latitude. So it's an open source LLM platform. What it does is, based on your query, it will try to find which LLM is suitable for addressing this particular query and try to improve the performance, etc. But the idea is that on the back end, they have access to all the LLMs irrespective of your query, right? They have already bought it all, and based on your query, they are charging you so that they make profit. Likewise, you have Root LLM, right? It's also very similar in a very nascent stage, doing similar sort of work. But in our particular approach, what is it that we are trying to see? We are trying to see a bidding market, right? So typically what we are aware of is online auctions, right? What happens in online auctions? You have a Google page or something, and there are multiple slots where online advertisements appear, right? And how do you know which advertisement to really show, and what should the advertisement really pay to be shown, or for every click? That happens via auctions, right? Google conducts the auction, and it selects based on an auction which particular advertiser to be shown, and for what user which advertisement is more useful, and all of that. So it's the same idea, but now we are trying to flip the scene where LLMs are bidding and you are the one querying for a particular reply. Right? So let us try to first see what is the general auction flavor, right? And why is it really relevant in this context, right? Probably not, but it's what we think is relevant, so open to your suggestions. So given that here we have a buyer, a single buyer who is interested in buying a particular item, right? Only one item is what he is wanting to purchase, but there are 5 different sellers, right? And each of these sellers could be, they are selling different items, and the buyer is looking to purchase any one of them, right? Any one of them. And what is the main catch? The catch is that each of these sellers have a cost. So the typical auction scenario is reverse, right? Where there is one seller who is auctioning a particular item, and it is being auctioned to a bunch of people. But here we are dealing with a reverse auction, because the sellers for us are in some sense LLMs, which we will be seeing soon, right? So in this reverse auction setup where there are these sellers, and each of these sellers have private costs. What is this cost? This is the cost that the seller had to put in while manufacturing, while procuring the item or manufacturing the item, etc. And this cost is private. That means it is not known to the buyer what exactly is the cost of the item, right? That the seller had to incur. So now these sellers, depending on their personal costs, would bid, right? Would give a particular bid to the buyer. They would say, so seller 1 here is saying, I would sort of sell my item to you for B1, right? So you pay B1 and you get my item, and so on, and so on. Now, imagine if you are a seller, you would never sell your item for less than what it cost you for, right? So if it costed you for C1, you would quote a B1 which is higher, right? You would not quote a B1 which is lower. And the buyer has certain, and the more important thing about auctions is, the buyers have certain values for these items, right? So the buyer has a value V1 or a happiness score. So if he gets the item that seller 1 is selling, he'll get a value of V1, V2, and so on. So these values are known, fixed and known in a typical auction scenario. So now what is the problem that we are trying to solve? We are trying to find these 2 things. One is what is the allocation, and the other is the payment. The allocation is who is the buyer going to select, right, to procure the item from, and what is the payment scheme does the buyer really follow, right? How much does he really pay to the seller that he selects? So you guys might think that why is this even a question, right? You just select the buyer who has the highest, who is giving me the highest value and the cost trade-off, right? And I just pay him whatever he bid for. But if I tell all of you that I'm going to pay you whatever you bid for, how much will you bid for? You'll bid as much as possible, right? You will bid infinite, nothing less than that. And I will have to pay you infinite. So we don't want that to happen. We don't want the market where sellers are arbitrarily bidding very high values. So we want their bids to be faithful to the actual costs. Hence, we need to design an allocation. Can we design an allocation and a payment scheme where the bidders really are faithful about their true costs, and we are able to maximize our profit or our value minus cost trade-off, right? So that's the goal in a typical auction. So this is a reverse auction where there is a single buyer and multiple sellers, and in the typical auction, the allocation function and the payment function are the functions that you're trying to design. And they are the function of bids. Because you don't know the true costs, you can only design the allocations and payments to be a function of the bids that the sellers have reported. So in this particular, why is it an optimal auction? It is an optimal auction because we are trying to maximize the buyer's expected utility, right? So we are trying to maximize the value that the buyer is able to ensure from this particular system. So how do we, so the value is just what you would have guessed, right? It is the expected value that the auctioneer is able to get for himself. So here AIB, you could think of it as a binary sort of a function where it is 1 if you allocate, if you choose a seller I, and it is 0 for the other sellers. And AI bar is the expected allocation. So I, as a seller, cannot know what your bids are. I know what my bid is, but I don't know what your bids are. But what I assume is that your bids are coming from some known distributions, because you're not going to bid very arbitrarily bad from, different from your cost, right? So I assume some distribution from which your bids are appearing from. So I come, and this then would be the expected allocation times the value that that particular seller's item is actually giving the buyer, minus the expected payment that the seller has to make, right? So this is the expected value minus the expected payment, and I am interested in finding the MathCal A and P which is going to maximize this. That's my goal. And what are my constraints? I have twofold constraints. One, which is famously in mechanism design, is typically known as Bayesian incentive compatibility, which essentially means that every agent's utility or every seller's utility is maximized when they are faithful to their true cost. So instead of reporting a bid, an arbitrary bid which is much higher than my true cost, if I report my cost itself, it actually maximizes my utility than reporting any other bid BI, right? So reporting CI when my true cost is CI is the best thing for me to do than reporting any random BI. So if this is the case, then people are not going to quote very high values. They are going to just quote their own values. And of course, we want individually. In this process, we don't want the sellers to incur any negative utility. So we want the utility of the seller in this case is the payment that the seller receives minus the cost that the seller incurs when the seller is allocated, right? So this is that particular utility of the seller, and it has to be non-negative. So by and large in this auction, what is it that we are trying to achieve? Maximize the user's or the buyer's utility such that the seller is truthful, right? He reports the true values of the bid, true values of the cost, and is also individually rational. That means does not incur any negative utility. So how do we solve this optimization? Meyerson comes to our rescue. He has already given us a very nice formula for what would be a solution to such an auction. So this is known as the Meyerson's optimal auction in the reverse setting. But the main thing that we must focus in this case is that your allocation function is non-increasing in B, right? So that means if you increase your bid, or if you say, okay, I'm going to sell you for very high value, then the probability that you getting allocated will just reduce, right? Because I do not want to buy from you anymore, I'd buy from somebody who is giving me for cheaper. So that is being reflected by this particular function, wherein I am allocating it to someone who maximizes this quantity for me as long as it is non-negative, and this is increasing in the cost, right? So that the allocation is non-increasing in BI. And you have a Meyerson payment rule as well, right? And that Meyerson payment rule it's not important here. What is important is that the allocation rule has to be non-increasing in BI. Now let us try to understand how can we map it to the LLM setup, right? In the LLM setup, we have a user's query, Qt. We as a user have some query, and you have multiple LLMs that you could choose from. But now there is a buyer who is trying to optimize this for you, right? And what are the private costs for the LLMs who are trying to sell, right, their system is that they have a cost per token, right? For every token, they are spending some amount. Now, this could reflect the model that you are using. So, if you are using a larger model, maybe the per token price will be high and so on, right? So, this is cost per token. And we could also think that the number of tokens that they want to generate for a given query is a private information. Maybe some LLMs would think that I need to generate a longer answer for you to be satisfied. Some say, no, smaller answer is good enough. So, the overall cost that I have is number of tokens times the cost per token, which is my private value that I have, and it is typically not known, let's say. I mean, we already know it in the current scenario, but let's assume it's typically not known. So, they come and bid for that particular value, and the buyer is allocating picking, using some allocation rule, is picking some LLM and giving your query to that particular LLM. And is also, so the LLM is charging some payment. So, these are the, PIT is the payment for that particular response. So, now the catch here is that the LLM's response may or may not be good. You don't really know, right? So, this is a stochastic reward that you observe. If you are happy with the response, the reward is good. If you are not happy, the reward is bad. So, the values are not, just unlike the auction setting, the values are not deterministic. They are stochastic, which is why designing an auction just by using Meyerson is not quite trivial in this setting. So, what we have essentially is expected. So, what we assume is that all these LLMs have a average level of worthy of being good, right? So, let's say LLM 2 is about V2 good, but has some variance to it. LLM 3 is V3 good and has some variance to it, and so on. So, now the question is, how do you now conduct an auction when you don't really know what the exact value is, right? So, for this, what we do is we resort to something which is known as a contextual multi-arm bandit, which is simply, it's a complicated way of saying that I'm going to explore all these different LLMs and try to figure out which is the best for me. But then that would mean that you are going to pay a lot, right? You are going to pay every time you are exploring an LLM which is not great. So, how do you minimize that? That's the goal. And remember, LLMs will not bid truthfully their true costs unless you satisfy monotonicity, right? The allocation function has to be monotone, but now you are exploring. While exploring, you want to explore all different possible arms irrespective of their bids. So, exploration and monotonicity do not go hand in hand, right? They may, so how do you design truthful auctions in a multi-arm bandit setting, right? So, that is what we are trying to explore, and here are certain impossibility results which say that, so in a multi-arm bandit setting, what you define is a regret, right? If the regret is large of the order of t, that means it's a very bad algorithm. You want typically the regret to be sublinear, right? So, what people have shown that if you want a truthful auction in a deterministic allocation setting, you must incur a regret of 2 to the t to the 2 by 3. For those of who are familiar with UCB kind of bandit algorithms, they might be familiar with the way in which allocation happens, and it's almost always, so you have an exploration term and an exploitation term, and they are always there in every round, right? So the idea here is that for it to be monotone, your exploration round should be bid independent, right? And which is why you must incur a regret of order t to the 2 by 3. So, the goal for us here is to reduce it, right? So, can we improve the regret? So, in our work, we showed that we proposed a randomized mechanism, because deterministic is hitting a lower bound, we cannot improve upon it. So, in the randomized mechanism, what we have is we modify the existing multi-arm bandit algorithm where the bids are noisy, right? So, which is introducing the stochasticity in the system, and we ensure that the allocation is monotone so that it becomes a truthful mechanism, and it pays the Meyerson payment in expectation. So, it is truthful in expectation. So the mechanism that we have is truthful in expectation, it is individually rational, that means it's ensuring that all the LLMs are not incurring negative utility just because you want to run your auction. And in this case, we have slightly better regret than what a deterministic would give, which is of the order root t, right? So here to conclude, what we have is essentially a multi-arm bandit based mechanism design where you are learning the values of the commodities that you are trying to purchase while also holding an auction simultaneously to minimize the costs, right? To minimize your cost and ensure that the LLMs will bid truthfully, right? So that's about the work, and yes. So thank you. I conclude my talk here. If there are any questions,
Thank you, Manisha. Went in the path where you have right now. That is, how did you choose academia over industry? Something
right. Yeah. So I've always had an interest for teaching, right? So my path to academia was really heavily dependent on the fact that I am interested in teaching, and of course my advisor really had a big role to play in motivating me in sticking around in the academia, staying around I know younger people, younger generation with much more ideas, and I'm getting to explore hypothetical problems in hypothetical worlds. I don't think this is a possibility in industry setup. So so the idea is that there's a bit of a freedom in terms of what kind of problems that you would like to work on and what kind of theory that you can do. So which is why I have personally chosen to stay in academia. And while I am also interested, in looking at the different applications of auctions, I'm also interested in getting into privacy, robustness, and fairness aspects of current ML models, which is the ethical notions. And I'm also exploring explainability, and so I'm able to explore all of these things is because I have a lot of students who are doing it for me and a lot of freedom to actually do whatever I want, so which is a very nice space to be in as per me. So that's the reason why I have chosen this path. Yes.
Yeah, please.
Hi, interesting stuff. So I was just wondering, this requires, Myosin's auction typically requires that you know the distribution of the bidders.
Yes.
Have you tried using something like Vickery auctions, which are much more simpler, not as complex as Myosin's auctions?
Oh, so yeah, no, we have not. So in this particular work where we are trying to optimize the revenue, since our goal is to optimize the revenue, we have only looked at optimal auctions. But Vickery auctions, yeah, so the goal would be to maximize the social
efficiency,
social welfare in some sense, which would be also meaningful. But so yeah, we will have to design a counterpart for Vickery auctions in a multi-arm banded setting. That is still.
Thank you.
Any other questions? Yeah.
Hi.
Hi.
So I'm a little bit curious about more complicated setting for multi-agent systems. I'll try to explain what I mean by that. So right now, most operationalizations that we see of this is like some game theoretic framework where you have auction systems, voting systems, things like that, right? I was wondering where or how do we even start looking into multi-agent interactions where intellectual labor is being done? Where multi-agent interactions where intellectual labor is being done, where tasks are not so clear as it's taking an action or not taking an action, or it's discrete choices. It's more than that, where
so something like multi-agent reinforcement learning setup where there are continuous action space and
imagine an internet of agents, LLMs that are online, and I need to do a task, I can go pick one up and I can hire it to do some part of the task, and it can delegate part of the task to something else, which is coming, right? Which I feel is coming, right? How do you navigate a space where it's the boundaries of collaboration and conflict shift, right, constantly?
True.
How do you, where do you even begin mechanism design for systems like this? Because people are building agent-to-agent protocols right now.
Very interesting question. So the thing is, so there is this cooperative versus non-cooperative or mixed. So for example, there's this football, multi-agent football Atari game, right, where you have to cooperate with your team members, but at the same time compete with the opponents. These kind of games are essentially solved using MARL kind of approaches, where there are very different kind of protocols for, let's say, designing queue tables or queue learning with centralized or decentralized rewards. How do you design rewards for each of the agent that is there so that it ensures cooperation? Or how do you design it so that it ensures competition? Or do you even see the reward as a whole, or do you see the reward individually for each agent? Because if you see the reward as a whole, even distributing it among agents is a bigger task, right? So the closest to what your question tries to, I think, is the MARL setup, where there is cooperative plus non-cooperative. But having said that, it is more in the game theoretic sense, where people try to design equilibrium notions, both or even core stability concepts when it comes to cooperative, or equilibrium concepts when it comes to, let's say, non-cooperative. But mechanism design, I'm not sure, right? Mechanism design is not yet explored in a setting like that, in a much. Okay.
That cannot be the case where you have like different, like let's say I have a software task where I send it off to a software agent, and then it sends it off to a like marketing agent or something like that. Right? So these are very complex tasks. Like how do we even like start thinking about?
So when the action space is not mapped out very well, how do you really go about thinking? That's a very good question. So I am not very sure. But what I think is, it is in some sense, you have an infinite space of actions. You could build it like that to begin with. You have an infinite space of actions where these are the possible kind of things that you have. You build a largest possible set that you can, and then you implement whatever the existing algorithms are. But on the fly, if your actions keep increasing and decreasing, I'm not very sure if there is any, I'm not aware of any such literature.
So I don't believe there's like complete observability possible in settings like this. But some amount of governance should be possible, right? Like, is there some kind of like research that you can look into in mechanism design?
Governance. So governance is a very different thing, right?
I know, but like also like again empirical systems very complex social systems.
Yeah. So maybe you should have an extended conversation over coffee or tea. Any other questions? Okay, so let's thank Manisha for her presentation.
Thank you.
ACM India will give this small memento to Manisha.
Hi, so good to see you all here still. But we are not done. We have a few very important things to do. Now I'm going to request Avijat from ACM to come to the stage to tell the most important part of the whole event, essentially how to get reimbursement. Please give him a big hand. He is the one who is going to give you money.
Right. Good evening, everyone. As Moinak mentioned, I'm here for the important part of the day about reimbursements. What we do is, post-event, we will share a link to the ACM India claims form that you would fill it up. I'm just here to give you a rough idea about how to fill it up, and particularly about what to not do. Okay? So please bear with me for a few moments. Here it goes. So, well, of course, you will start by clicking on the link, but instead of the link, we also have a QR code, all right? You might want to click it up. I'll also flash it at the end of end of my talk.
Take a picture.
Well, the idea is if you attend, you get the reimbursement on the lighter side. All right. Okay. So the form looks something like this when it starts. It initially collects your bank details, your name, and so on and so forth. First, please fill in the bank details correctly. So when it says beneficiary name, it should be the name of the account or as it appears on your bank account. All right? Exactly as it appears like that. Also be sure to or double check the account number that you enter, particularly if there are leading zeros and so on and so forth. All right? I'll now describe about travel claims that are there. Then I'll go ahead with for other people, speakers, and so on and so forth. So the travel grant claimants choose travel grant as claimant as your role. Sorry for that weird phrasing. The others will choose as applicable. So if you're a speaker or an invitee or whatever, you will choose that and go ahead. The event initiative name would be ARCS. And at the end of that, you will choose travel. I mean, you will go to the travel at the end of the, let me just show you the form. Yeah. This might be a little easier. Full name as per your bank account, that's your beneficiary name. Mobile number, 10 digits, exactly. Event initiative is where you choose ARCS. Event location is, of course, Hyderabad. Your role, as I said, you could have many, but for travel grant claimants, you would choose travel grant claimant. It's all right. Bank name, your bank account number, account type, branch IFSC code. These are all critical pieces of information. At this point, you would go to travel. All right, you would select travel from here and press next. Okay? From then on, when you claim for travels, please note that your claims are against actuals and some of them are capped, as has been already told to you. So actuals means that you would need to upload your bills. Soft copies are okay. In fact, only soft copies are what we require. And you should claim for your share only. So typically, there could be a group booking for, say, train or whatever it is. Out of the total, whatever is your share is what you claim. Each one claims for himself and herself. There are two sections to the travel part. The first section is arriving to Hyderabad. All the travel for arriving to Hyderabad is put in over here. You just add up all those sums and just mention it here. Your travel date will be the first travel you start from. Usually it's the same day, but just to keep it clear. The other section is departing from Hyderabad for your destination. Again, add up all the travel points there and then upload. Add them up, write that amount, and go ahead. Once this is done, you move on to bills upload. Okay? At this point, I just have one request. Please combine all the bills into one file and upload that file. That's much easier for us to track. This is a request, so please help us. Fine. As far as the form is concerned, if my memory serves me right, about 10 distinct files are uploaded. If you have more bills, well, if you individually upload, that's something that will happen. At this point, you add up the total of entire travel and write it up over here, and then upload the bills. There is one question where you'll upload the file. Please upload it at that point. You go on, please specify your PAN And if you have a soft copy, please upload the soft copy. Finally, you will come at a declaration. You just need to write your name, full name, in that declaration. You don't need to write anything else. I, the undersigned, hereby assert, or whatever. You don't need to write full sentences. Just write your name, and that should be done. That is it. All right? Fair enough? Okay. Here is the QR code again, but let me just first continue. Again, I'll at the end of the end of this slides, I'll flash this again. For invitees, speakers, chapter awardees, and so on and so forth, there is a slight change. That's all. Most of the initial section is the same. As far as bank details are concerned, everybody needs to be careful. So, for invitees and speakers, you could also have ACM, ARCS, or annual event as a possible event or initiative. And you could separately claim for food, expenses, accommodation, and travel. Okay? And as you can see in the form, oh, where did it go? What did I do? Sorry. As you can see, you can select for travel, put up the travel details. The same question will come at the end. You can select food, put up the food details. The same question will come at the end. You can move on to accommodation. In any order, you can do this. So, this is the only real change that is there. Again, claims are against actuals, claim your share only, and bills are to be uploaded in a separate section. The comments for travel are again the same. There are two sections, one for arriving at Hyderabad, the other for departing from Hyderabad. All right. And finally, the bills upload section where you upload the bills. We request one single copy, that is all the bills in one. Total up all the expenses, upload the bills, state your PAN, definitely upload your PAN card, a soft copy. Note my words, definitely, please upload. And then, again, finally write your name. Fine? Is the procedure clear? Essentially 3 steps, your bank details, your travel, food, or whatever, and then bills upload, and statement, declaration that I am the one who's doing that. One of the things we also write there is you're not going to claim against these bills at somewhere else. But anyway, so this is essentially what you do. Any questions? Yes. The travel amount is capped for grants, as was already mentioned. If I remember, if my memory serves me right, it's up to 6,000 or something like that. So if your bills exceed that, it'll be up to a cap there. If the actuals are less than that, then the lesser amount is what you will get. No, you may not be giving the same bill to the department, right? If you are dividing your claim between department and ACM, there will be some bills for ACM will be ACM bills. That's all we need. The rest is up to you. Yes. Could you come ahead and speak a little louder? I cannot hear you. No, could you come ahead? I mean, I can't hear you well.
Am I audible now? Yeah.
Yes.
So in the travel, there are options to choose from air, road, rail, and own arrangement. I'm asking if it's a mix of these, what should be filled?
Choose one, that should be fine.
Okay.
Any other question? Okay.
Here is the QR code again for people who might have missed it earlier. people who have got it, could anybody who has looked at that QR code, it took you to the claim form link? Great, thanks. One confirmation is there. I mean, I just wanted to check the QR code works. All right? So thank you very much. That's it from my side. Over to you, Mayank. Moinak, sorry. Mayank.
Not too bad. So I would need the computer back. Thank you. Okay, so what is left is three things. First one is the announcement of 3 distinguished posters. Second one is talking about your suggestions that is there. And third one is the AMA. Essentially, AMA means Ask Me Anything, which involved your feedback and anything that you want to tell us. Just so that you know, last year, you actually mentioned the program was a little bit too sparse for you. So we tried to take that and tried to make it a non-sparse one. However, the point that I'm trying to make is that we listen to you and we try to pose ourselves as trying to solve your problem. So the AMA session will be just for that. Okay. And this is extended, right? Oh, perfect. No, ठीक है, कर लेंगे हम. So first things first is don't think that I have access to this. I understand. Okay then, fine. Some technical hiccup, so I'm just going to read out the names. So this year we decided to actually give 3 awards, not ranked, because clearly we cannot really compare TCS with systems and systems with AI. So rather, we are going to give 3 distinguished paper awards, which our jury felt was nice, very innovative, and at the same time, their presentation was also very good. I hope at least some of you are here. The part is that we'll just announce the names now, and you are going to get those soft copies of the certificates next week from ACM. That helps? Right. So the first distinguished poster award goes to Subhadeep Panda for partially blinded unlearning from IISc Bangalore. It's okay, we don't have certificates, but you should come and we should take a picture. Come. The second distinguished poster award goes to V. Divya Sharma for IndicSynth, a large-scale multilingual synthetic speech data set for low-resource Indian languages from IIIT Delhi. And the third one, the third distinguished poster award goes to Sweta for Drishti, do not forget slicing while designing glass-level cache replacement policies for many core systems from IIT Bombay. Let's congratulate them all. And currently all, so is Sweta here? Not. Okay, you two come on stage, let's have a picture. And after that, we'll just continue with the AMA for 10-15 minutes. The AMA session. The feedback, currently we have 26 feedback, thanks to you. And you really appreciated the talks, panel discussion posters, enjoyed connecting with people, that is the hallway track. PhD clinic people liked, which is really good to hear. And someone told what went well as nothing, which is a bit hard, but that's okay, I guess. The talks on how to do good research was useful. The science slam, someone just thought it was good. Now, the bad part is all went well except the accommodation. We understand there were hiccups, and we listen to you. No, we really do. But I mean, we'll take this feedback and try to actually do better. However, we hope that the problems that you raised, at least they are getting solved within some time, because that's what the best we could do. Another one was domain. Actually, there is some feedback about domain-specific 1-2-hour session with domain expert, and the poster presentation should be fixed and could have given a better time. It is possible to get is it possible to get a list of all faculty or researchers? That is on you. Like, that's why we have these tags and everything, so that you can just go there, they get their name and talk to them. So it's like, collecting Pokemon. The more you actually go there and collect Pokemon, the more connection and network you will get. Connection doesn't come from a mailing list. You can just write a scraper and basically collect our email IDs. So you should just go and talk to them. That is, we are here just to give that platform so that you can do that. And then, the considerations actually also going for the Wi-Fi, the connectivity, and so on and so forth. As we told, accommodation and this thing, we'll take care. Last time the feedback was centered on program. We fixed it. Accommodation, we'll take care that this is at the top priority. But IIT Hyderabad team, they actually handle these things with extreme precision, and they actually handled it pretty well, to be honest. However, we will do better. 12 hours of being seated seemed a bit much. It was, some events can be on 14th. Yes, I completely agree. Unfortunately, 14th is also very packed. So all the people, more 700 more who are coming, they will also sit for around 12 hours. So another option is to now have a day -1, and you will sit for 12 hours for 4 days. But let's actually stop there up to a certain extent, right? That's all. So we will, this is all the feedback that we got. Now is the time for you to talk. Can you please just get the microphone to them and see? So, first questions, I think, and I am here for sure, but also Subruk, who is basically the brain and the heart of the whole IITH operation he's here, Vijay is here. A lot of the people who actually made it possible are here. So we'd love to talk to you and listen to your feedback. Just tell your ideas. Who wants to go first? Sure. No? So no feedback? Please. Can you please give her the mic? The mic.
First of all, I would like to thank ACM. It was a well-organized event in some aspects. I really enjoyed attending. This was my first time attending. But yeah, I gave a feedback that was not addressed, so I wanted to re-bring it, I would say.
Sure.
Or maybe it is like a question to you rather than a feedback. We were invited for presenting our posters. I would just like to ask, when were we expected to be near our posters? Because the poster session was coinciding with lunch, coinciding with the 10-15-minute breaks, in which even there were times when I was standing, but there were nobody there to listen to my poster. On the other hand, I don't know, I heard people, I overheard people, I would say, commenting on the fact that students were not there when they came, but then at that time talks were going on, so we were trying to attend some of the talks that were relevant to us, which is why I was suggesting there to be a dedicated poster session in which nothing else is happening, basically. So I just wanted to bring that up.
Sure, so if that is the question, then we have the poster session right now. In fact, actually that's true. If you look into the schedule, we clear up the schedule to have the poster session till 6. So I'm going to wrap up within 5 minutes, but it's true, I'll tell you the issue that happened. The issue is that in general, the food and the poster are side by side. So we'll actually take the food, and within that time, you can just eat and quickly just come here. In this case, they are segregated. So if you look into all this refreshment plus poster, lunch plus poster, that session, it didn't really work out as planned. And for that exact reason, we scrapped a lot of events today at this end, and then I'll just wrap up within the next 10 minutes. And from now onwards till 6 p.m., we'll have the dedicated poster session. And it is already announced, sort of. But your point is very well taken. It should have been more organized in that particular sense. We have not seen that. We should plan better.
Sorry, just one more feedback maybe. The lightning talks happened, but then like if the poster sessions could happen a little nearer to the lightning talks, that would also be helpful. Because like I noted down a lot of posters I wanted to check, but then after that there were so many other events planned that I still haven't gotten, like hopefully now that you mentioned there is a dedicated poster session, maybe I can catch some of the people. But if it happened a little nearer to the lightning talk presentations, it would be a little better for even people to connect.
We'll take that into consideration.
Okay, thanks
But also,
a lot.
as you can see, the talks are actually there for their constraints and so on, but we'll take that into consideration for sure. Thank you so much. Anything else? Okay, if not, then here are the 3 things which are left. Go to your poster, people will come, talk to and go to each other's poster, because I hope that they will feed on each other's work. That is the one big reason all of you are here who published papers, right? So theory can take inspiration from systems and systems can AI, and they are already doing it, but you should go ahead. You have around 1.5 hours to do it. From 6 p.m. onwards, we'll have this, what do you call it? The Anti-Innovation Summit. And that will be the end of it. So what is Anti-Innovation Summit? Essentially, there are some crazy ideas which are very anti-innovation. They will actually come from you, and we'll discuss that. Be creative. Finally, if there is any other feedback, if not, without further ado, I would like to announce closing of ACM ARCS for 2026. Thank you so much for coming. I am, thanks, a big round of applause to ACM, our sponsors, and overall volunteers and you for coming, participating, and making it a, I would say, a reasonable success. Thank you so much. Okay, so poster session.
code level e করতে পারো, but আমি জানি তোমার requirement code level e সব problems code level. So basically, first collected all the statistical information. Let's say that you have a choice of rates. Is confined to the space of finite eigenvalues. Then what our method is the best way? Before applying for that time, she helped me a lot getting in She trained me for the interview round. She had the training. My poster go to is understanding and cigarette and cigarette goes for poster over the
all the different systems because they are machine, they have memory and speed. इसको गेम को चला के छोड़ दो, खेल रहा है बहुत सारे एक्सपेरिमेंट हमने कर लिया और ऑर्डर ऑफ मिलियंस आपको डेटा दिखा दो.
This index of paper, previous works did not have enough data for Indian language. There were some like MLAT data set was there. It covered global languages, but out of all the Indian languages, we only covered Hindi, and the division was like.
I inject fonts data. Yes, yes. Like, agent coming in a completely.
There is a trick to associate products to this persona based on the few labels, the few label data that you find, and that gives the few.
You can help me this with the definitions that will be good. Vertex cover, maps and control. Here I remember this person. It is very easy to make. What we do today as partners are there. But ours is like when we know the number of placed in. So basically from repetitivity, from shared skills.
Explain this, I think, systems. So I work in scheduling of control systems. See, like we have multiple control systems like this, and when executed in the processor as tasks, let's join the net. कैसे? अच्छा, मतलब वही usually what happens so here instead of being beyond.
One second. because everybody knows that this is the picture which is going online.
Everyone knows. Just okay. Everyone.
Everyone. Everyone.
One second. Okay. Okay.